Welcome to APEC. It's May 10th, 2025, and I'm your moderator, Tim Ventura. Thank you to everyone for joining us on today's call, along with everybody who is watching us on YouTube. We are live streaming on YouTube, LinkedIn, Facebook, I believe Twitch, Instagram, the whole 9 yards. We have a lot going on. We're multicasting this to a pretty wide and diverse audience, as well as everybody watching us on X. So I am really excited about today's call. In terms of presenters, we have some amazing stuff. George Fedorovsky is going to be introducing the Russian Society for Anomalous Research Preservation. Joel Michalowitz is going to be providing an introduction to Heim Theory. John Brandenburg is going to be discussing Microbial Life on Mars. Gary Stephenson is going to give us an overview of gravitational field propulsion techniques. And Isaiah Ritchey is going to be walking us through Searl Effect Generator Construction. So these are all really amazing things. And I want to give a big thank you to Joel also, but definitely to George Fedorovsky. He's going to start us out. He's joining us from Russia, so it is super late his time. I've been talking to George over the last couple of weeks, and really what he is doing there is similar in some ways to what we're trying to do in the United States. And so that's why I'm so pleased to have him just provide an overview of what he's doing. I connected with him looking at the Dalnegorsk UAP samples. He has been working with the researcher who was involved with that. So a couple of quick updates. So today's event is using StreamYard, broadcasting through the Alt Propulsion YouTube channel. If you haven't subscribed, please do so now. You can ask questions using the live chat feature on the right-hand side of the page. We will try and ask them to our presenters depending on time constraints. Also, you can view conference replays, details, and speaker info on our website at www.altpropulsion.com. And wait, I have two more websites for you. I am super excited to introduce you to a new website called UFORev.com. I will drop a link in chat there. It's www.uforev.com. That is a UFO reverse engineering website. And one of the reasons is a massive percentage of the folks who are involved with APEC are also into the UAP phenomena. Over the years with APEC, we have produced a pretty massive collection of reverse engineering related material. We've gone into, again, we've analyzed four or five different samples, I think, at this point. Mark Sokol is like neck deep in propulsion engineering. We have looked at two or three other approaches to propulsion engineering that are directly UFO reverse engineering related. So what I wanted to do was try and put that together, as well as some of the key UAP videos, right? The Nimitz stuff and the UAP hearings, right? Because I think it's important to have those kind of aligned with what we're doing. I wanted to put all of that together in one place. I'm really excited. It's UFORev.com. It has a separate mailing list. If you want to sign up for that, that is totally cool. We don't really have an event in place for that yet, but we are looking at doing some stuff there. So take a look at that one. Also, I absolutely want to mention that our friends over at the Scientific Coalition for UAP Studies are doing their annual conference. That is next month. I don't have the dates in front of me, but I believe it's something like the 7th or 8th to 10th. So it is kind of the beginning of June. I would highly recommend checking out explorescu.org. And if you're able to get to the Huntsville area, I was at last year's conference. I will post a link to the photos that I shot there. It is an amazing event, and they are doing real diligent science, and they are trying to unravel the UAP phenomena. So that's it. That's starting out. So let's get to our first speaker, George Fedorovsky. Again, Russian Society for Anomalous Research Preservation. He's going to talk about the work that's being done by RUSARP over the last few years. He's going to talk a little bit about the history of Soviet research into anomalous phenomena. So he is researching both UFOs as well as parapsychology. So just be aware that this goes a little bit outside of what we normally cover, but this is kind of the scope of what he's doing. And again, one of the things that is so exciting is Russian culture and Russian history has a pretty massive body of research into these areas, and that really has not had much exposure in the West. So if we are able to build bridges between these two cultures, maybe we can compare notes, and then everyone would benefit. Okay, so let me bring George in. George, welcome, sir.
Thank you for having me, Tim, and welcome everyone. Hello. So back in
Yeah, well, George, I can hear you fine. So why don't I do this? I will still be here in the background, but I'm going to take myself out and take it away, sir.
Yeah, thank you. So back in already several years, we started to conduct meetings in Moscow, discussion club to discuss all kinds of paranormal phenomena which we try to investigate and research. And further on, I stumbled across a few mentions of Soviet researchers, and I thought to myself, like, well, there've been done plenty of research in this field back in the day, 40, 50 years ago. And I thought, what maybe someone already collecting this kind of data about Soviet research. And yeah, there was several people who've been doing it. And I've been able to find some people who've been busy with this in Moscow. And what's interesting is what it's really is a huge amount of different fields which were researched in Soviet times, and we tried to conduct all kinds of people. We tried to collect all kinds of archives and materials which we can locate and find. And we've been busy with it for around, already, I would say, 6 or 5 years. And I have to mention what one of the main things for which were very interesting is Sweden's archives for unexplained. That was like one of the inspirations for this project which we run, and with more years, let's say, like, right now we started to digitize all kinds of data we've been collecting. Like for the last 2 or 3 years, we started to digitize the things we collect, and it was quite. It is a quite complicated task, which took a lot of time, and we're still doing it today. It is not an easy one, and we've been trying to find more archives to be able to digitize them, and I'm receiving some materials for for quite a few for quite a lot for quite a lot places. We already stuck everything we can with them, with this all the papers and tapes and everything else. What's interesting about it is Soviet research began back in the 20s, 1920s, and it's quite it was mostly parapsychology. It was mostly parapsychology with the help of psychiatry and medicine till let's say till 50s and 60s. They've been investigating mostly telepathy, and already with starting from 60s, they tried to investigate telekinesis with Ninel Kulagina, and there've been quite a lot of things what were said about it, about this phenomena, and I should say what Kulagina won. She won at the Soviet court. People were trying to say what she's a fraud, and she proved what she's not. And what interesting is, even for many academician scientists said what her phenomena is actually real, well, it's still a huge debate to this day. So people still. I even heard from some of the American colleagues what it was a disinformation, which is not. It is not disinformation. It was a real person, and many real people who've been who've been investigating and researching her. I've been able to meet them and spoke with them, and you can actually find some of the materials on the internet. And even last Kulagina's last of Kulagina, she died in the end of 80s, 1980s, and you can find some of the TV recordings from back in the days. And moving forward is, I would say, there was a big movement of, let's say, conducting special clubs. Special clubs were conducted, which were at first you can say what it was like a club for enthusiasts, but it was mostly special. It was mostly special places for scientists. You needed to prove yourself to attend, and these clubs they were scientific societies. It was all called Scientific Society for Popov Technical Scientific Society. So it was a huge web of these clubs, and it was basically a start for many anomalous research programs back in the Soviet days. At example, many of the tasks of Setka, if some of you remember, there were a big Soviet program dedicated to ufology and researching of all kinds of flying saucers and things like that. And they were located at first. They were located at these clubs. Well, at least some of the members were active inside these clubs, and they were investigating all kinds of phenomena again, as I said, and not just parapsychology, but as I said, ufology. Also, they were visiting crop circles. They were visiting people who claimed to be kidnapped, abducted, and so on. They've been collecting. Well, most of the job, which were ufology back at the Soviet times, it was collecting messages. So you collect. So if you have, let's say, as a special department, they were able to collect messages from people, and they wasn't the only ones. Later on, there was a commission for anomalous phenomena in Moscow. Later on, there was a Ajaja and Ziegel and so on. But the main thing is it was collecting messages from the people who saw something, who heard about some ufological event, let's say like this. And later on, people started to move to the expeditions, expeditions to the alleged places of landing of the UFOs. I can show, if you give me a second, some pictures we've been able to find. Give me a second. Okay.
Okay. And George, let me see. Let me know if you need help sharing. If you need help sharing any of those.
Yeah, I see what I can share.
Okay.
Yeah.
Yeah, and if you run out of content, we can open it up for Q&A as well.
Yeah.
It's
Can
totally up to you.
Can you pick up the picture?
Yes, I can. Yes, I'm sorry about that. Okay, yep. I'll just put them up as you add them then.
Yeah, the interesting thing is this. This is the very first, well, one of the very first expeditions towards the alleged place of UFO landing. And as you can see, it's just they were in regular citizen clothes. They just this group of scientists, they were organized by Ziegel It's I believe it's 1978 or something like this. I believe so. And yeah, it was quite a complicated task to conduct back in the days. It took a lot of power from the people who conducted it, and it was very risky because well, it's quite a new field, and it's a very specific one. You know, people were criticizing it actively, and it was basically quite dangerous from the uh, bureaucratical side of view. Yeah, and this kind of expeditions they became like a tradition. People started to gather gather around uh, and look for this kind of places, you know, like where someone said what UFO landed there or something like that, and all kinds of you know paranormal hotspots, as you say in English, and yeah, that's quite an interesting part of history, which is forgotten mostly today. Most of the people on this picture already died uh, quite a long time ago, and we've been able to collect this picture, this photograph uh, from one of the ufologists who's still around, who's still alive. Uh, he got to be around 87, I believe, right now. And yeah, so after they collected this data, they've been releasing special books. You know, the thing is to exchange information with each other. It also was quite a complicated task to do, and people were doing not just personal letters, but also, as I said, books, self-made books, which called samizdat. You may find many mentions of this kind of self-made books in the internet, but they mostly about they mostly non-scientific, and here um, it was quite unique because uh, it was completely towards ufology. And what interesting thing is also they've been trying to translate uh, American and European books. It was also just not exactly legal, so it also was very, very risky. And this whole topic was connected with big risk for participants of such events. And yeah, that was quite interesting period of time. Further on is uh, let's say already in the 80s they started to conduct more open uh, clubs, for ufology, and Ajaja and Ziegel, who's the father of Soviet ufology. They began to gain more. They started to be more popular in Soviet society, and people were making songs about them and all kinds of things. But the interesting thing is they both were involved in the program I mentioned earlier, Setka. Setka began in 1978 with phenomena called Petrozavodsk Divo or Petrozavodsk miracle, let's say. And it gained a lot of attention from Soviet government. And what interesting was they very fastly conducted special, let's say, special commission to investigate these phenomena. And honestly, to these days, there's a lot of discussions about Petrozavodsk Divo, Petrozavodsk phenomenal miracle. Why? Well, because there's quite a lot of proofs what it was, actual military experiment. And from other point of view, many people say what it's not exactly that. It's actually something anomalous, what it's actual UAP, as we say today. And well, if we look at this from that point, what happened is, yeah, I will show you a little picture right now with some of the events which took place. Yeah, so here you can see from the left, it's how it looked like. So that was the phenomena. Because back in 77, at the September 77, this phenomena occurred. And this was some of the results, some of the effects of this activity. And well, yeah, people still debating was it actually something anomalous or not. But if you ask me, I won't say what it was, 100% military experiment. I heard from some people what it was actually something anomalous, but again, it's a thing for debates, and you're free to form your own opinion on this matter. Yeah, and that was Setka. Setka began with this Petrozavodski phenomenon, and as I said, already at that time there was these clubs which I mentioned, and Setka were communicating and working together with them. And as well with the all kinds of special units they created. I will show you some of the pictures as well. Yeah, here it is. Yeah, so here you can see one of the field trips of the of one of the people who belong to the Setka group, to the military part of it. From the left, you can see Colonel, one of the people who were running, some of the investigations in the program. And on the right, you can see Eduard Yermilov. So Yermilov, he was one of the main researchers in Setka. Well, at the beginning of this program, he created a special, he created special guidance for investigation fields. Places where allegedly UFO landed. And yeah, they've been running this program till the 1991 or 1992. So till the very end of the Soviet Union. And later on, there were some other programs which were doing similar research, but it's already more modern than the time period we discussed today. So if we're coming back to parapsychology, it was also taking it turns, yeah, it was also developing back in the 80s with probably much more power because it was a little bit more appropriate for most of the institutes. And yeah, they've been having lots of different institutes, but there was never a singular united program for parapsychology like there was for ufology. And that's some of the interesting parts I can notice today if we're talking about development of anomalous research in Soviet times. And what interesting thing is if we're talking about parapsychology, it's very good question who started this psychotronic race, or as we as some people said, psychotronic war? It's a good question because back in the 60s, some of the people in CIA, they were concerned what Soviets conducting parapsychology research, and at kind of at the same time, uh, at the Soviet uh, government, they were concerned what Americans starting to uh, to research this field. And in Soviet times, most of the parapsychology were conducted in official institutes, and it was mostly a scientific field. It was mostly a scientific field which involved many people. Uh, well, let's say, in my opinion, there's almost every institute in in Soviet in Soviet scientific system were involved in this kind of research and investigation. Um, and they were investigating all kinds of stuff, like psychics, clairvoyance, and remote viewing as well, and many other things. Yeah, that was quite a huge attempt, and as I said, it wasn't united by some singular program. It was many different laboratories and institutes who've been running this. And I can say what maybe some of the main powers were probably in Siberia. Um, let's say what I will show you a picture in a second.
Okay, sorry about that. Is this the Ilcor image? I want to make sure before I put it up.
What do you see?
Sorry, what is the image? Let me put it up. Is
Yeah, this
that
one.
one?
Yeah,
Okay, I'm sorry about that.
yeah. So yeah, it's okay. So that was one of the main Siberian attempts to research this kind of phenomena. It wasn't just parapsychology; it was a lot of different topics, but mainly it was towards the uh, parapsychological fields, and more like a multidisciplinary field. Uh, they were running a very interesting program under the Tomsk Polytechnic Institute, and later on, uh, we've been able to, myself and my colleagues, we've been able to meet with some of the people who've been involved in this research. Uh, and I should say, as I said earlier, it's quite huge. It's quite huge, and people were there were many people involved in this program, And on this picture on the right, the group of these scientists. This is 1985, and these people, they gathered in a special group to investigate a poltergeist case, but not just regular flying objects and other stuff, but they were interested in phenomena of ball lightnings, which occurred to manifest in the apartment building they were investigating. Yeah, it was the beginning of this program, but the very name of the program you can see on your screen, Siberian Scientific Research Center, it was at the end of the Soviet Union. They started to go under this name, but they conducted quite a lot of work. They had quite a wide web of different, wide network of different groups were working under this organization. And as well, what I should mention also is very interesting person who sadly already not with us today, but it's yeah. Tim, can you pull it up, please? Yeah, this one. Yeah, thank you. Yeah, so Казначеев, Vlail Казначеев, it was one of the main figures in Soviet and Russian anomalous research, parapsychology, bioenergetics, biophysics, ufology, and he was an academician. He created back in the Soviet days, he created a Siberian branch for the Russian Medical Academy, and further on he created the Institute for Experimental Medicine, for the experimental medicine, and under this institute and under the Siberian branch of Russian Medical Academy, Soviet Medical Academy, they been basically running this huge program dedicating for paranormal research, anomalous research. As I said, they had a huge network towards many cities and towns and villages in Siberia, and they conducted many expeditions in many different paranormal hotspots, as we say today, and they've been able to collect a lot of data, and some of the data they published, and some of the data been published by late Soviet and Russian scientist Yuri Cherednichenko. And interesting fact about him, Cherednichenko, he were friends with many American researchers and with famous Siberian let's say researcher as well, Viktor Grebennikov, with flying let's say with the special flying cabin or something like that. And yeah, it was quite, as I said, it was quite interesting. It was quite an interesting research conducted back in the days. And if we're talking for times, if we're talking for today times, well, as far as I know, well, Kaznachev died back not very long ago. Kaznachev died 11 years ago. But the thing is, he was conducting his research till the late 2000s, and I believe till his death. I think he was still doing something a year before his death. But either way, they were conducting research in 21st century, and as well in Moscow and in some other Russian cities. They were doing all kinds of experiments. But nowadays in Russia, nobody really call it parapsychology, and the same as in Soviet times, nobody really use this kind of term, this kind of words, because it's more of a Western words. And yeah, it's also interesting topic how people in Soviet and Russian origin call this kind of studies, and biophysics, bioenergetics, and everything else. But the thing is, as I said, they've been running them till the till his death, basically. And still nowadays they have an institute in Siberia, in Novosibirsk, in the city of Novosibirsk. They still running some experiments. His group is quite active, one of the most active groups in Russia nowadays. And if we're talking about ufology, well, ufology, it was mostly, well, nowadays ufology is mostly conducted in Ukraine. There's a very productive group, Zond, with under the leadership of Artem Belik. And in Russia, there's well, there's few groups who conduct ufology, but they are more of a local groups. They mostly all have ties to Cosmopoisk, which exists to this day, and I should give a special note of the Belarus. Um Belarus is mm, Belarus. They have right now one of the best, or maybe the best. I don't know. Groups to research all kinds of phenomena, but they doing it in mostly. Uh, they doing it in mostly uh, uh, folklore folklore studies. They collect mostly people what people say about phenomena. So yeah, and uh, our group, we what we do is we collect, as I said, we study the people who who conduct all kinds of interesting things, and yeah, that's uh, that's what our group doing. We are planning to launch a website soon, but nowadays we have a Twitter account. Uh, I will share. I will share it in a second. Yeah. Give me a second. Yeah, I'm sorry for a little pause here. Yeah. So yeah. If anyone interested in topic of the Soviet research, of the Soviet anomalous research, we're, as I said, we're planning to launch a website soon, uh, which would gather all the data. Well, some of the data we've been able to digitize right now. We've been working to um, digitize some of the archives. Um, some of the archives we've been able to collect lots of, as I said, papers, tapes, and other media which have this kind of Soviet investigations and research. But the main thing is it's never ending, and we still finding more and more groups which were active in Soviet times. Yeah, so again, I'm sorry for this kind of rushed and spontaneous presentation, but that was that happens sometimes. So yeah, Tim.
Yeah, yeah. No, George, thank you so much, man. Thank you so much. Again, I mean, you cover like a really broad spread of different phenomena and research and things like that, right? So it's not just UAP centric, but I guess what I should mention for folks watching is we connected over the Dalnegorsk samples, and if you're open to it, and we can plan this in the next few weeks, you mentioned being able to potentially translate for the principal investigator there. So that is an area that you cover. But then the other reason I'm so excited to be able to have you like participate in APEC is so that people are aware of the work that you're doing. And so they have the x.com RSARP underscore OSI, right? And so they can visit you there. They can reach out and connect with messages that way. The other thing I want to do, let me share my screen. I'm actually going to share that page, and okay, there we go. Yeah, and so this is the actual account. I do not want to give your email out, right, in open channels, just
Yeah,
that gets
yeah,
scraped. But the other thing I dropped earlier was you did an interview a couple of years ago, and so if people want to learn more about
it
it,
is.
I've
Yeah,
dropped a YouTube link to that as well. So thank you so much. And again, like if you have new technical data, we talked about doing like something with Dalnegorsk. We can follow up on that.
yeah. Speaking about Dalnegorsk and 611, it's quite again. It's the same that the Petrozavodsk. There's people who say what it was military. Uh, some people say what it was actually something phenomenal, and it's not a principal researcher who I have, but there's few people. There's actually a lot of people who've been investigating, including Americans and Japanese who visited this place, who visited this place of this event. And I know few people from Siberia who've been involved in this research. Uh, Again, I can discuss with them, and we can try to invite them.
Absolutely, absolutely. And actually, since we're doing that, let me share this tab very quickly. We are almost at the top of the hour, so I will make it quick. I created a photo gallery on my Flickr account. You contributed some of these images. Philip Mantle was kind enough to send some as well. And then Mikhail Gerstein. And so
Yes.
these are images, and a lot of these are old, manual photos, right? So it's,
Yeah.
again, this is what your organization does. You guys preserve anomalous research data like this.
Yeah.
So
It's a
thank
work. It's a work of several people. My picture, the only picture which I provided is um, the picture with actual photo of the some of the pieces from this place, from the spot of the event. And it's good what you mentioned, Mikhail Gerstein. I I have to mention him as well. If you have any interest in Soviet ufology, in this very last one is mine. So if you have any interest in Soviet ufology and in Russian ufology and in ufology in common, Mikhail Gerstein is um, exactly the person you're looking for. Uh, he's great. He's great,
you.
great, great.
Yeah, and I believe actually, and again, we're at the top of the hour. I think I have a photo of him. So this is the plaque on the lower right. Actually, I believe I have a couple of photos of him. I think that's Mikhail right there,
No,
right?
no.
Oh, okay.
That's
Oops.
that's the guy who's been investigating this phenomena his whole life.
Okay.
He
Okay.
he died a couple years ago.
This gentleman, I believe he
Yeah, this
he was
guy.
the principal
Yes.
investigator. Again,
Yes.
Dalnegorsk happened in 1986, so it was a ways back. But again, this is what you do. You are
Yeah.
preserving and sharing this data. So let me put your tab back up for just a second. If anyone wants to connect with the Russian Society for Anomalous Research Preservation, if you want to reach out to George Fedorovsky, again, building bridges, sharing data, right? And this is how we can all work together to create the future. So George, thank you so much, man. Thank you so much.
Thank you for having me again. Quite quite a busy week. And I should say, not
Yeah,
not the good time. Not the
I
good
know.
time. I'm sorry.
Yeah. Oh,
Not
no
the good time.
worries. Okay. Well, so we're at the top of the hour. So what I'm going to do is I'm going to stop sharing. Before we do that though, I'm going to burn a little bit more time here. I got to bring everybody in. We need to give, this is traditional APEC. We need to give a giant applause to Mr. George Fedorovsky. Sir, thank you one more time. I almost forgot my applause. That is our tradition because we appreciate it. We absolutely appreciate it. Okay. And now Joel Michalowitz. So we are drilling down on Heim theory. I don't even know where to start. You have a massive amount of stuff. So I have an overview that I can read here. Yeah, so basically this is kind of the opening talk of a Heim theory series. You have a ton of information. You're talking about basically where the boundaries of mainstream physics meet audacious geometry. This is the history of the research of Burkhard Heim. Some of that was incorrectly cited in Wikipedia. I should mention that. Another thing I should mention is you are actively building upon and extending this research. And so this was a theory that was popular. It was worked on for decades very quietly. You have picked this up and you were working with a few key people to extend this. So let me hand it over to you and, let me know. I will be here. Again, I'll turn the camera off. And again, Joel Michalowitz, thank you again so much, sir.
Yeah, thank you very much for having me here. And I think APEC is just the right conference to introduce Burkhard Heim, because he started out. So now the slides are not working. Okay, they are. Sorry. Okay. So first of all, yes, we are starting to reconstruct Heim's theory and trying to bring it into the international audience, because so far Heim's theory only exists in the German language and in a very inaccessible German language as well. So two disclaimers. First of all, English is not my native language. I'm quite good at it, but especially when it comes to Heim theory, there's a lot of terminology that is quite special, and I even have trouble in German. So it's going to be really fun to bring this into English. Also, there are a lot of philosophical terms, as Heim theory goes beyond a standard physical theory. Heim theory is one of the few theories that aims to derive physical reality from first principles, namely geometry, logic, and semantic structure. Heim theory is not a theory among others, like we are used to in the modern physical landscape. It's a structure theory of reality, a formal account of how phenomena, matter, and law emerge from deeper semantic geometry. It can calculate. So Heim, out of this framework, produced a mass formula that can actually calculate and predict particle masses without free parameters, and also derive the fine structure constant. We are here to reconstruct time theory and hopefully to build on the formalism. So we want to do this in modern mathematical and semantic terms, because there has been a lot of development since Burkhard Heim actually passed away in 2001. And building on this, especially here in APEC, we want to evaluate how this could lead to measurable predictions out of Heim theory, and especially novel technical applications, right? Novel propulsion systems. This is something that Burkhard Heim himself also started on. Like in the beginning of his theoretical work, novel propulsion ideas, going beyond chemical reaction mass dependent propulsion systems, was one of his goals. So I'm using a lot of complicated terms like modal geometry. I'm going to explain this now. Modal geometry is not just geometry with extra dimensions. It is geometry whose shape and content depends on logical permission. And already here we see that Heim theory is something else. So we can see here an overview through the presentation, but first let's have a look at the actual worldview of Burkhard Heim. So Burkhard Heim poses that our three-dimensional space is embedded in a six-dimensional, is part of a six-dimensional material side of the world, in which there are three more dimensions. One of them we already know, it's the time dimension, and we are quite used to it, but already the time dimension in the R4, right, description of Burkhard Heim is special. It is not Minkowski space. Minkowski space is already a special case of this R4. So the theory is very complicated. And if you only get a surface level look at it, it's very easy to misunderstand and misinterpret the theory. So I highly encourage everyone to go beyond the surface level description that I'm able to give you here in 1 hour. And even if we do more presentations on Heim theory, like we want to do, you will need to read also some of the material we are trying to bring into the English speaking audience. And you will also have to do your homework on some philosophical terms and ideas, because Heim theory goes beyond. So in this presentation, which we will see how far we will get, this presentation is pretty long. It's already structured that I can split it in two separate presentations. We will go and have a look at the biography of Burkhard Heim to be actually able to understand what happened there. Who was that guy? What did he do? Why did he do it? How was he able to do it? And why has nobody ever heard about it? Which is also very relevant. So we're going to look at his childhood, his education, and an accident in 1944 or 43. We're going to see it that shaped his future life. We're going to then look at his academic path and his independent work. We're going to have a look into the philosophical frameworks which underlie his theory. Again, his theory is a structure theory, and in my opinion, it is the first real try to have a real ontology. So yes, a real description of the world, not just try to describe some phenomenal interactions like particle physics does today, but something which goes way deeper than this. So we have to talk about Hedwig Konrad Martius, who actually met Heim and laid some of the philosophical underpinnings while Heim was working on theory. And they actually didn't do this side by side talking to each other, but they met and found that they actually kind of did the philosophical and the mathematical, logical two sides of one coin, you could say. So this is based on model logic and stratified ontology. The foundations of Heim theory are quantized geometry and the metron. The metron is, we're going to go in detail later. Selector fields and modal logic. The synchrometry and the final manuscripts of Heim. So in the second part of the presentation, I'm going to go through all publications and what they introduce. The synchrometry is the central work of Burkhard Heim, I would say. And the whole framework can only be understood if the synchrometry is understood and fully applied to the whole framework. So to give you a grounding first, the S6 formulation is already going way beyond the standard model of modern physics today. It is the unification of general relativity and quantum mechanics, and it is strongly formalized. I would even say probably completely formalized, with one key ingredient still missing: how to bring the observer into it. Heim worked very hard to build a strong foundation from which he could formalize how this R6 is embedded within the whole R12. But in my current understanding, and based on all the publicly available documents from Burkhard Heim, this was never completely formalized. There are a lot of gaps and a lot of stuff that is hinted at but not completely structural formalized. And in my current interpretation, this is because Burkhard Heim lacked the mathematical tools to actually formalize deep insights and intuitions that he had. And I do think that today we might actually be able to realize it if we bring a lot of different stuff together. So syntropy, which is, entropy. So this is the inverse of entropy. He brings something in which is not entropic, but syntropic. And maxime telecentric and televariance are keywords. If you do not understand syntropy, maxime telecentric, and televariance, you will not understand Heim theory. Formal logic and semantic convergence. So from Heim theory, in my perspective, you can derive three different kinds of novel propulsion system. The dynamical contrabarré, a model oscillation drive, and the syntropic collapse bubble. This is my wording at the moment. So the syntropic collapse thought in Heim theory, if you have a complete syntropic collapse, then you have the equivalent of a black hole in the standard physical model. So, and if, like we know from the ER equals EPR conjecture, here is something, right? Wormholes, black holes, and there is something there, but mainstream physics is not even able to fully understand the black hole. Heim theory is able to understand this better. So this is very interesting. Also, when we see the slides, like this is speculation now, this is not fixed, but I think the syntropic collapse bubble realized as a propulsion system could lead to the generation of real mass, which would be a byproduct of using the drive. So when we see UAPs dropping and leaving behind stuff, real matter, here could be an explanation for that. So let's start with his childhood and the early genius of Burkhard Heim. So the pictures are taken from an autobiography of his wife, Gerda Heim. This is Heim with his grandfather, who was a big early influence. His grandfather was a teacher and highly educated, and Burkhard Heim, from a very early age on, was a very interested child. And he always liked to ask questions, really tough and hard questions. And his grandfather was one person who really liked to answer those questions. His father was a high-ranking bank official and had also a good formal mathematical training. He was raised in a warm family environment and had early exposure to astronomy through books like Bruno Bruegel's book From Distant Planets. At age 6, he was already able to memorize star constellations, and he knew the names and even sometimes their position, even if they were not visible in the sky. By 8, he taught himself more than 10,000 Chinese characters to write in secret code, which he could do as fast as stenography, right? So he could write in this self-derived language in very high speed. But with the age of 6, he also had to start school. And this is when Heim learned that not all people are as friendly as his grandfather, and not every environment allows free thought. So he was very fascinated early on with chemistry, physics, and explosives. At 10, he received a chemistry set and began to build actually explosives. Yes, so he went to a gymnasium from 35 on, but was very bored with the standard curricula of the school, and also had a lot of problems with bullies and other kids in school. By 11, he manufactured TNT by himself and was quite good at it and did it in a quite safe way. And he actually built rockets. And so we need to take a step back and actually ask ourselves, what time was that again? Yes, that was before there were any rockets. The V1 was not built by then, but Burkhard Heim, 11 or 12-year-old child, actually built a rocket, which he actually, even with an explosive charge in the tip, which he launched over the Templina Lake, and it blew a big hole into the ice sheet on the lake. So he performed explosive pranks at school with self-built explosives and even tear gas he manufactured himself to get back at teachers and bully students. And he did that actually more than once. And at first, nobody knew that it was him, but he got caught and expelled from school at 14 years old with bad notes in chemistry, math, and physics. He dreamed still of becoming a chemist, but he didn't want to continue a formal school education. He just started to read and study on his own and grab every physical book and paper that he could find, and chemistry, of course. He started to author some essays and he started to actually write some stuff down. And I actually think that some of his ideas might actually start here. So he authored an essay on electron path formation, which he showed to a professor who saw the potential in Heim and convinced him to finish school so he could later go to university and study. His parents find a suitable day school, but Heim is bored there. And he enrolls in an evening school where young people who just finished college are teaching. And he didn't even tell his parents about this evening school. In the evening school, Heim gets treated as an adult and on the same level for the first time by the educational system. And he even starts an affair with a biology teacher. And after reading Otto Hahn's paper on nuclear fission, I think that was 38 or something, he starts to work on a concept for a nuclear rocket. And I think this paper started the process in his mind that there needs to be something beyond chemical propulsion. There needs to be other energy sources. There needs to be other forms of propulsion than just use a reaction mass. In 1942, he transfers to the Gabbische Lehranstalt Berlin. This is the alternative private evening school. And he passes his Abitur 43. I'm not actually sure if the 42 number is correct. He might have gone there earlier, but it's actually very hard to verify informations on Heim, because there's like actually just 2 kind of biography works and then a sci-fi book from I think 1956 or something, which includes some of the real biographer of Burkhard Heim, because it is based on his propulsion drive. So after he finished school, he has to do compulsory labor service. We are in 1943, right? In the end of the Second World War. So he gets drafted, like everyone in that age has to, into the Wehrmacht. So in this special case, into the Luftwaffe, the Air Force. He actually had training in, I think it's paragliding in English, like a plane without a propulsion system. So he was a kind of a pilot, and he was trained in Luftwaffe to be a pilot, but he never flew a mission. He was then stationed briefly in Italy, but felt deeply that he had to get out of there. So he tried everything he could to get into safety. So he wrote to Berlin about his ideas of new explosives which could reach higher temperatures and could be used in propulsion, or maybe as a weapon system as well. Those were heard, and he was reassigned to the Chemisch-Technische Reichsanstalt in Berlin, and he even got a high rank. I don't remember the exact term, but it was very unusual for a guy of his age to have this kind of position. But this is when an accident struck on May 19th, 1944, in the Reichsanstalt, the Chemisch-Technische Institut in Berlin-Tegel. Heim was developing a novel high-energy explosive, theoretically intended for future rocket propulsion concepts or weapon technologies, and an accident happened. He actually just used 1/10 of the explosive he wanted to use, and that saved his life. A termite mixture detonated prematurely during the experimental handling, and immediately a massive explosion in the laboratory environment struck Heim. His arms and both hands were completely ripped off from like this position on. He had severe facial trauma and progressive deafness and partial blindness, which in the beginning he was almost completely deaf. This got better over his lifetime. And the blindness also, it got better. But in the beginning, he was totally blind. Then for a short period, he could see in the infrared. And then his eyesight kind of normalized on one eye. Kind of. It's never completely, of course. The survival was only due to immediate first aid by a physician who was randomly present at that day. And also because actually Burkhard Heim, he felt a tickle and touched his neck here when the explosion happens. And this probably saved his life. Otherwise, his neck area would have been probably injured severely. So the consequences of this are permanent physical disability, no ability to manually write stuff down, to actually read papers, or to typically communicate with people, especially in groups, because he had only partial hearing on one ear, especially in groups. He was not able to follow discussions or to discuss stuff with multiple people. This got better over time. He also got hearing aids and stuff like that, but especially in the beginning, this was very bad. So he was forced to complete internalization of his mathematical work, do mental calculations and visualizations. So here you can see Burkhard Heim already a big step into his reability. Maybe I should mention, because this is actually written down in Gerda Heim's memories, and there are more than 20 hours of audio tape from Burkhard Heim, which are accessible on the Burkhard Heim Discord. That is new, and also to this, the Burkhard Heim Discord is meant as a bridge. So there are people on this Discord who are part of the original Heim work group. So they actually worked with Burkhard Heim, and they worked with Illobrand von Ludwiger, who did a posthumous Heim work group, working on his material and publishing posthumous a lot of his stuff. So yes, let's go on. From 44 to 46, he was mostly in the hospital or in the parental home in Goslar. And there are many months of surgery and uncertainty. He was almost blind and begins the process of many operations. He had suicidal thoughts in that time, and a lot of time with himself. So he asked himself some basic questions. Will I ever be able to get back into normal life? And this includes stuff like, will I manage on my own, for example, on the toilet? Can I hold a soap? So like the basic necessities which would allow him to come back to life. But he comes back from this in an extremely strong way, saying, yes, I can, and actually making a crazy life happen. So after the recovery, he enrolls in chemistry at the University of Göttingen. The university is not that pleased because it sees the high challenges that Burkhard Heim and his conditions imposes on the institute. But Heim tries to resume his academic life. He soon has to realize that chemistry study is not the right thing for him anymore, as he has, because of his impairments, he has to internalize all the stuff. He cannot work in a lab. He cannot handle stuff. So he starts to focus more on theoretical physics. In late 48, his father, Heinrich Heim, returns from Soviet war captivity and moves in with the family. He becomes Burkhard Heim's daily assistant. He is reading to him physical textbooks aloud, and he is writing down equations from dictation. So the family support of Burkhard Heim was really amazing. Without this, all the later success could not happen. Then in 1948, Burkhard Heim meets Gerda Straube in Nordheim. She was working as a secretary at the Max Planck Institute. Heim was, this is in the next slide. Yes. Okay. So this is important. She works as a secretary at the Max Planck Institute and is immediately impressed by his intellect and his resilience despite his injuries. She begins assisting Heim daily, reading aloud, taking dictation, helping edit early physics manuscripts, and also with the stuff he has to do for work. They marry. Gerda Heim becomes his closest scientific collaborator and lifelong personal support. From 1950 onward, Gerda, and as you see here, this is also interesting. Burkhard Heim was actually able to travel and participate in life also alone. Like, he was not as excluded from public life as one might think. So Gerda types all his scientific manuscripts, including equations dictated from memory, right? So Burkhard Heim is dictating his work from memory, and then there's like a proofreading, and it goes back and forth. So she reads physics literature aloud every day and manages the correspondence, helps with theoretical proofreading, and creates a stable environment that enables Heim's uninterrupted research. She remains by his side for over 50 years. In her memoir, she writes, I was his voice, his hands, his bridge to the world. So to jump a little bit back in time, the academic career. So you see here, Heim already met Gerda when he begins to study theoretical physics in 1948 at the University of Göttingen. And he attends lectures of Pascal Jordan, Max Born, Werner Heisenberg, and others. But as you can see here, those are some very key names in quantum mechanics and Pascal Jordan general relativity. So he had some of the brightest minds of physics and mathematics as his teachers. And the whole study was only possible because of the help of his father and Gerda Heim. They actually went with him to every lecture, and they wrote down the lecture and later narrated the lecture again for Heim. And when Heim had to write something for university or so, his father or Gerda would have to write it down. So it was really, Heim's study was already a group effort, you could say. 1952, he initiates the formal development of a unified field theory, and he presents preliminary work at scientific meetings. The concept of the metron, a smallest surface, which is real, a quantized surface element, is already present. Heim wishes to submit this work as a doctoral dissertation, but no professor agrees to supervise this project. This is very interesting because we see this actually multiple times in history, that there are great minds with great works. One example would be Hermann Oberth, right? He would be also very relevant for APEC. He actually wanted to write a dissertation about his rocket science, right? He is the father of Western rocket science, and he wanted to write a dissertation about it. But same as Heim in 1952, I think it was in the beginning of the 20s, like, I don't know, 21, 22, something like that. I think he published in a book because he didn't find a professor who actually agrees to supervise the project. And this is kind of forecasting what will happen to Burkhard Heim. So in 1954, Heim completes his Hauptdiplom in theoretical physics. During his oral, it was just an oral examination, like multiple oral examinations. So during his oral examination in tensor calculus, this is important because tensor calculus becomes really important in his later work, delivered entirely by dictation, and examiner remarks, he owns the equations better than we can read them. In 1954 to 1956, he works at the Max Planck Institute for Physics and Astrophysics in Göttingen under Professor Carl Friedrich von Weizsäcker, and he engages in his own gravitational field theory on the side, and has to depart from the institute because he is not able to work in a group. He cannot see what people are writing on the blackboard. He is not able to participate in group discussions. He can only talk to people one-on-one. He cannot really read all the physical papers. He needs someone to read them to him. So group work just doesn't work with him, at least not in a classical sense. So, yes. Now we're coming to the really, really interesting hype that was in the 50s. And this is similar to the hype that happened in America and maybe other places. So the G drives are coming, right? This is the time frame. 1952, 1955, Heim proposes his first formal concepts for field propulsion based on a modified gravitational metric structure. He publicly describes a spacecraft propulsion system using field geometries and eigenvalue effects. This draws interest from German aerospace circles and the Max Planck Institute. 1957, Heim's work appears in early issues of popular science press, including reports in German magazines like Bild, Der Wissenschaft, and aerospace trade journals. In 1958, first public lecture on the Heim field drive is presented at an International Institute event. So this was an event for, I think for rocket science or something like that. So no publication follows due to skepticism from the institutional physicists. And 59 to 60, Heim completes the design of a theoretical propulsion capsule, but this is just a design, okay? This is not, there's no real drive inside, at least not to my knowledge. Newspapers, including Stern and Bild, run front page spreads on Heim as the next German Einstein who will bring us to space. So wonders will become reality. If you see down here in the right corner, who is going to be the first is the question, okay? That's posed here. And as you can imagine, not publishing his theory in scientific papers, not presenting his theory on in physical congresses, but speaking about it openly and in such a way that you get this kind of press, that really pissed off the mainstream science people. So he gets a lot of attention from media, from press, also international attention. Werner von Braun was very interested in his works. And I'm not sure if Hermann Oberth reaches out to him in this time already, but Hermann Oberth is very interested in his work in later years. Hermann Oberth became actually quite old. I think he lived, I think even completely through the 80s, if I'm not wrong there. So Hermann Oberth and Heim met, I think, so for sure they met in the 70s. I'm not sure if there was earlier engagement between them, but Hermann Oberth was really interested in what Burkhard Heim was doing. at least by this time. But Werner von Braun definitely was interested in what Heim was doing and was requesting material on it. For NASA, right? He was in America at this time already. So this article claims Heim's capsule design could reach Mars within weeks and the Moon within hours, using pure geometry instead of chemical thrust. This propels Heim to national fame and even some international fame. He is invited to private military briefings and consulted by aerospace engineers. Also, many remain highly skeptical. In 1961, Heim presents a closed technical briefing at the Deutsche Forschungsanstalt für Luftfahrt, the German Institute for Aerospace stuff, I don't know, proposing that gravity is not a force, but a projection effect of modal zone structure. And again, this terminology might seem highly abstract, but if you go into it, it becomes more clear over time. And it takes some time. Like my first interaction with Heim theory is now more than 5 years ago. And I'm just starting to really realize what Heim theory is in the last months. From rocket dreams to national recognition, Heim's early timeline. Again, let's have an overview. With the age of 6, he was fascinated by the stars and wishes to sometimes travel among them, memorizing star constellations and so on. In 35 to 1940, he's building working models of rockets and propulsion nozzles. At the age of 15, he sketches interplanetary ships and dreams, of a Mars expedition or to go beyond the Earth, right? In 54, he begins building internal geometry models of selector-based propulsion. In 1960, then he is recognized in the German public press as an innovator in gravity research. So let's clarify some stuff about his framework. Heim theory is a geometric semantic framework grounded in tensor geometry and quantized surfaces. The quantized surfaces is the metron, right? Model logic and selector fields, discrete operator structures, and syntropic, not entropic, right? Syntropic convergence. This is something definitely new, right? What it is not. It is not a theory of subjective consciousness. It is not a metaphysical speculation or a spiritual worldview. It is not a relativist or postmodern construction of knowledge. All constructs are defined within a stratified quantized geometry over an R6 base space, grounded in operator theoretic rigor, while the extension to the R12 remains incompletely formalized. This limitation is well understood and explicitly treated as an open problem. Heim pursued a formal and ontologically committed reconstruction of physical reality. Heim's logic layer is semantic, but strictly in a formal, structured sense. There is no anthropocentrism and no idealism in it. So let's take a step back to fully appreciate what Heim did and to understand where he was coming from and why that might actually be the way we have to go in our modern time. So the forgotten assumptions, physics without metaphysics. Since the time of Galileo and Descartes, science made a strategic assumption. We shall describe phenomena, not reality. We completely exclude metaphysics and only focus on real material phenomena, which we can measure and then make large lists of values on which we can apply the highly sophisticated tool of mathematics, right? This was never a discovery. It was a methodological suspension. It was a bracketing of questions. It was not the resolution of those kind of questions. But this actually happened so long ago that over centuries, this operational assumption hardened into ontological belief. There is no metaphysical structure. only measurable patterns. This is the dogma of modern physics. Fields, forces, particles, abstract models on metric continua. No structure to the act of observation, no ontology for consciousness, semantics, or causality, no structure for the act of observation. You can even say no structure for the particles, right? What are point particles? What is happening? Heim refused this shortcut. He asked not only how fields interact, but how they come to be and how they are selected. So let's look at this through Plato's cave and the shadows of science. In the allegory of Plato's cave, prisoners are chained inside a cave, facing a wall. Behind them, real objects pass before a fire, casting shadows. But the prisoners see only the shadows, surface appearances, and mistake them for reality. Modern physics, having banished metaphysics, often studies only shadows. Mathematical models on manifolds, instrument readout and statistical effects, ignoring what projects the shadow and who watches. Heim's work is the act of turning around. What is the source of the projection? What structure selects what appears? Instead of treating observation as neutral, Heim models the semantic conditions that give rise to fields and causality. So Heim is kind of the way scientific self-knowledge can mature. So Heim showed us the way, right? Mainstream physics rarely asks who observes or what is the structure of the observer's cognition. It kind of, it excluded those questions into a realm of it's not even allowed to ask this kind of questions to physics today. But every experiment is framed by conceptual assumptions, linguistic selectors, and cognitive thresholds with logical commitments. Heim recognized that a physicist who does not study their own mind is using an unknown tool to measure unknowns. In Heim theory, observation is not passive. It is a modal selection. Fields emerge not from equations alone, but from the semantic geometry of the observer. Physics becomes self-aware, grounded in both logic and lived structure. Heim did not just extend physics, he deepened its foundation. He brought physics back into a dialogue with reality, meaning, and the act of knowing. So, to understand this better, we have to see at the other side of the coin is, I think, easily accessible, better accessible than the mathematical rigorous formulation that Heim did. So let's have a look at the philosophy side of the coin first. So Hedwig Konrad Martius and the ontological foundations of Heim theory. Hedwig Konrad Martius lived from 1888 to 1966. She was the first female in Germany who got a PhD and was allowed to teach in philosophy in the university system. She was a phenomenologist, real ontologist, and a colleague of Husserl and Stein. She developed a stratified ontology of reality, which has three things: a Stoffbasis, the material substrate, a Wirkbasis, the domain of causal effectiveness, and a Sinnbasis, the domain of meaning and purpose. Heim built the counterproduct, and we will see later what that is, emphasizing that reality is not just experienced, but structured in layers, each with its own modality of existence and lawfulness. In 1958, Burka and Gerda Heim actually visit Konrad Martius in Starnberg. In her book, Gerda Heim writes, Burkhardt suddenly had the idea to contact the Munich philosopher Hedwig Konrad Martius. The conversation between the two of them quickly turned to how his physical ideas could be interpreted within an ontologically expanded system of thought. She was astonished at the structural parallels. So again, they developed this without knowledge of the other developments. And then when they met, they kind of saw, oh, you're doing the other side of the coin of my work. Heim did not derive from her system, but their meeting revealed a deep resonance. The modal layers of Martius are the modal dimensions in Heim, so the x5 and the x6 dimension. So if we speak about dimensions in Heim theory, we have to open our mind for new kinds of descriptions about what a dimension is. So we kind of understand the space dimensions, and we kind of understand Minkowski space, and in this framework time. But it gets more complicated with the x5 and the x6, and more abstract. I think this is the most important part, more abstract. So a Kaluza-Klein or stuff like this, that doesn't work, okay? You need ontic strata, a polymetric tensor, and selector logic. So what is a polymetric tensor? Poly is just many, right? So many metrics. While in general relativity, you only have one metric to describe reality. In Heim, you have a polymetric, so multiple metrics which are interacting. And Heim developed one metric for each of Hedwig-Conrad-Martius basis, right? One for the Stoff basis, one for the Wirk basis, one for the Sinn basis. So in Conrad-Martius ontology, it is an ontological stratification of reality. Reality is not flat. It consists of structured layers, right? The stratification is important because this is how Heim also structured his theory. It is stratificated, if you can say that. So each structural layer has its own laws of manifestation and modality of being. So the Stoff basis, the material substrate, matter, extension, quantity, the work basis, efficacy and process, causality, force, dynamic relation, the Sinn basis, meaning and teleology, directionality, order, intentionality. So in Heim theory, there are a lot of terms which are derived by the meaning of the word itself, like theologically. Telos is a word that Archimedes already coined and used, and it's like the end purpose that is intrinsic to something, right? So we will build on this. Each layer builds upon the former, but cannot be reduced to it. This is very important. So science must uncover not just behavior, but ontological function. So Heim's model geometry and selector logic is the implementation. He implements his philosophical layers with the 6 spatial dimensions, the Stoff basis, the spatial substrate, the causal angular time, die Wirk basis, and the modal structural dimensions, die Sinn basis. The selector field determines which layer, and the selector field over the metron lattice, right? So you have the metron as a quanta of surface, and out of this quanta of surface, you have a 6-dimensional lattice, which is the base space of Heim theory. And on this metron lattice, everything happens. The selector field on the metron lattice determines which layer becomes active, just as in real ontology. Only certain structures emerge at certain ontological levels. Heim's approach answers the call Conrad-Martius posed to give science an ontological backbone. So, ontology in Heim theory. Structured reality from model logic. Heim's ontological commitments. Reality is model, stratified, and quantized. Defined by logical constraints, not spatial extensions. The metron is a 2D quantized surface. And you can see here is kind of like the Planck area. There's internal discussion if we just should call it the Planck area. But yes, if you wanna participate in this discussion, join the Discord. Space is built from surface elements and not from points or substances. Fields do not exist on their own. They are generated by a selector logic under model permission conditions. Ontology is layered and structurally sequenced. There's a zone on a selector and an observer projection. There's no absolute stuff, only quantized activations structured by eigenvalue logic. Matter arises as the eigenvalue realization of a geometric selector configuration. Causality is not force transmission, but modal accessibility, whether a transition is allowed. Space is not a container, but a projection surface constructed from modal structure. So, there are even more philosophical depths and resonances to the works of other people. Burkhard Heim was aware of Hedwig Konrad Martius. Like I said, they met, and I also think they stayed in contact till Martius passed. But there are other philosophical, deeply theoretical works that can be mapped on Heim theory, and I don't even know if Heim was aware of that at his time. But again, I think so all of this happened before the internet. This is a very important part. The information space was just not as open, as fast as it is today. And also there was not, the computers were not as good, right? And definitely there was no large language model which you could ask, hey, can any other philosophical work map onto this? So today we can have a unique position and a bird's eye view of many great and deeply explored theoretical frameworks and try to bring them together. So Heim's ontological zones reflect her Stoff, Wirk und Sinnbasis, like I said. Then there is Nikolai Hartmann. He developed model ontology and emergent layers. And Heim's model strata parallels Hartmanns Schichten and Seinsmächte. Then there is Roman Ingarden, who developed ontic moments and potential being. Heim's eigenfields are structured, not yet realized potentials, awaiting modal resolution, echoing the work of Roman Ingarden. And then there's Whitehead. Relational process metaphysics. Modal transitions in Heim theory can be interpreted as structured, actual occasions in Whitehead's sense. So to clarify again, Heim's model is not idealist or phenomenological. Model zones are not constructs of the minds, okay? Heim maintains objective realism. Selector logic is the structural precondition of field realization, not a psychological condition. This protects Heim from subjective or relativistic misuse. And again, I'm doing this because on a surface level, Heim theory looks like a lot that it's not, okay? You have to really go into it. You have to understand that the formalization is not complete and that you cannot just interpret stuff into it which is not there. So we will treat this with ontological precision and the scientific responsibility that this great work deserves. Heim theory is not subjective or mystical. It is a real ontologic. It is real ontological. While engaging in deep ontological structures, it is grounded in formal logic, discrete geometry, and quantized field operators. Misinterpretations that should be avoided is idealism, because the modal zones are not generated by thought. Constructivism also doesn't work because Heim's laws are not cultural artifacts. And also, the syntropy is not a spiritual force. It is just the inverse of entropy, right? It is a geometric semantic gradient in the other direction of entropy. Heim theory aims to be rigorous, testable, and ontology of structured physical reality, not a belief system. So let's get to some fun part before the time is over and talk about the three propulsion systems, which I currently see within the Heim framework as a possibility. Okay, so let's talk about the term dynamische Kontrabarie or Kontrabarie in general. Kontrabarie comes from the Latin contra, against or anti, and the Greek baros, weight. which could be also mass. So counterbaric is kind of an old school term for anti-gravity. First coined by Burkhard Heim in 1959, maybe earlier, but 1959, he published in this Flugkörper magazine. I have some over there, maybe I show them later. The article about his Contrabarry effect and the propulsion system based on it, right? He described a theoretically predicted state in which gravitational interaction is internally neutralized via field geometry. So, yes, Heim proposes that in certain polymetric field configurations, internal modal zones could reach a state of tensional symmetry. This results in the cancellation of effective gravitational coupling, or in inertia mass reduction. We could also term it like that. The zone behaves as if mass were reduced or reprojected. In Heim's framework, the Contrabarry effect is governed by the alignment of selector zones. The polymetric operator Ci forms an eigenvalue geometry under modal boundary conditions. The dynamical form arises when temporal selector phases align such that modal tension counteracts inertial participation. So this arises because Heim has a polymetric, right, and not just one metric. So the different metrics can interact with each other. Heim's intention, originally explored as a theoretical propulsion principle, was not really pushed further in later works due to a shift in focus to mass spectra and metaphysics, and also because the effect is not really big as we think today. And also Heim, look, he developed his theory, right? So it was not there in the 1950s and 60s in a complete form, but he actually did some mistakes on the way, like you should do. If you try something really, really hard, then you should do some mistakes on the way. Otherwise, it wasn't really hard, right? So in my perspective, by 1959, he thought the effect would be bigger than he later thought, and we believe today. And so the application to an experiment would have been easier, right? To show you some equations, and I know this is by far not enough to understand what is happening here, but like I said, we are working actually on bringing this in a formalization and into English papers and so on, so that you guys can understand. We're also trying really hard to optimize AI systems to translate the original audio files and the original lectures and the publications of Heim. So you have a formal condition where a polymetric field tension and a modal tension from selector gradients lead to an effective inertial or gravitational curvature. If this condition holds, the region becomes inertially neutral. So you could reduce the inertia of a system, you could reduce it down to 0, and you could maybe reduce it to a negative value. In the zone, the model geometry cancels curvature participation in spacetime, a literal contrabarry. So, experimental opportunities. This is an early slide on this. I have an accompanying document which I'm gonna give the APEC group, and we can also publish this. It is toward experimental validation of Heim theory. It goes a little bit more in depth to the framework, and it poses experimental ideas. This is just the first draft, and it also states that this will be an ongoing effort, and it will be refined when I get feedback or when we actually see something, and so on and so far, and when we're actually able to understand and formalize Heim theory better in the future. So to test this concept, we have to look for EM field configurations that couple to model selector analogs. Oops, I'm not here. search for anomalous reductions in inertial response or gravitational interactions, modulate field gradients and torsion symmetries dynamically. And what we need to measure is weight anomalies in toroidal field shells, variations in inertial mass under high frequency modal tension, time variant collapse signatures from centropic gradients. This drive is geometric. Propulsion emerges from modal cancellation, not force. And it also doesn't have a reaction mass, right? So Heim drive type 2, the contrabaric oscillation drive. This is what Dröscher is working on, right? He will be introduced later in the presentation, but as I wanted to put the 3 drive concepts in the first presentation, so yes, just take it as it is. So this is a contrabaric oscillation drive. Heim and Dröscher extension, and probably Dröscher extension, Dröscher-Heuser extension today, proposes that polymetric field curvature can be modulated dynamically. If done rapidly, inertial reference frames within the R4 base space become locally distorted. I think I said the S6 is the base space, right? I think that was incorrect. In my current understanding, the R4 is a base space, okay? What that actually means, this is a discussion, maybe your own presentation, maybe a paper or something like that, but okay. The result of all this is acceleration from within the field zone without Newtonian reaction mass. The mechanism used here uses oscillating external fields to trigger modal transition within polymetric zones. Can express it like this, where K of channel mu is the polymetric tensor governing model structure, model curvature. So selective field fluctuate under controlled excitation, which could look like this. This affects curvature via polymetric dependence, results in inertial and gravitational properties oscillate locally. And you would drive it by a cycle, right? So you would activate modal oscillation at resonant frequency, induce time varying curvature, capture net displacement through asymmetric geometry, and then reset, phase, and repeat, and hopefully move in the right direction. So towards a lab test, and I know I'm going a little bit over time here, so Tim, just feel free to stop me at any moment if you want to. Let's construct an oscillating high Q field cavity with toroidal symmetry, apply synthetic selector modulations via electromagnetic pulses or phase plates, use superconducting layers to isolate modal zones from classical leakage, and hopefully see mass fluctuations. And the slide is not working. Yes, Tim, I think it's stopped. It says it is the last slide, but it actually isn't.
Yes. So it's telling us that it is that time. Well, we're about 5 minutes over. So Joel, this is amazing. Man, I am so excited that you are starting to like unravel and showcase and again extend Heim theory. This is one of those that needs more eyeballs on it. It needs more minds on it.
Definitely.
Right? So
it needs more minds on it. So please post the Discord link and make people aware of this. This is like seriously an invitation to everyone, because Heim theory at a large framework goes beyond physics.
Well, before we close, do you have
scientific field can participate.
Do you have a website or contact info that people can use? How can they get in touch with you?
So far, actually, the Discord would be it. You can look at heimtheory.com. There's a lot of material, but I'm not the owner of the website. And it's also not a, So at the moment, Discord is the best way to get in touch with me. I'm gonna derive a private email address for this maybe.
Okay. So let's do that. We are just about out of time. So what I'm going to do is bring everybody in here, and oops, let me take down the slide deck. And again, that's only partial. I mean, you could have gone for another couple of hours. So thank you so much, man.
Probably.
So let's do this. Let's put our hands together and give Joel Michalowitz an enormous applause. Yeah, again, man, absolutely amazing and well overdue. So Heim Theory needs way more attention.
I totally agree, and like it is a shame that the German university system has not formally put someone onto reconstructing Heim theory in a mathematical formulation that is accessible by today scholars of physics and mathematics. This is something which definitely needs to be done, and that it should have been done a long time ago. But we are in the now, and we have to work from what is the current stand. And again, like we want to reconstruct before we try to go beyond, and we want to be very careful how and if we go beyond.
Yeah. Well, Joel, again, thank you so much, man. So I'm going to go to John Brandenburg next. I'm cruising right along. I'm going to take everybody back out here. Okay, sorry about that. Mr. Brandenburg, you have been sending me updates. Did you upload your slide deck?
Yes, I did as a PDF. Oh.
Okay. Yeah, and let me see. I'm not seeing it.
Okay. Well, here, let me see if I can bring it up as just a presentation then. And see
Okay. Yeah, if you want to share it, you can. I believe you can. Yeah. So click the share. Click the share screen button. And again, the only reason I'm pestering you is because if I upload it, then you have to do the previous next thing. So.
Sure. Okay.
Unless it's named, is it named Ilcore through X5? I don't think so. No, that's something else.
No, it shouldn't be. Here, let's see if we can. Okay. Did you see anything? Okay, here, let's hit share screen.
Yeah. And it will bring it down the bottom.
Slides and PDFs.
Mm-hmm.
Okay. So I'll go share screen. Okay. Then I just go present. Okay.
Yeah. So present slides and PDFs.
Okay, slides and PDFs.
Yeah. And then your computer.
My computer.
Yeah. And then it's going to ask you to select which PDF.
Oh, okay. Okay, let's see. Okay. Oh. Okay, it's uploading. Okay.
Yeah, looks like it's something just changed. So I think it's.
Okay, perhaps it's too large. Okay, wait a minute. Here we go.
There we go. Perfect. And now,
all right. Now
delay.
This is an expansion on and a continuation of a discussion I began last week, just an open mic. So this is a much more thorough exploration of what I found. And basically, friends, I believe that the the days of us being alone in the universe are ending probably this year. And I've submitted a article to a journal on this very subject I'm going to be briefing here to you today. I believe, based on that planet 120 light years from here, KB, something, the oceanic world with the two dimethyl sulfide kind of derived molecules in it, which are put out by plankton. So this has a hydrogen atmosphere and an ocean and a and what looks like large amounts of plankton. And of course, the planet is in the habitable zone of its star, so it has Earth-like temperatures. So, but closer to home, we have the planet Mars, where we have an enormous amount of data. We have rovers roving, we have meteorites there, and we're going to talk about the discovery of microbial life on Mars. I believe the case can be made. We've now reached critical mass to say definitively there was and is life on Mars now of microbial nature. And the reason I decided to just focus on microbes is because that's the Straits of Dover. Basically, that's the simplest form of life on Earth, aside from viruses, but a simple form of life that has metabolism. And we have the most data suggesting that. So I want to talk about that today again, and I'll get started. You guys know me as somebody who normally works on gravity and advanced propulsion, but you must also realize that all of our propulsion yearnings are yearnings to be able to travel beyond the Earth's atmosphere into space, into other planets, other stars, is motivated by who we think we will meet there. So here we go. The discovery of microbial life on Mars, which I believe can be now made definitively. And if it's not discovered here, it'll be discovered on this planet 120 light years from here. So the age of us being alone is going to end. Okay, I'll be talking Mars data, planet that we know the most about. Mars data suggesting microbial life has reached what I call critical mass. And that's a collective judgment where you have a bunch of data or a bunch of things interacting with each other, and they reach critical mass. Early Mars versus early Earth. We'll talk about organics on Mars. Their meaning. Mars 1976 life experiments re-examined due to Gil Levin. Mars seasonal variation in oxygen methane. Abiotic and biotic sources of organic chemicals. We'll discuss that. And inductive proof of life on Mars. Inductive rather than deductive. Codifying Occam's razor. Occam's razor is an inductive argument. It says we have a number of things and they could all have various explanations, but there's one simple unifying explanation that explains all of them. That's Occam's razor. And that's how court cases convict people on circumstantial evidence. Then we will do a summary and a conclusion. Whoa. That's not supposed to happen.
Yeah. Is this a PDF or a PowerPoint?
This is a PowerPoint.
Okay. This happens with PowerPoints. Do you have a PDF version that you can upload?
Sorry. I'm used to doing PDFs. Okay. Well, here, I'll just talk to it.
Okay. Yeah. If you want to push through it.
Circumstantial critical mass and a body of circumstantial evidence. We're talking forests here rather than trees. Deductive reasoning, that's looking at the trees. Does it have bark? Does it have leaves or needles or something like that? But if we're talking about a collective system, then that's a forest. Now, on Mars, we do have one rule. If we find one single microbe on Mars, then Mars is essentially living. If we have a rover with that scoops up some soil, maybe moistens it and looks at it under a microscope slide on the rover and sees one protozoa moving around, that means Mars is alive. So that's the one microbe rule. Okay, early Earth versus early Mars. We know that early Mars had a magnetic field. There's big chunks of magnetized area on Mars. We know that Mars had liquid water and had an ocean. That's been confirmed. And by the way, I was the first person to propose that. And we also have, we know that Mars had organic matter that was formed in the nebula, in the hydrogen-rich nebula that Mars condensed out of. So we have, in fact, meteorites on Earth that are 4.5 billion years old, the age of the solar system, and they're full of organics. So we know that abiotic biosynthesis actually occurred in the hydrogen-rich nebula that formed the solar system and its planets. Now, what does this mean if early Mars and early Earth had the same conditions? They were basically identical: liquid water, magnetic field, lots of organics, same composition, same rock. Scientifically, Mars should have had microbial, if life appeared on Earth, never mind the details, we're just talking phenomenology here. If life appeared on Earth with early Earth conditions, then it should have appeared on Mars also. There's nothing special about Earth. That's the principle of mediocrity. There's nothing. Earth is just another pebble in the cosmos. And so if life started here or appeared, let's say here, it should have appeared on Mars also. That should be our scientific opinion. Now, we have a bunch of meteorites from Mars, one that is 4 billion years old, or we now have a couple, ALH 8401, and we have some that are intermediate age, 1.4 billion years old, and we have some that are very young, which are 0.2 billion years old, and they all have organic matter. They all have water deposited minerals in them, and those minerals contain organics. We have also found at 2 different sites on the with the rovers organic matter in the Mars soil. So this idea that Mars doesn't have organics put forth by the Viking team based on the Viking landing experiments 50 years ago, that's completely blown out of the water now. Mars is the home of organic matter. Now, and it wasn't just organic matter from one stage of Mars geologic history. It's a whole range, ranging from very old to very young. So Mars has not only organic matter, but it's persistent and formed in various ages on Mars. Now, in 1976, a half century ago, we landed on Mars with the Viking expedition, and we did life experiments. They carefully sterilized the spacecraft before they landed, and they gave the life experiments by the criteria they had established before they landed, gave basically positive results. But they found something confusing. They found unexpected superoxides and peroxides in the soil. Superoxides are chemically unstable in the presence of water, kind of peroxides on steroids. And I'll be discussing those in just a minute. So superoxides and peroxides are things you find in rocket fuel as oxidizers. And peroxide, of course, is a disinfectant. Superoxides are the same way. That seemed incompatible with life. So the experiments, to make a long story short, were ruled inconclusive. They moistened the soil and it gave out all this oxygen, indicating superoxides. That's a typical of superoxides. And so they thought, gee, if we add organic matter and it gets oxidized by these superoxides, puts out CO2, that means it can look like it's metabolizing the nutrients, so it can look like life. It looks like metabolism. So they ruled the experiments were inconclusive. However, this was protested by Gil Levin, and he based this protest on the fact that he had collected samples from very Martian parts on Earth, like the Antarctic dry valleys, and he found there were spores, like 5 spores per cubic centimeter in these Antarctic soil samples, and they matched, when he used the Antarctic soil samples, he got matching results with the life experiments. And then we've also found that at a place called the Atacama Desert, driest place on Earth, as you can see here, it looks very Martian. You can have superoxides in the soil. That is, if you add oxygen, you add liquid water to the soil, it immediately breaks down and releases oxygen. So Gil Levin was able to show that the results on Mars were actually quite compatible with life. And knowing Gil Levin, I've met him in person or before he passed, and he was a very vigorous fellow. An example, by the way, of having oxides, superoxides or peroxides formed on Earth by biological systems is the bombardier beetle. It makes hydrogen peroxide, which is used as an oxidizer for rocket fuel, in its gut. And if you make it mad, it points its behind at you and shoots out a rocket blast of hydrogen peroxide mixed with another chemical with which it reacts, and it makes boiling hot steam. It makes a steam jet full of noxious, full of kind of a tear gas. So this is the bombardier beetle, is an example of biological systems making what is normally considered something that is very toxic to biological systems, hydrogen peroxide. And if you put hydrogen peroxide in soil, like from the Atacama Desert, you will get superoxides. Now, they've also found that there's bacteria, we could call it bombardier bacteria, that make superoxides in Atacama Desert and other desert type soils. And they do that in a reaction to drying out. If they go through a real dry spell, they start making these superoxides as a way basically to get rid of oxygen from photosynthesis. Oxygen for plants, they need very little to support their metabolism. So what they do is oxygen is basically a waste product for photosynthesis, photosynthetic bacteria. So if it's very dry, rather than exposing their own cytoplasm to excrete this oxygen, they excrete it as a solid superoxide. And this is what sodium superoxide looks like. If you add water to it, it breaks down and releases a bunch of oxygen, just like they found on Mars. And it's the same color as the Martian soil. You wouldn't notice it. And here is frost at the Viking landing site, indicating that there were periodically wet periods on Mars, and that would have destroyed the superoxide, so it had to always make more. So what could have made more superoxide in the soil? Biology. We also have evidence for Mars photosynthesis, seasonal oxygen and swamp gas, methane. If you look at the oxygen levels, they track the sunlight in various areas on Mars. When there's a lot of sunlight, you get more oxygen. Oxygen is the fourth most abundant element in the Mars atmosphere. And it it goes up when there's a lot of sunlight locally in the local atmosphere, and then the local summer, spring and summer, and then you reach, of course, the a summer solstice on Mars that has seasons like the Earth because it has the same axis tilt, and the oxygen peaks there when the peak sunlight occurs, and then starts to decline as you head into Martian autumn, and then finally declines completely in the middle of winter. Now, oxygen is an unstable molecule in the Mars atmosphere due to the ultraviolet, so you have to constantly renew it. And also, then you have methane. Now, methane would be driven by bacteria, biologically would be driven by bacteria in the soil. When the soil warms up and you have permafrost that melts, then you get more methane, which is Martian microbes breaking down buried organic matter to get energy out of it. Now, on Earth, of course, we know that the peak temperatures of summer do not occur at the summer solstice in June in the Northern Hemisphere. They occur in August. So there's a phase lag between solar warming or sunlight peak and the actual warming of the soil. And we observe that in the methane. The methane increase lags by about 2 months. The photosynthetic oxygen. So you have peak of sunlight, photosynthesis, peak of photosynthesis. Then you have a peak of temperatures leading to metabolism of microbes in the grounds and melting of permafrost in the Martian soil that leads to more methane, and the two show a Earth-like phase lag. So, more evidence for microbial life on Mars. Now, what color would plant microbes, photosynthetic microbes, and lichen, let's say, which is just a colony of photosynthetic bacteria on rocks, what color would they be on Mars? They would be red. I live in Oregon, and that's where I grew up. We would go to the coast. The seaweed that would wash up on shore was not green, it was red, because Oregon being farther north, the seaweed wouldn't get as much sunlight. So what it would do, it would the seaweed adapted to this by adding a red dye to the chlorophyll complex that would capture green light. If you look at the solar spectrum, especially on the Earth's surface, it peaks in the green. That means all the green life, the green plant life you see is actually throwing away, it's reflecting green. That means it's throwing away the most intense part of the solar spectrum. But if you have a place where there's not much sunlight, like near the mouth of a cave or under 6 feet of water, then the plant life turns red because it wants to absorb that green light. So Mars lichens could be hiding in plain sight. We could be looking at lichen on the Mars rocks and we wouldn't even notice it because it's the same color as the hematite and the superoxides in the Martian soil. Now, we also know that Mars is red. Deserts on Earth are red. Here's the Sahara Desert on Earth. As you can see, it's a bright red. It's red because the soil there has been exposed periodically to water and to a lot of oxygen. And that makes the iron oxidize in the lava rock when it comes out of a volcano is black due to ferrous iron oxide. It gets oxidized to form hematite. It adds another oxygen, goes in the +3 state, and it's bright red. It's rust red. So that is the color of deserts on Earth where there's no cloud cover or vegetation or water is bright red. And Mars, and that's because of oxygen in the Earth's atmosphere. On Mars, Mars is red for the same reason, because of hematite. And if you look in the Valles Marineris Canyon, you have layers and layers and layers of red rock. It's not just oxidized on the surface, it is oxidized to depth. Same thing in the Grand Canyon on Earth. If you go down, the top layers of these sediments are all bright red, and then they suddenly turn black because that marks the demarcation when the Earth's atmosphere suddenly started having oxygen as a dominant gas. So Mars is red. And there's only one way to make that much oxygen, and that is plant life. Plant life runs on visible light. You can make oxygen with ultraviolet by breaking down water molecules or carbon dioxide. But if oxygen is created by UV, and you start creating a lot of oxygen, it immediately creates an ozone layer, which, guess what, blocks the UV. So it's self-limiting. However, plant life can make a lot of oxygen and make an ozone layer. And since plant life makes oxygen via visible light, it can be a self-serving situation where the plant life is making its own ozone layer to protect itself from the UV. And it's not self-limiting. You can get a lot more oxygen in the atmosphere from plant life that runs on visible light than it does on ultraviolet, which is ultraviolet photolysis. So the redness of Mars, especially the oxidation of the Martian soil to depth in the Valles Marineris that is seen, and also the exposed sediments seen by the rovers, indicates that Mars had a lot of oxygen from an early age on Mars. Now, why is this important? Well, let's just say that Mars, being farther from the sun than Earth, and also when the sun was young, it didn't put out as much light. So that means you had to have a greenhouse on Mars to have temperatures and, of course, atmospheric pressures to have liquid water. And in fact, a liquid ocean, I'm the first person to propose that ocean, by the way, though they never give me credit. I'm what's called the Voldemort of Mars. It's he whose name must not be mentioned. And so if you have CO2 in the atmosphere and liquid water, this forms carbonic acid, which reacts with lava, which is iron. A lot of it is iron silicate to form sand. It forms silicon dioxide quartz and what's called siderite. And the CO2 then disappears very rapidly into the soil. Carbonic acid is an acid. The It reacts with the lava. We know there was a lot of lava on Mars. And so you end up with big beds of carbonate. However, and of course, then what happens? The CO2 level goes away in the atmosphere. You lose your greenhouse. Mars goes into a deep freeze, but that's not what happened. Mars kept warm temperatures almost until the present geologic age. You find a lot of very young terrains on Mars, few craters, and they show abundance. They show that rivers and lakes used to be there. So what happens? Why does this carbon dioxide reaction with the lava to form siderite and sand not destroy your greenhouse? Well, as it turns out, if you have oxygen, large amounts of oxygen in the soil, I mean, not in the soil, in the atmosphere, oxygen reacts with siderite. Siderite is ferrous iron oxide, iron carbonate. So what happens is the siderite combines with oxygen and decomposes into hematite and releases the CO2 back into the atmosphere. So it recycles the CO2. So in order to have a stable greenhouse on Mars that lasted for billions of years, you have to have a dense oxygen atmosphere. And of course, what would that leave? A lot of hematite and hardly any carbonates. And they've done a lot of examination of spectra from space of the Martian surface. Mars carbonates are very rare. They expected to find thick layers of them because of the past greenhouse. No. They don't find a lot of carbonate on Mars. It's all hematite. In other words, oxygen has attacked the siderite and freed the CO2 to go back into the atmosphere. Okay, now we've discussed finding organic chemicals on Mars. People are fond of saying, well, that doesn't indicate life because you can always make organic chemicals without biology. And on Earth, we can make organic chemicals can be created in a hydrogen-rich environment. Organic chemicals can be created in the hydrogen-rich nebula, abiotically. The early nebula that formed the solar system planets was rich in hydrogen, and it created a lot of organics with ammonia, methane, and water vapor, and plus hydrogen. You can make complex biological molecules, so that you can do it without life at all in a hydrogen-rich environment. Or on Earth, you can make biotic chemicals in a whiskey barrel by fermentation. Life makes organic molecules all the time. By the way, you've never heard of Jack Daniels being harvested out of sandstone on Earth. That is, if you find biological deposits on Earth like oil, petroleum, coal tar, Jack Daniels, it is all biologically produced. There's only been a few exceptions. Now, people showed, Miller and Urey experiment showed you can make organics with electric discharges. So all you need is lightning and an atmosphere, but the atmosphere has to be hydrogen rich. It has to be full of hydrogen, methane, ammonia, water vapor. The Jupiter atmosphere, it has to have an atmosphere like Jupiter. Earth's atmosphere, early Mars and early Earth atmosphere did not have Jovian type atmospheres. Both Earth and both Earth and Mars had, the best they can come up with is they had atmospheres of carbon dioxide, nitrogen, and water vapor from the very earliest. The hydrogen can't be, the Earth's gravity is too weak, so is Mars, to confine hydrogen. The hydrogen just goes out into space. It's lighter than air, it goes to the top of the air, and ultraviolet hits it, breaks it up into atomic hydrogen, it's lost to space. At the same time, ultraviolet breaks up the methane and ammonia and even the water vapor into hydrogen, and that escapes. So you end up with an oxygen-rich atmosphere on an Earth-like planet like Mars or Earth. And while you can make abundant biological molecules in a Jovian-type atmosphere, a Jupiter-like atmosphere of hydrogen, methane, ammonia, water vapor, if you put in carbon dioxide and nitrogen, water vapor, and spark it all day with lightning, you can't make anything. It just doesn't work. The oxygen released by the discharges, when you break down like carbon dioxide or water, attacks all the organic molecules and eats them up, turns them into CO2 and nitrogen. So you have to have a hydrogen-rich atmosphere to make organics. And that atmosphere was not present on Earth or on early Mars. They're too small to confine hydrogen. Early Mars and Earth did not have Jovian atmospheres. So when you run the Miller-Urey experiment with volcanic type emissions, carbon dioxide, nitrogen, water vapor, you don't get anything. You have to have a hydrogen-rich atmosphere. Now, that doesn't stop people from making organic molecules by without life. The Nazis used this to make synthetic fuel production to produce diesel for their tanks. Here's a Tiger tank. They kept those running till the very end of the war because they were making synthetic fuel, hydrocarbons, by what's called a Fischer-Tropsch process. And but that itself was a well-regulated industrial process, and it required hydrogen-rich atmospheres to react with carbon monoxide, and that made fuel oil plus water. So even if you want to make synthetic fuel, if you want to make organic matter on Earth now without biology, you have to use a hydrogen-rich environment. That's the laws of chemistry. And the problem on a terrestrial planet like Earth or Mars is the volcanoes, is the oxygen is the most abundant element in the rocks. So it's automatically, you can't confine hydrogen in the atmosphere. It just drifts out into space and it's lost because the gravity's too weak. And what you're left with is oxygen-rich molecules, which eat up your organics as soon as they're formed by breaking them down. So if you don't have hydrogen-rich environments on Earth or Mars, you cannot make organic matter. And how likely is that? Well, if you're losing the war on both the Russian and the Western fronts, the Allies have landed in Normandy and the Russians have overrun Poland, then you make oil any way you can. But that's not Mars. There was no industrial plants on Mars using Fischer-Tropsch processes. Abionic organosynthesis is possible, but it requires hydrogen-rich atmospheres, not early Earth or Mars. One must assume special circumstances for abiotic organosynthesis in nature. You have to figure out some way to make a lot of hydrogen on Mars and keep it around. And you can't do that on Earth. And you can't do that on Mars because Mars has even weaker gravity than Earth. Oxygen is the most abundant element in Earth's Mars crust, not hydrogen. So your chances, so it is always less likely, it is always a fortuitous event on Mars where you could make organosynthesis because it requires hydrogen. Now, we have a rule for looking at large bodies of data and trying to explain them. And this is similar to what is used in court when you have circumstantial evidence. You don't have a smoking gun, maybe. You don't have witnesses who saw somebody shoot somebody. What you do is you have somebody who was shot. You may not even have a gun, but you piece together from an abundant supply of evidence that the circumstances indicate the simplest explanation is the suspect killed this person who owed them money or something like that. Occam's razor: no more things should be presumed to exist, such as fortuitous circumstances, than are absolutely necessary. The fewer assumptions and explanation of phenomena depends on, the better the explanation. That doesn't mean exactly the simplest thing, because life is not simple. If life is the simplest explanation for an array of data, then you could say, oh, well, that's a simple explanation. Other people would say, oh no, life is complicated, so that's more complex than abiotic synthesis of organic molecules. But no, Occam's razor said no more things. Even though those things can be complicated, such as a person. But that's if that makes for a simple explanation, then that's the one most likely to be true. How do we apply that? Well, we have a mathematical way of doing this called an inductive math model. And what we do is we calculate the probability, a cumulative probability of Mars being sterile, that is, lifeless. And we do n is the number of tests. Let's assume each test gives a probability of life of like 50%. And we come up with a mathematical model. Oops. And this includes the one microbe rule. If we have one microbe on Mars, one very high unambiguous probability of life in an experiment, n number 5 or something like that, that means that the probability of Mars being sterile goes to 0. It's a product rule. And it also, by its complement, that means that Mars has a cumulative probability of being life of 1. So we apply a cumulative math model for probability, Mars with some constraints. And that formula did not get reproduced. This is why I never used PowerPoints before this. I always used PDFs. But I thought, no, let's move into the 21st century here. Let's start using PowerPoints. So, foolish me. Anyway, when you apply this math model over the numerous tests, So taking the data as collective, there is one unifying reason that you could get the data you've seen. It explains why Earth and Mars would start out the same. Let's say 50-50 probability of life on Mars if it was present on Earth because the situation was similar. And then you just assume like 50-50 for finding all of the organic matter and the results of the life experiments, now reinterpreted with the superoxides, and finally the seasonal variation, and also the redness of Mars. And so it turns out the cumulative probability of Mars being sterile drops very quickly after about n equals 5 or 4 to being 3%. So that means there's a 97% probability of life on Mars based on this mathematical model. Now, how good is the model? Well, it gives a probability between 0 and 1, and it matches the extremes. So I challenge anybody to come up with a better model. And what this means is that we have a verdict based on circumstantial evidence that Mars has microbial life on it. It started out with microbial life, and it has microbial life now. And if there's life on Mars, there's life in the stars. Occam's razor rule of inductive reasoning indicates that widespread microbial life that's rugged, tough life like we find on Earth in deserts can explain what is seen on Mars more simply than numerous fortuitous abiotic circumstances and organisms requiring hydrogen-rich environments which are just not present on Mars, except under very special circumstances. A volcanic eruption, something like that. Thing is you make hydrogen on Mars, it doesn't hang around. It just goes off into space and is lost. So summary and conclusions. Like a criminal case built on circumstantial evidence, life on Mars can be proven based on an array of present data. You can have an inductive proof in mathematics. Basically, as the number of tests indicating the possibility of life increase, the probability of Mars being sterile and these things all being explained by fortuitous abiotic processes drops to 0. Widespread microbial life is the simplest explanation for organics seen on Mars and everything else we observe now. Cumulative probability of life on Mars, I would estimate to be 97%. Now, if you go to a casino, I know some academics will say, well, it should be 100%. No, you're not. That's not the way life works. You're not going to go to a casino and bet against 97% probability. You're not going to throw down real money on a table if you only have a 3% chance of actually winning. So humanity is now moving to a new age of consciousness. I call it the second Copernican revolution. In the Copernican revolution, Earth was moved from being the center, the geometric center of the universe, to being just another planet orbiting the sun. In fact, Copernicus basically said there was no geometric center to the universe. The second Copernican revolution means that we are moving Earth from being the center of the biological universe. It has no center. Life is everywhere in the cosmos. And I believe this year it will become widely accepted that we are not alone in the universe. By the way, if there's microbial life on Mars, There's microbial life in the stars. People have argued, oh, well, we've dropped so many probes and things like that on Mars that were not sterilized. You know, Mars is now contaminated. Well, Mars has been sending meteorites to Earth for billions of years. If there was life on Mars, and Mars, being a smaller planet, farther from the sun, would have assembled and cooled more quickly, formed an ocean. If life appeared there, it would have appeared earlier. And meteorites from Mars would have been showering Earth, bringing life from Mars to Earth. So Mars life may have preceded Earth life, and the two systems were not, because you can now find bacteria that can survive a trip to Mars on the outside of a spacecraft, the polyextremophiles. Life on Mars and life on Earth can't be really considered isolated systems. But if anything was most likely, was that life conditions on Earth, on Mars preceded life conditions on Earth. And since rocks basically move downhill, of course you can get rocks flying from Earth, from like the Chicxulub impact, dinosaur bones and things like that. They would have ended up on Mars. Just the laws of statistics, it's a less likely event. You can get a meteorite from Earth hitting Mars, but it could happen. But generally the rocks flow downhill. They flow towards the sun. That means Mars has been showering Earth with rocks for billions of years. If there was life on Mars earlier, it's spread to Earth. So, but then you ask, well, how did life get started on Mars? Well, let's just say life appears under proper conditions. That's the only scientific, that's the most defensible scientific position, is just phenomenological. We know that under certain conditions, life appears. That proof is we're having this virtual conference, the APEC conference. So we're moving into the second Copernican revolution. Now, if there was microbial life on Mars, there would also have been evolution on Mars, just like there was on Earth. And so just about everything follows. If you have life elsewhere in the universe, you also have evolution. And by extension, extrapolation, intelligent life like developed on Earth. The principle of mediocrity says Earth is not a special place. It's typical of other planets in the cosmos. And my favorite example is Proxima Centauri, the closest planetary system we can find outside our own solar system. And it's got a planet that almost exactly the same size of Earth that rotates in the Goldilocks zone. So my friends, welcome to the new age. And this is what I say to my critics.
Okay. Well, John, thank you so much. Thank you so much.
It's a pleasure and honor to be addressing this guest group.
Yeah, well, I'm sorry about the PowerPoint issues here. I'll take that out. You know, let me put a point in a couple of things that you said. You summarized this really well. But like I've done a few SME interviews. I interviewed Dr. Robert Zubrin. I've interviewed a fellow from the Institute for Molecular Advancement, I believe. You know, and so I've done some space science interviews on this.
Right.
And I think there are a couple of big points that you're going to. You expressed those really well. So this, the
Thank you very much.
evolution of planetary life is not a binary equation. And that is what you're talking about with this Copernican, the second Copernican revolution.
No.
In the past, science has looked at it and said, okay, well, life either evolves on a planet or it doesn't. And what we're saying is the idea of cometary panspermia has been around
Yes.
for 100 years, right? That's well known, well established. If life evolved inside of a comet, if that chemical soup turned into DNA or bacteria or something, it could have pollinated the entire solar system, and in fact could actually have flown outside of the solar system and pollinated other solar systems as well. So we have that. We also have this lesser known idea of asteroid impact panspermia. For
Yes.
me, that was mind blowing. And that's what you're talking about. You're talking about when Mars gets hit by a large rock, it kicks stuff up. Some of
Yes.
that lands on Earth, and a lot of it never gets heated or doesn't get heated to the core of those samples to the point to sterilize it. The same is true. And again, his name is escaping me. I did an interview with a Mars scientist who specializes in genetics, and he was saying that pretty much all of the rocky planets exchange mass. He said the only place you're probably not going to see this kind of panspermia would be like Jupiter or Saturn. But in terms of the Earth, Mars, Venus, things like that, you're going to have big ancient impacts if life existed. So I think that this really goes to the foundations of the Drake equation, and like you said, the
Absolutely.
principle of mediocrity. And I think that's incredibly important. We may not have advanced life on every planet, right?
No.
But I would bet you we will have life hanging on around the edges on a lot more worlds than we think about. So
We will find cockroaches elsewhere in the galaxy.
yeah,
I
well,
believe.
and the
Or the
more
equivalent.
And then the other thing that people need to keep in mind, and this goes to alien civilizations and UAP and SETI and all of that, is these cross-pollination events, which multiply the chance of intelligent life evolving, have been going on for billions and billions and billions of years. And so we are latecomers to the game.
Absolutely. The universe, this galaxy is 13 billion years old.
Yeah.
Our solar system is only 4.5 billion years old. A lot of shit could have gone down before we arrived. And I will also mention, that panspermia, I am a fan of panspermia, but then people say, well, where did life actually begin then? And I say, in a galaxy far, far away, a long time ago. In other words, that's an irrelevant question. We have no idea where life actually began in the first billion years of the universe. And
we're not answering that, but I think what we are doing is I think we're making a much larger case for the prevalence of life throughout the universe in many forms, right? Not all intelligent, but the prevalence of life. But John, let me do this. I want to bring everybody in. We're at the top of the hour.
Top of the hour.
So I'm going to bring everybody in. Guys, please put your hands together.
Oh my goodness.
A giant applause to Dr. John Brandenburg. And John, thank you again so much for your patience with PowerPoint issues. And, but hey, we rolled through it. And I think that it was incredibly important point. You'd asked about presenting that at the open mic, but we're not recording those right now. So I was like, you know what? We need to get this thing recorded. So that was why I asked you to present here. So
that's very kind of you. And by the way, the alternative to panspermia, that life came from someplace else, which is of course not an answer as to where life actually started or began, is I call it the water from wine, turning water into wine hypothesis. that you had somehow a bunch of organic chemicals cooked in a pot, and they magically transformed themselves into the fine wine of life. And that's that's a miracle. The probabilistic arguments were worked out by Hoyle. He was the big proponent of panspermia, and he said it would have taken 100 billion years on Earth to actually form the first living primitive cell based on just a bunch of organic molecules. But when probabilities are that low, they might as well just be zero. So I just wanted to mention that, that I just say, well, life appeared here. We don't know how, but I'm actually a fan of panspermia.
Well, John, thank you yet again. So we're kind of rushing the gun here. I'm going to take everybody out, and then we're going to go to Gary. Okay, so I believe, let me see. Sorry about that.
All right, Gary.
Well, John, good to see you.
Okay, Mr. Gary Stephenson. And Gary, and you have your presentation uploaded. Awesome.
Yeah.
Thank you so much. And again, I'm rushing a little bit today. Some of it's just, we're under the gun to stay on track, but thank you so much for presenting.
We got a lot booked. Yeah. Well, thanks, Tim, for the chance to give this paper again. I've been volunteering with the CEO of the Scientific Coalition for UAP Studies for just over a year now. And when I joined them first, it's an all-volunteer organization. And I asked them, where do you need the most help? And because of my background with gravitational waves, they said, could you have a look at gravitational field propulsion, see if it makes any sense at all in the context of possibly being one of the ways UAPs could operate. And if it is, how could we leverage this for reproduction vehicles for our versions of these UAPs? Then the second part of that task was to get this material peer-reviewed by experts in the field. And so the way I did that was I went and took it to Marcel Grossman 17. This is every other year meeting of general relativists that work in the field. And I presented it there, and that's how I was able to get this material peer-reviewed. So that occurred last summer in Italy. And I think it was pretty well received. I didn't get a lot of comments live. I did get some questions after the fact, but it wound up getting published in the Proceedings for Marcel Grossman. So it did undergo peer review. Basically, what I tried to do was create a taxonomy of various possible forms of general relativity or quantum mechanical gravitational manipulation. So those are the two broad categories, the classical general relativity, warping of space-time, or just quantum mechanically changing the space-time at the quantum level. So those are the two approaches I'm going to review here in overview fashion. And hopefully we'll have time at the end. If anybody wants to go back to any of these, then we can do that. The one I've studied the most, this isn't any particular order other than the order of which I'm familiar with it. I'm most familiar with Robert Forward's work. He was a contemporary of mine, actually the generation prior, but I did overlap with them a little bit at Hughes Aircraft Company. I was working in Hughes at the time. He was at Hughes Research Malibu Labs. And he had first dreamt up a mass flow coil, which in an inspiraling mass will trigger a Lenz-Thirring effect in the surrounding space-time. And then that Lenz-Thirring effect tends to build at the center of the coil. And no one did a lot of work at this because it was like huge numbers of solar masses you would have to get flowing in a coil like this to get it to work. He first published this in the early 60s. I had a look at it again later on in 2019 and 2021 because I had partnered with William Ryken, who is also a friend of Tim's and had an interest in this area. And he had been working with nanotechnology, and these superconducting nanotechnology wires can support an incredible amount of current. we're talking about now electrical current. So the mass that's flowing to be the mass of electrons. And the people often forget that in a particle accelerator setting, the mass of electrons is not a constant. It depends upon how close to the speed of light they're being accelerated. So if you've got a very high voltage accelerating these electrons near the speed of light, you could certainly see how there might be enough mass flow to get a measurable impact in these toroidal coils. So that's when I started studying, and then I realized this geometry is the same geometry as a superconducting magnetic energy storage device, SMAS, that the Department of Energy has been studying for many years as a potential battery storage device. And so there's a technology here that could be leveraged to get a measurable gravitational potential to build up in the middle of the coil, and it's more spread out at the edges. So you do have a net effect, especially if you put a larger mass in the middle of the coil than you have at the edges. And so I covered that. I wrote that up and covered it. Marcel Grossman 15 and Marcel Grossman 16, the two preceding Marcel Grossmans that happened before this one last summer. And I also had that work peer reviewed, and that's how I wound up being so familiar with this concept. Another one that I've been working on, as well as Andy Beckwith has been doing some work on, is it possible to create plasma oscillations in a tokamak that could create gravitational waves? For gravitational wave, you need a third derivative of the quadrupole moment. So how do you get that? Well, if you have the sloshing back and forth of plasma at a specific frequency, that sloshing back and forth has a third derivative. And if it's sloshing back and forth in a quadrupole manner, then you got a third derivative of a quadrupole moment. And that would create then a gravitational wave orthonormal to the movement of the plasma. So I first worked out this in 2003. I revisited it for a high-frequency gravitational wave summit in Chengdu in China in 2017. We looked then at a burning plasma because we weren't getting really enough delta mass to be able to measure anything with just ordinary plasma. It has to be undergoing fusion. So we have to be oscillating between fusion nodes, where fusion node burning, and continue. Now that still doesn't get us to propulsion. What we need to do then from these gravitational waves is do rectification of the waves. And so I had written that up during the Gertzenstein paper that I gave, I believe in the 2007 timeframe. It was one of the STAVE conferences. And that's kind of in the lower right. It's a little bit of an eye test. I'll walk you through the steps, but this is going to be available for download. Tim, you've got this now that I've uploaded it, so feel free to make this public. And if you slash in one direction very quickly and you slash in the other direction very slowly, then you get an asymmetry that comes out of that third derivative. Faster, higher frequencies, the third derivative of those is much stronger than a very slow mass movement in the relaxation direction. And so that if you have two of those, then two of these toroids situated in such a way that the gravitational waves add at the front of the craft, and they also add in the opposite direction in the back of the craft, you can get forward motion. And so that's what's depicted there on the right-hand side, are those steps of fast impulse, slow relaxation, and that's doing your quadrupole rectification just geometrically, where you're getting constructive interference on one edge, and then you're just throwing overboard the gravitational waves on the other edge. So this could never be more than 50% efficient. In fact, very, very probably very much less so. But it is one potential route to go for rectifying quadrupole gravitational waves. Another way is, and I just published a paper on this in 2005 on generating an electromagnetic wave using the Gertzenstein effect. So the Gertzenstein effect says if you have a very strong electromagnetic wave and it enters a strong magnetic field, then one reaction to that is to get a gravitational wave out of it. Since that time, we've also seen Boccoletti had done a similar study in a more complex electromagnetic picture where he could use a static electromagnetic field, either a static electric field or magnetic field or some combination, and get the same results. So both Gerstenstein, Boccoletti had schemes to do this using Einstein's classical field equations. And so I'm depicting here a number of different ways you could arrange that. You could arrange pulses, or you could do a steady stream. Either way, you're going to get a gravitational wave out of it. Although it's highly debatable whether it's strong enough to ever have a measurable effect. Warp drives are another way that you can create a propulsive field. Ackleberry, everyone is familiar with his solution, which is depicted on the lower left. More modern solutions, the Nattario solution is depicted on the lower right and needs far less energy to get the same amount of warp drive. So less energy requirements. I listed out a number of different evolutionary changes that have been happening with warp drives over the years. Unless you're familiar with the Warp Drive Factory website, you may not know all the different solutions that are out there from loop and lens and so on, and how they're rapidly evolving. So this is a very exciting field right now to follow all the work that all the general relativists are doing with warp drives. Certainly the energy requirements keep coming down further and further. I think the loop one is the most exciting one. There's 6 different material metrics that he's generated, including one that has a global acceleration case, which means it can accelerate through space, not just hold a steady state. Wormholes, the difference between warp drive and a wormhole is a warp drive shaped space-time in like an S0 surface. A wormhole is an S1 surface. It has a hole in it. Other than that, you would have to have similar techniques to build these wormholes in terms of stretching space and time. Excuse me, I'm going to get a water and I'll be right back. If you could pause, Tim.
Okay, yeah, and I will take Gary out for just a moment. I've had that happen too. It's allergy season, so. What do you think, David? This is pretty heavy.
Interesting stuff. Yeah.
Yeah. Oh wait. Okay, Gary's back.
Yeah,
Here,
I'll for a water. I had a little scotchy in my throat.
Are you doing okay? You know what? I've had that happen too. It's like allergies, and then something gets you, and
yep.
Okay.
This is when I start speaking, and that I didn't realize there was a tickle to start speaking. So Matt Visser and company had a little fun with warp drives, looking at, can you shape a specially shaped warp drive for a pressor beam or a tractor beam? There's the classic example of the UFO lifting a cow. And so that would be a tractor beam. A pressor beam would push the cow away. A stressor beam you might use to cut the cow open and do some operations and some sampling. So they specified all that mathematically. Obviously, it's not experimental yet, but it was a mathematically interesting case. So then I'm going to switch gears now and go to the quantum versions of gravitational manipulation. And this work was done by Fontana, and this was actually the topic of my last talk that I gave at one of Tim's APECs. Is can you use quantum mechanics to emit gravitons directly by forcing a spin-2 transition? Like for instance, if you're stimulating high temperature to low temperature superconducting junction. The key is really not high temperature or low temperature. It's type 1 versus type 2 because of the quantum mechanical transitions that are triggered when you do that. The transitions of spin 2 are depicted on the left side, where you can push 2 photons in, you won't get 1 graviton out. So in terms of particle count, it's a divide by 2 situation. Likewise, for gravitational wave communication, you can do the opposite effect too and have a detector that absorbs the graviton if 2 photons come out. So it can be used for propulsion or detection. And this is a very exciting possibility for gravitational wave astronomy at higher frequencies. Can we use these detectors to do gravitational astronomy? And so I think that's going to be the topic of a workshop on quantum mechanics for gravitational astronomy that's going to be occurring in Germany this summer. Metamaterials might also be another possible way to shape space-time if they're specially conditioned metamaterials. And Sarfati has been doing some work on this, describing the sort of metamaterials that would take to, for instance, create a tic-tac. So that's what's depicted on the right-hand side there. Kalaz, I wasn't familiar with his work until I started investigating this topic, but he has done an awful lot of work in this area too, in terms of how are metamaterials evolving and how might we shape the light cone of space and time using these metamaterials. Finally, there's the topic of teleportation. In other words, just get from A to B. Don't bother with all the traveling nonsense. Just go straight from A to B without having to travel in between the two. That's teleportation. And in this area, I leaned heavily on the work of Eric Davis, who in 2004 did a teleportation study for Edwards Air Force Base, in which he exhaustively listed some 250 different references and categorized them in these categories. So I've simply copied his categories for these teleportations. There's the vacuum metric engineering for teleportation. There's a quantum entanglement that you might be able to use for teleportation. Are there extra dimensions or exotic Kaluza-Klein is one example. Parallel universe extra dimensions, imaginary access dimensions that could be leveraged for teleportation. And then finally, we have the problem of psychic or telekinetic teleportation that we don't quite understand. For my talk at Marcel Grossman, I omitted this last one because their area is really classical general relativity. And so the psychokinetic or telekinetic teleportation was not presented at Marcel Grossman. I presented all the other slides. What's vacuum metric engineering? Where it's a way to condition the actual vacuum fluctuations of space-time so that you can manipulate the density of space-time and the index of refraction of space-time. Remember, space-time has a characteristic index of refraction, and you can suppress that index or you can raise it up without actually using matter. You can use energy instead of matter. So there's been some work done by Morrison Thorne. Visser has been doing some work in this, but the classic work that everyone thinks of is Hal Puthoff in the late 90s and early 2000s. And so I have him listed here too. By the way, I've also uploaded, Tim, a full list of all of the references I used for this paper. And that's a separate PDF file if anyone's interested in going back and looking at some of these references. I have an exhaustive list of all the references that were used to put this together. And so I made that available also as an upload. Another one that Eric captured, Eric did a really good job of doing diagrams. So I captured some of Eric diagrams I poached them from his paper, figure 6 and figure 7 here out of his paper. And quantum entanglement simply means you're using quantum entangled particles to read the state of matter. It destroys that state, but the other quantum entangled particle can recreate that state somewhere else. So it's essentially, it's 3D destroying and 3D printing in two different places with an entangled pair of beams. And so that's how you're moving it. You're not really moving it. You're destroying it by reading it, and then you're recreating it somewhere else. So it's a sort of 3D printing by matter beams and by entangled state measuring and state creating beams. So that's the trick here, as opposed to a regular fax machine, which just has the sense beam and then creates an actual copy of it. So I thought those were really instructive diagrams. And then there's the issue, and I know Greg Michalowicz had done some work on this too, and I think this figure down here is one of Greg's figures. Are there hyperspace dimensions that we don't understand yet, we can characterize mathematically, but we don't know how to get to? That is that a way to, if we find a way to jump into a hyperspace and jump back out, is that a way to do teleportation? So Kluser-Klein was a very early, they weren't talking about teleportation with Kluser-Klein, but it is an extra dimension formulation that you can explore and say, is there a way to leverage Kluser-Klein to do teleportation? Green had done some work in this area too. Randall and Sundram have done the most recent work, and I can also recommend Boyd from 2024 is working in this area. I saved the most troubling one for last, and the one I'm least familiar with. Eric did a fantastic job and I've only cherry picked a very few of the papers that he leaned on to describe this. There's been a number of tests in other countries, most principally China, People's Republic of China, and former USSR, now Russia, on telekinetic teleportation. The trick is to find the right humans that are highly skilled at telekinesis, ask them to move an item from one sealed box to another sealed box, put some high-speed cameras on this, and let them go to work. And so pretty fascinating papers to read. And I would point you to Eric's 2004 teleportation study for more details on this. But there are stories about high-speed cameras observing an object essentially disintegrating and then reintegrating somewhere else. In some cases, the object simply disappears and it's nowhere for a while. It's just gone. And then a few seconds or up to minutes later, it shows up in the other box. Where was it? Right? And there were, in one particular study, sensors, radio emitters embedded in the object, and that radio emitter stopped emitting when it was gone, and it just didn't start emitting again until it showed up on the other end. So somehow, I think the important thing about this is somehow people are able to do this. So if people are able to do this, are UAPs able to do this? And if so, how? And what are we missing in our physics that could explain this? There is an emerging field of studying the physics of the brain called neuroquantology, and it's a mess right now. It's in disarray. But it is one of those fields I want to keep an eye on, because if there's ever any insights that come from how does the human brain work, and what can that tell us about the reality of teleportation, then that's something I would certainly want to keep an eye on for UAP studies and for doing reproductive vehicles for both ours and for the vehicles potentially of our adversaries. And so I think that's the sum of it. Let me see if I've got anything else. Yeah, variety of classical and quantum approaches here. The next step for this year, and I want to give a plug for SCU. We are meeting in Huntsville in June 6th, 7th, and 8th. And so we'll be statusing this work again this year, because this work is from last year. But what we're looking at now is what are the signatures of variously observed UAPs, and how do those signatures line up with the expected signatures of what I've just outlined? So every different form of propulsion has its own characteristic signatures. What are those, and do they match up with what we've observed on the UAPs so far? So that's work that's occurring this year, and I'll be briefing that in Huntsville in June. And I think that's what I've got. With our backup slides, there is another way to do a gravitational wave, I guess, rectification. Make an AC look like a DC effect, and that's the Christodoulou memory effect. It says that if you pass an oscillation through space-time, there's a permanent displacement that's experienced. That permanent displacement could appear to be the same as propulsion. So that's one go back. Here, just for reference, Einstein's field equations, and then the gravitational wave power equation, which has that mass energy, the the third derivative, square of the third derivative. And so that's, of course, that will go up as the frequency goes up, it drops as the frequency drops. And then the relationship between an electromagnetic input and a gravitational wave output, it essentially doubles the frequency of the signal. And some other examples of how we might make nanotechnology gravitational wave emitters. Okay, that's what I've got. So I think we have time for some Q&A.
Awesome. Gary, thank you so much, man. Thank you so much. Okay, let me take the slide deck down. Before anything else, though, I'm going to bring the whole gang in. We need to give you an applause. Okay, this is everybody that we have. Look, it's our Brady Bunch outline. Giant applause for Gary Stephenson. Gary, thank you. I will be seeing you at the SCU meeting. Mark Sokol and Jared are going too.
Fantastic news. All right, we'll see you there, guys.
You see an enormous camera lens. That's me hiding behind it. And then Mark and Jared will be normal.
I guess you've got special dispensation. We're only supposed to take pictures, but I think you have a special dispensation.
Well, and then I do need to drive down and meet with John Brandenburg at some point too. So, but so yeah, thank you again, man. Do you guys want to do Q&A or open discussion? Our next person is Isaiah Ritchey, but he is not here yet. And the reason is we have about half an hour. So go for it, John.
I noticed your Bob Forward, who's just a brilliant guy, came up with this idea of this toroidal thing. Does he have a tokamak has helical lines of force going around the torus? They're not just straight, or they're not straight around one short way or the long way. They're actually helical, or a mixture of the two. Is that what's giving rise?
Could that be applied to tokamaks? I hadn't thought of that.
What?
I hadn't thought of that.
Oh, okay.
There's probably actually going to be a pollination.
I thought the mass flow is what leads, the Lenz-Thirring effect leads to frame dragging in the same direction as the mass flow.
Right.
So I thought the circulating around the short side, is that what creates the Lenz-Thirring effect in the middle? Oh, yes. Okay. Thank you.
And there's mass contained on the inside, and you would want to arrange it so there's not any mass contained on the outside of the craft.
Oh.
So you do it right at the edge of the craft.
Sounds like a complicated plasma physics problem to me.
Interesting point. Yeah,
but,
we might be able to leverage.
But it can be solved. A standard tokamak with helical field lines that would solve it.
Interesting idea. Thanks. Other questions or comments?
We can't hear you, Drew, by the way.
Go ahead.
You're muted,
not
Drew.
Hearing you, Drew. I think you might have been on mute.
Must be some audio thing. He's not muted.
Oh.
Well, hey, Gary, I was just going to ask, what out of all these different things you've kind of reviewed, what do you see as the most likely or most promising avenue?
I think really the quantum mechanical approach is where we're going to get a breakthrough first. And the reason is, the coupling constant in the Einstein's field equation, that's that G over C to the fourth or G over C to the fifth for a gravitational wave. That's just really difficult to overcome. Just that's 45 orders of magnitude of loss of signal there that we don't experience quantum mechanically. Quantum mechanically, it's going to be quantum efficiency, which can be low. It can be 1% or 10%, but the quantum efficiency is not going to be 10 to the minus 45%, right? So I think it'll be quantum mechanical.
We have to somehow put that 45 levels of magnitude in the denominator.
And Sarfati has been looking at, hey, can we use metamaterials to overcome those 45 orders of magnitude?
Right.
Question. First of all, can you hear me?
Yes, I can hear you now.
Yeah.
Okay, good. Okay, so let's say we build let's say we wrap somehow one of these Albuquerque warp bubbles things around a space shuttle, and we want to whoosh it to next place. What makes the thing go forwards? Does the warp bubbly thing just suck the spaceship with it, or somehow magically, or do we have to have rockets or something blasting mass out the
That's a
back?
good analogy.
Something has to be moving the field, accelerating the field forward. And that's why some of these more recent warp drives that have an accelerating term in them are exciting, because you can't start at a constant velocity of 10C. You have to get there somehow.
I think that's me drop.
Gary, are you familiar with the recent warp drive paper from, I think, last year by Dr. Barak Shoshani, where he does exactly this, an accelerating warp drive, and he does one of the first comprehensive proofs that you can use warp drives to make CTCs within the context of general relativity.
Shoshani, I'm not familiar with that work, but I'd love to see it. Is it
Okay,
Brad?
I can send it to you.
Okay. Warp drive.
Yeah, there's a lot going on here. I've been reading the news the last couple days. New quantum theory of gravity, new questions about black holes. There's a lot of interesting stuff going on.
Yeah.
Well, I'm glad to see that Gary's picked up on the work of Fernando Loop too. He's one that's kind of gone very much under the radar. But he's one of the only people that I see that's actually like kind of trying to merge the frameworks of some of these different warp drive the metrics.
Right.
So
I think he was the first one to come up with an acceleration drive. Yeah. Other comments or questions?
Yeah, John, go for it, sir.
I noticed you had these interesting experiments where things would appear and disappear.
Yeah, pretty fascinating.
What would be that's almost like like supernatural apparitions. Is this like something going into a different dimension and then popping back out again?
That's the question. I don't have any answers for you there. That's the question, and they seem like to be really well documented papers and well instrumented, and very few people can pull this off. But the Chinese have a population large enough where they can downsort them to find these people, and so I think that's been their real gift, is that they're willing to look for these people and put the effort into that, and then finding these incredibly gifted people, and then put them in the lab and let them go to town.
There was a comment, in the discussion of the Heim Theory, Joel, where you talked about the teleological, aspects of this, and part of this is that, there was the idea that we weren't we're trying to get some overview of things rather than just looking at patterns of measurements.
Yeah.
And to me, to me, science is more than saying there's things that everything we can explain by science. I mean, Feynman had this great quote. He says, there are things that are true that can't be proven.
Yep. And
be open to the idea that we don't know everything.
Right. And so Heim Theory might be able to shed some light on this. I don't know.
Yeah, I think it really is able to shed a light on a lot of stuff if we find a complete and good formalization, and if we start to be able to actually use it, right? Mm-hmm. So to this,
way to use it usefully, yeah.
Yes, right. So one big part is the accessibility and of the framework, and actually even Heim was not really using his framework in depth, let's say quantum mechanic. When it was first derived, it was maybe some 50 pages or 100 pages of math, and look what today all is done with it. Like it's got so in the, like not in the depths of understanding quantum mechanics, but from this little knowledge, what you can do with it, right? Mm-hmm. So if you would do this with a formalization of Heim theory, the scope is beyond everything. So this is my current interpretation.
I don't understand Heim theory that well, but what I like about it is it's trying to do a unified field theory approach. It's complete in its
Yes.
formulation. It's complete.
Yes.
Whereas all the other sciences are incomplete, where general relativity doesn't match up with quantum mechanics. Heim theory at least is complete, and it even includes like information space or information theory.
Yeah, and actually it shows that it's necessary to include this to get a full picture.
Yeah.
And what I said in the beginning is very crucial here. The R6 space is already extremely mighty. You can do probably a lot of what we're dreaming of already if you just have and use probably the R6 formulation of Heim's framework. What all is possible within the R12 framework, that is, I can't really foresee it yet, seriously. So yes, and about the point, John, that you made, I totally agree, and I read Kurt Gödel, right? And I'm aware that there are certain limits, but so was Heim. He explicitly stated this, and I wish that we would have a perfect translation of his audio tapes, and David Chester actually is looking into making that happen and possible, because when he talks, you understand that he is aware of all of these limitations. Like there are quotes in there like a theoretical framework, and his framework still needs 3 empirical values that go into it. H bar, C, and big G, right? And he is saying the quality of those 3 is not good, okay? And it is not good in an area that the output of the theory is really impacted by this. And he was aware of this the whole time. And he also said, yes, of course, it's not a complete description of reality and then you know everything. No, it's not that, okay? It is next level, and I would even say it is next level compared to just general relativity and quantum mechanics, but it still is a model of reality and not reality itself. And Heim really formulated it in this strength.
Yeah, because we're missing something with teleportation. We're not getting the whole picture here. So it may be able to help. Or some other formulation. I work a lot with Andrew Beckwith, and he's doing a cosmology based purely quantum mechanical, no relativity at all. So from beginning to end, his entire cosmology is fully quantum mechanical. And so that might also lend insight. John, you had another question.
Oh, yeah, just a comment. If we expand further on the Heim space, that it's like a Hilbert space, a space of functions, then we can imagine that just like there are FM radio stations sitting on the dial, that if we don't have an FM radio, we don't know they're there. And if our bandwidth is not big enough, in other words, you could have a one station wink out and the signal reappears on a different station and then goes back to the original station. That happens a lot around here in Oregon.
If we don't have the right operators to find that, we'll never see it. Yeah.
Yeah. Then the one final comment, and then I'll shut up. Joel, what would Herr Professor Planck say now about quantum mechanics, do you think?
Oh, also, Gary, can I ask you to email me the Marcel Grossman again? I had a copy of that. I do not have it anymore. I can't pull it off the drive.
I'll send you the briefing I just gave. I'll also send you the reference list, and then the Davis reference. So I think the Davis
and I already have a drive location, so this would be on Google Drive. So people could download it from the. It's at the bottom of each conference page. So yeah.
So to actually answer your question, John, I think it's an important question. I think we should all ask ourselves, what would the founders of quantum mechanics think about the current state of quantum mechanics? And I think they would say, oh my God, what are those people doing? Because I think they had a broader view on reality back then than we have today. Okay.
Yes.
We've run so far along a narrow road, which led us to so much success, right? Look at the technology we were using, right? But doing this, we forgot that there is so much more. So this is my answer. I think you're talking surprised that we became so dogmatic.
You're talking about like acolytes versus trailblazers, right? And maybe that's not a great terms to use, but like those original people were like, okay, we have this model and we're going to create this model. Let's see how far we can take it. And then folks who have come since then are
But it's a
largely focused
model,
on,
and it is something that is a step to something else, right? And we forgot that this should be a step to something else. I think this is the way they viewed it. Some of them like formulated it directly like this, that it should be a step to something else, which is actually ugly and I don't like it, but I get something out, so I'm going to use it, right? So this shut up and calculate. Like, don't ask why the fuck is this so not good? Just do it, right? This mentality. So, and to go back so I have a slide on the logic in Heim theory, actually two. One is to Kurt Gödel, like his formulation, you could say, no system of arithmetic is complete. And Heim accepts this and says physical realization means convergence, not deductive closure. Okay? So this is within Heim's framework. And you have two other ones, Leibniz, the Characteristica Universalis. Logic should express all thinkable truths via structural operations. And Heim says, yes, physics is semantic logic over modal surfaces, right? The metron lattice. And you have Charles Sander Peirce. Semiotics and logic are inseparable, and Heim aligns field identity with interpretance of selector structure. So the observer has a special role in the system, right? So yes, it's. I think it's all there, and what wasn't there can be put into place today.
Gary, I do. I actually have quite a few different papers and warp drives that you might find interesting to add to your collection. That if Tim wants to connect us via email, I can connect you with. There's like Escape from a Black Hole, Spherical Warp Drive Aerodynamics, like some more esoteric ones that I think you'll appreciate.
I think it'd be really beneficial for my work with the UAP folks, because that's going to help us define what are our expectation values here around signatures. What signatures do we expect to see out of these particular drives, and how do those line up with our UAP observations that we've made today?
Yeah, Gary, actually, I wanted to ask you about that. Bring my microphone closer. So from what I've seen with the available UFO data, it looks like we have a few things that kind of narrow our parameter space for what mode of propulsion they're using. And it would seem as though it's a different mode of propulsion when it's in atmosphere versus likely out of atmosphere. The in atmosphere propulsion, we see simultaneous gravitic and magnetic changes. We also have apparently a few different Faraday ring images that give us some ballpark estimates for the magnetic field strengths that are being used. We have some evidence of gamma emissions coming off of these craft. It seems like each of these little data points, while not, amazing by themselves, when combined, probably significantly reduce the parameter space of what's going on with these. Oh, and then they're jumping 50 miles back and forth, blinking. And back in the day, in the 50s, the Air Force guys thought that they were utilizing the Earth's flux tubes, which if they're jumping back and forth 50 miles at an altitude of 50 to 60,000 feet at different points on the Earth, and we see that happening at certain latitudes, that might once again reduce the possibility space on what they're utilizing. We see magnetic field rings. We see jumping specific distances.
Yeah. I want to be careful there, though, because we don't want to converge too much and rule out that we're looking at many different craft here.
Yeah.
Right.
Well,
and maybe some of it is not even a craft, right? So
some of it may not even be a craft.
Could be just psychologically or other things.
An information space thing.
I think.
Yeah. Who knows?
Yeah.
We may not
I
even
think Curtis wants to join, Tim.
Is Curtis here? Oh, okay, there's Curtis. Awesome. Welcome, Curtis. And I'm still waiting for Isaiah, although if he can't make it, we've had one heck of a conference today. We still got to do lab updates. I think Mark is hiding. Yeah, Mark is hiding out. I can see Mark. I'll bring him in. So yeah, we have about 10 minutes left if you guys want to keep doing Q&A, or we could jump to lab updates now. I mean, I'm really excited. And Gary, I'm super excited to see you at the SCU conference. I got that photo of you and Nancy at Reagan Airport last year.
Yeah, that was a great photo. Thank you for that. Yeah, it's a fun group, and they cover the waterfront. I think of Julia Mossbridge when I think of the psychological aspects. She's really good at covering that particular aspect of it.
Yeah, Gary. So first thing I wanted to say was that I didn't see any mention of Jim Woodward's work. You might want to look at that in terms of the. Yeah, I mean, what
I view that as not necessarily a general relativity device, but maybe I'm misunderstanding what a mock drive is.
Yeah, you might want to look at that because really, in terms of like unifications, right? So special relativity, like we consider it unification of E&M and right, E&M, electricity and magnetism. General relativity is kind of like the unification of inertia and gravity. And a lot of times with conventional relativity, people just talk about only gravity, and that's the thing that Jim is emphasizing with his work is inertia.
Yeah, it's more an inertia.
But
inertia control,
that is general relativity, right? It's meant to unify both fields and treat inertia as a field. And then, of course, the unified field theory is unifying all of it, which is something that I'm working on as well. But I would say that a lot of the things you're pointing out, like if you look at like the Mach-Lorentz thruster, you look at the mega drive where you're taking the inertial side. I don't know how any of this is going to work without understanding inertia and really like taking that into account. And the thing is, if you look in Jim's book, I mean, he does point out where that whole 10 to the 45 problem kind of goes away, basically. That there's where some things where you could consider the field side turn into the source side, right? So
the kind of frequency chirp, it overcomes that. I mean,
yes,
it's there, but it overcomes it.
Yeah. So that's the part we're kind of playing
a good point.
with.
I didn't look at that in developing all this, but I should go back and revisit his work because it continues to evolve.
Yeah, and I haven't yet published the unified field theory that includes Jim's stuff and other stuff that I mean, basically I got back in the game like 3 or 4 years ago because certain things. And yeah, you're right. I mean, the thing I would say about that, I would caution you though about quantum mechanics is that it's looking like, based on what I've seen so far, that quantum mechanics is correct in a certain domain. So it's a subset, which doesn't mean it's wrong. It just means that like at lower energies it works, and in certain domains it works. And
there's a lot of assumptions that have gone into Fontana's work and so on. So yeah, I'm very aware of the risks.
yeah. But and there's, I'll cover some of these things in my lab update.
Okay.
I'll cover some of the theory things, at least give you some hints about touch points. Like I said, I haven't published yet. I'm hoping to publish my work this summer, and includes the inertial side. So Jim's work is included, and yeah, I think all that stuff you showed is pretty neat, right? The lens stirring effect, all that stuff. It's really important that we include gravity effects as well. But the whole point is that that Einstein was trying to do is unify inertia and gravity, and that's the thing I want to mention, is that part of it, that physics, is probably something we need to understand before we do these cool things.
Yep.
So anyway, I just wanted to mention that.
Yeah. Thank you. Other suggestions? If not, it's first back to you, Tim. I'll open it back up.
Okay. Yeah, absolutely. Well, let's do this then. Gary, thank you again. Let's do one more applause for Gary, and then I would go to Isaiah. So Gary Stephenson, thank you again.
You bet.
You are, hardcore work, man. It's amazing. Thank you so much. Thank you so much. Okay, so let me take everybody out and I will go to Isaiah Ritchey. Isaiah, welcome, sir.
Hey, Tim. Hey, Tim. How's it going?
Let's see, Mark and I are both trying to take people out, so we're playing musical musical buttons. Okay, there we go. Okay,
There we go.
so you're gonna do an overview of the SEG, and let me bring that up. Awesome.
Yes.
Thank you. Man.
Yes. Thank you for having me on here, Tim. So today I just wanted to do more of a not as in-depth as the interview last year, but more of an update from where I left off last year until basically today. There's been a lot of advancements. So let's see. Good afternoon to everyone and good evening to some. Thank you for being here. It's been exactly 1 year since I last shared my progress on the Searl Effect Generator, and it's been quite the crazy year. Over the past 12 months, I've pushed my own boundaries of magnetic engineering and materials science to bring the SEG technology of what I'm working on closer to a possible reality. From custom ceramic and neodymium rollers with imprinted magnetic waveforms to precision-built stators, experimental magnetizing jigs, and full-scale and working now on a half-scale SEG unit. This past year has been a journey of breakthroughs, challenges, and relentless innovation. Today, I'm excited to share with you the results of those efforts, including what's working, what's evolving, and what's coming next. So go ahead and start here. Okay, so May 10th is listed here on the board, and that was one of the last units I was working on. Tim came and did an interview at my house, and I showed this unit, even though I don't think I had it work at that time, but I did get it to work. And then May 10th is one of the most latest developments. I have a version right after it that is working, but this is one of my pride and joy models on the left side here with the controls. I basically have an on-off button, power button, and then a speed button, along with battery levels and RPM. Let's see, slide 2. Okay, so soon after that, I had the idea of doing an inverted setup. Instead of the rollers rotating around, I had the stator spinning. So I'd called this the inverted SEG setup. The stator rotates clockwise. The rollers were locked in place, only held in magnetically. I got it up to, I believe, around 7,000 RPM. And this is where I first observed the demonstration of the roller levitating on the surface of the stator. This is probably just a 0.5 millimeter distance, or maybe 1/3 of a millimeter. It was just about the thickness of a piece of paper or so. Interesting about this model, it could get up to very, very, very high speeds. The rollers were incredibly stationary. I found at certain speeds, the rollers would lock perfectly evenly between the top and bottom. And the only thing I didn't like about this model, that it generated heat. It didn't get cool. It warmed up within about a minute of using it. It got to hand temperature and continued to get warm. So I like the principle of it, but I discontinued it because obviously with the SEG, I want it to be getting cooler, not hotter. So you see the image on the right is the roller pushing itself away from the stator, even though it's held on magnetically. The middle image is the first roller setup I did to just basically balance between the two opposing magnets held next to the left and right of the roller. And then far right with the RPM gauge, I was able to do all 12 rollers and spin the stator either left or right. Let's see if I'll go to the next slide. So these are several of the systems that I engineered just within the last year. The first is the pulse system. It worked fairly good, but it can only get up to about 230, 250 RPM, which is too slow for what I'm looking at. And at about that time, the roller would start to pull away from the stator, having kind of the semi-levitating, and it would smack into the electromagnets it was rotating that were pushing it around. So eventually had the idea to do a carousel system, and that worked very well. It was large, it was robust and clunky, but it was kind of proof of concept that I could push the rollers and pull them at the same time. And you can see it was the big plexiglass enclosure around the stator with the 4 rollers. That worked really, really well. except at certain high speeds, the rollers would fly off the stator and be pulled into the adjacent magnets. So it worked for a while, but it wasn't exactly what I wanted to happen. So after a lot of trial and error, I came up with what I call the magnetic coupling system, and that's the third in a row, the fourth lower picture, with just the stator and the one roller on the white platform. That system has worked the best of all the systems I've tried. What it does is has a system or a combination of magnets underneath, and it doesn't just repel or pull the roller, it actually does both. I base it off of a magic trick I saw of basically you can kind of tractor in a magnet, lock it in place with it either pulling too close or pushing too far away. It kind of balanced out the rollers. So I can do all 12 rollers, I can do one roller, I can do 5, 6, anywhere between 1 and 12. I was very happy with that. I can go to anywhere from about 30 RPM all the way up to about 1,000. The motor can. Even with driving all 12 rollers, the motor it has one motor underneath the base that runs the whole stator unit, the whole SCG. That motor stays cold even after hours of operating. It takes one tool battery. I use Milwaukee batteries to run it. And so I was really focusing last year on having a way I could rotate the rollers to any speed I want up until where they fly off. The next picture on the lower right is the inverted SCG principle, but I combined the rotating armature of magnets to propel the rollers. So I could have the rollers going one direction and the stator going the opposite. What that created was I could bring the rollers up to the point where they're levitating, but they won't fly off, which is about their max they can do is about 395 RPM before fly off. But they start levitating, floating at about 275. So I have a lot of range to kind of go through. And then I could also spin the stator backwards, thereby spinning the rollers, each roller on their axis, spinning it much, much faster, but not making their orbit around the stator any faster. So they'd be rotating on themselves faster, but not increasing the centrifugal force to fling them off. What I found on that system is I could get them going so dang fast that the copper sleeves and not really the magnets, but the copper sleeves would actually expand on the magnets and fall off sometimes. It was crazy. Like they really got up extremely fast, which is what I'm looking for. So that was that system I worked on, multiple systems, and still hooked on basically the number 3, the one on the whiteboard. That one is the best system because I can also put inductors around it when I want to start tapping power out of the rollers. Now, I want to introduce somebody. He's seen some of the episodes of APEC. His name is Josh Varner, and he came on about a year ago. And he has been an incredible help, inspiration. I have a small group. Jared is part of it and a couple others. But Josh has contributed to this project immensely, and he has an incredibly creative mind. So one of the things he was working on, which I copied after his work, was producing a half scale size. So it came out to be, with everything that could work, to be not exactly 50% smaller, but 51.252% smaller in size. And I'll get into this soon, but using magnetic printing, I'm going to use half the value of the squares, which is half of 34 is 17. So this on the right side, you see the small copper band that is precisely 51.252% smaller than the standard stator and roller size I've developed. Here's another view of the half scale model. Now this one could fit in your hand easily. It'll be all full 12 rollers with special magnetizing that I'm about to get into soon. And what I'm gearing up to do, basically the world's first, is do a full 3-ring system. First with the half scale, and then eventually do it with the full scale. But what I've found with factoring costs, I'd say prior tariff costs, was that it was about 90 to 96% cost savings to do a half-scale version compared to the full scale. So they have a Milwaukee pen next to the system, the copper ring, and the one little roller segment. Here's my scaling system. Scaled everything precisely down from the original size stator model, which I have all those dimensions, sizes, and trying to stick with the laws of squares, which Josh has helped out immensely with understanding them. And so keeping the gram weights, conscientious of gram weights on the half scale model. I just call it the 0.750. But basically start with the stator, then the magnetic neodymium and Teflon insulator, and then neodymium core. Weirdly enough, the total weight for the just stator is 1,234 grams, 1, 2, 3, 4. Weird how these things work out. Next is a model which I've had running, and this is the ceramic magnets. This uses my prior stator. I think it was version 5. And using ceramic magnets instead of the neodymium. I have the copper sleeves for them, and then I got these magnets, believe it or not, off of Amazon, and they were crazy enough, like the exact size they needed, and the right correct gram weight, which is just it was weird, but that's the way it ended up happening out. What I needed just came, and so I got plenty more than enough to experiment on, and also enough to do one full ring set, which is the 96 pieces, ceramic pieces. Okay, so next. Now here's what I'm calling, it'd be version 7, the gold edition. This is just the stator and then the new set of rollers. Up on the right-hand corner, you see where the squares, those start from the 2852 neodymium, and then you go to the magnetic, and then copper and PTFE. That's just using squares to keep the weights. What me and Josh have understood so far using squares is that the weights have to be in a divisible by 4. So trying to adhere to that. These are the sizes of the gold edition, and it shows all 4 layers. Something me and Josh are eagerly pursuing after is to find a replacement for the pure neodymium, a substitute. And that has resulted in lots and lots of research, lots of conversations with ChatGPT, and between me and him. And one of the other things we're going to try for the neodymium layer is to use an electret, and then many other compounds to do possibly a type of replacement. So one of these is writing out the densities of each layer and calculating out the weights so that they all are divisible by 4. This is just one example of many pages of calculating out these values to be just right in relation to the size of the rollers. Okay, so this is getting towards one of the huge developments of this year. So I'm kind of shifting from the models that I was working on into the programming, which is the special magnetizing. Now this is pretty crude. I just got some, I think it was mu metal or mild steel. I don't remember which was. But I cut a wave line into it to relay over the stator parts of the stator magnets, and just to kind of bend and twist the field. Bend and twist the field, which it kind of worked. I mean, you definitely see a wave line in there, but it's not exactly what I was looking for. Plus, the steel shields the magnet. It doesn't. It shapes it, yes, but it also decreases the field. And if you put a roller on there, you barely pull it away. The strength dissipates very quickly. So it looks good, but it's not. It's not what I'm going to be using. Now here, this idea came to me because I think in 2013, 2014, I just did this random experiment of putting grooves into a magnet. Yes, it did alter and shape the field, and then I just left it behind until last year I decided to start cutting grooves. And I hired a guy who had a whole small factory with machines called a wire EDM, and that's all he does is cut out mostly medical machinery. And I had to use an unmagnetized ring magnet to do this. And so looking at the law of squares, 34 is the number that is most prominent that John Searle uses. So I asked of him if he could do a ring magnet with 34 equal lines, cut in 1/3 of the way each, the inside and outside, 1/3 of the way each, into the ring magnet, and then cut each line at 21 degrees of an angle. Why 21 degrees an angle? Because what I've learned, I've heard many sources say this, is that the field on these roller magnets is not just straight up and down, it's heliacal in nature, like a heliacal gear. And on one interview one speech John Thomas did, he mentioned that the field is slanted at about 20 degrees. So looking at law squares and how the squares add up, I never could find like 20 much at all. 21 was very prominent. The geometry of 21 was very prominent. And so I just took the chance. Let's just angle it at 21 degrees, which is 69 degrees. It leaves a protractor. I just call it 21. It's easier for me to remember. So 34 lines, inside, outside. You get this really incredible pattern. You can see my thumb pressing up against it. And then looking on the side of the magnet, you get all these really cool spikes. So you get these patterns on there. And I went with this system for quite a while. I ended up developing tooling that used water as a cooling agent. Now the wire EDM guy, he charged a lot of money to do that one ring. I found a way I could do it for about 23 cents per magnetic ring, using very, very fine dental diamond blades, which were, I think, 1/3 of a millimeter thick. They were incredibly thin. So I made the tooling, and it worked very good. I could replicate his magnets and do smaller cuts than he did with his wire EDM, or larger cuts if I wanted to. What I found was the smaller the cut, basically, the less of the deflection in the magnetic field you would find. But the slightly larger of a cut, which is about a 1/3 of a millimeter, was optimum. So I'll go to the next slide here. So I continued with this one for all of last year. Now this lower left-hand corner is a picture with a superimposed image of the geometry, 34 points with one empty. Now shown here in the law of squares, you find 21, 5 and 16, 14 and 7, 15 and 6, 8 and 13 at geometric placing. So I just took the chance of using 21 degrees 34 times. And you notice here, 34 magnetic points, one is null, each angled at 21 degrees on each roller segment. So right here on the right side, this took me many hours to get this image. It was before I had the Tesla meter that pairs with the oscilloscope. So I painstakingly put a ring magnet onto a rotary index table and rotated it 1 degree, and then took a measurement, and then rotated another degree, took a measurement. So you have your 360 degrees of rotation, and took a measurement for each one. Put it onto an Excel sheet, turn it to a radar image, and that is the image I got with the what was I using here? The cut lines, the roller segments with the cut lines on them, and you have these nice sprocket pattern. Notice with one poking in is null. So the reason I'm leaving that one empty, just like you see in the lower left-hand corner, I had a dream last year that gave a very important detail about that. And in the dream, I was sitting down at a kitchen table with my grandfather, and John Searle was there looking through my parts, and I was showing him the rings I made, and he was very impressed with it, happy, but he's like, you're missing one thing, and you need to have 34 points, and one is null. So after that dream, I've always left it null or empty. And thus you have that one point on the right side image, basically zeroing out or going down to hardly anything. What I found out later after doing that was that created a spring action in the ring magnet. And if you use that precise number of 21-degree slant, 8 segments, 34 points, that slant and tilt on those ring magnets will start at one point and work completely around to the bottom 180 degrees apart from each other. So it creates this springing action, which the roller, as it rotates 180 degrees, it'll line up it creates a springing action, not 170 degrees, not 190 degrees, 180 degrees exactly. I accidentally found that out when I built a physical model of the 21-degree slant with all 8 rollers. If you use 9 rollers, it won't work. If you use 7 segments on a roller, it won't work. You have to use 8, just like John said. And this is 34 points, 1 missing, and those are all angled at 21 degrees. You get this perfect geometry, which is a complete surprise to me that I found it. But that's how the geometry works when adhering to these strict numbers. So here again is some pictures. This is a little more closer look at my ring magnet, the lower left-hand corner, and you can see here where the blade missed a section and kind of jumped. And that actually was the reason I discovered the spring effect, was because of that tiny little chip. Because at that point, I wasn't doing what I had learned in the dream, was leave one empty. So after that point, I started leaving one empty and had these amazing results of seeing this springing action inside the ring magnet. Now this top one, the top middle, that has nothing missing. So there's no springing action effect. This right-hand image is, I think, one of my first tries at doing the same cut lines in a ceramic magnet. Had pretty amazing results, but the springing action was almost not even noticeable in the slightest. The neodymiums really, really enhance that. Also, their field strength is far greater than a ceramic. Let's see, I'll continue on here. Here's some more pictures of what I've been developing. Now, this far right corner neodymium magnet has deeper cut lines. And if you look at the image next to it of the magnetic viewing film, the angles are a little spread too far apart for me. I like that pattern, but it's not the best of what I can do. In the middle line of pictures, you see there's kind of almost like a loop-de-loop of magnetic field. And then next to that, you have a ring magnet with a deeper cut line. That really adds to the spring effect. Now, there's a video play button here, which was just a photo I copied from myself, but it doesn't actually play. But this will show as this ring magnet goes down this piece of steel, it bounces like a spring. And I had some really, well, okay, I'll save that until later, because there's something here I'm very happy to introduce, but I can't give any details till I get there. Okay, so let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see, the 10th would be lower left near the middle, where it shows this very nice sawtooth pattern. That's really what I'm going for. And then the image next to that, where the cut lines are pretty faint on the magnet, those magnetic sawtooth lines would barely even show up when you start using super, super thin blades, to where it was kind of pointless to do it because you could barely even see the sawtooth. Next. Now here is some of Josh Varner's work. He is the pro of pros at 3D printing. Josh Varner's unparalleled 3D printing work with a half-scale SEG rollers and custom magnetic field arrangements. This is amazing because he came up with these rollers that were about a half of an inch in diameter, and then he would make sleeves to be able to custom put, sleeves to be able to put tiny little neodymium magnets and customize the field arrangements to wherever he wanted. And he got them to arrange them. So you see in these lower pictures with the colors and the lines, that's magnetic viewing film. And he could arrange those to have a beautiful sine wave on his rollers. And they would connect right up to his stator unit beautifully. So he's presently working on some other projects, but also this has been on like the something going on in the background of gearing up to be able to do a full half scale model SEG, and using custom configured magnetic layers and magnetic patterns to whatever he wants. He could do squares because it's all 3D printed. But presently, sorry about that. Presently, what we're working on is really figuring out the center core, a neodymium substitute. That's the one thing we're after right now. Magnetizing, we have it down to pretty much a science, and we're very happy with the results. So that is Josh's work, some of it. Let's see. Oh yeah, so more of Josh's amazing comprehension of the mathematics in the law of squares. Now, this is an old print from one of John Searle's books he found, and he would go through and figure out the math. Now, this guy, Josh, I didn't know him from anybody, but he saw the video when Tim came and did the video of me here at my shop. He saw that and took a chance to email me. And so I have something he wrote. I'm going to include that here in a moment. But he reached out to me, and no kidding, no joke, this guy spent 3 straight weeks, day and night, and the guy barely sleeps, day and night, understanding law of squares, writing several computer programs to understand law of squares. He helped me figure out a 17-year problem. I had no idea it was a problem. A 17-year problem. I've been doing the stator measurements wrong, and he figured it out for me. It blew my mind when he showed me that. So this is some of the squares he's been able to figure out. And then he wrote this computer program himself. This also helped us to understand that when using a 4x4 square, the weights in the stators and in the stator need to be all divisible by 4. This stuff, I wish I understood it. I really don't, but he does. It's just really, really incredible. Here's one of the computer programs he wrote to where you could input values if you want to use a 3x3 square or a 4x4 square or a 5x5 square. Interesting enough, now the squares, you just have the grid lines of 4 rows of 4, and then a 3x3 square is 3 rows of 3. With a 4x4 square, there is not near infinite, but it might as well be infinite. There is about a 9.2 trillion number combination of arranging those numbers. In a 3x3 square, because you have 9 digits, there's about a 800 or 900 or give or take amount of combinations you could come up with arranging the numbers differently. So the number arrangements are fantastic, and he figured that out. So you could change the weights, you could change the densities, and then run different calculations. He spent 3 straight weeks on that sucker until he was satisfied with the answers. And still, there's a few things that he just didn't understand, which blows my mind with everything he was able to get and comprehend and actually put it in a way that could be understood. Now here's, we were playing around with sizes. No one's ever done this before. Josh, this is a 6-layer SEG design using law squares. This is what Josh came up with. So if we were able to build a 6-layer SEG, this is what that's a massive, it's a massive system. And we could calculate the weight, but basically what I've learned is with this system, if it works right, could produce for 1 pound of weight produces about 90 watts. So imagine what the size of this system would do. Would be a lot of power. Now here's the thing that Josh found reading through all of Searle's books painstakingly, day and night. He read them. He discovered that what I had believed, that all 4 layers of the stator, the neodymium, Teflon, magnetic, and copper, I believed for 17 years that they all had to weigh the exact same weight, down to the gram, which part of that is true, is the gram weight is very, very important. But what I had falsely believed is that every layer had to weigh the exact same weight, and it's not true. So he figured that out and told me. So using the principles of that, I broke it down to using percentages. So that these layers are represented in percentages. Now, this factor sheet you see here, number 44, says, I would have made my first try as follows. This is John Searle talking. The system's a little different than what Fernando Morris, who developed the latest iteration of the SEG back in the 2000s. It's a little bit different size, but understanding that each layer needs to be a different size, and the neodymium, obviously the biggest layer because it is the electron reservoir. So I had to basically start from scratch with the calculations on the stator, redesign a new stator. Fortunately, I had not started version 7, and I recalculated out till I know exactly the right sizes to make it and the gram weight. So thanks be to Josh for finding this. It was a tremendous find to finally correct a 17-year mistake I've been making. Okay, so before I go here, I want to read something Josh. I asked him to print something out for me that I could read for this presentation. So this is from Josh Varner, who I'm hoping may eventually come on here at some point and be able to talk at some point. But here we go. I messaged Isaiah for the first time on Thursday, August 17th, 2024, after seeing a video on TikTok about free energy device that ultimately led to his channel and a wonderful video interview by Tim Ventura at APEC. I personally had never seen the Searl Effect Generator, but before spent a few days doing some homework on the device before I reached out to Isaiah. Surprisingly, he was kind enough to entertain my curiosity, and we've since then spent possibly thousands of hours trying to digest the mind of John Searle and his SEG. Absolutely thousands of hours. I really appreciate Isaiah and his dedication to the project. Without such generosity to teach, no replication would be possible because there is indeed a lot of variables to consider when building an SEG. At the end of the day, without wasting too much time, I do believe the SEG to have battery-like capabilities through a solid-state type effect, much like an open-air battery. If you could speed up the oxidation, it would create a dynamic charge throughout the system. This combined with each roller acting like an independent generator and building up a charge high enough to spark gap to the next layer. I could see how the multiplying factor of energy could be there, thus backing up Searle's claims. The fact that they can put a voltage detector up to a roller and get a green light is an indication of this. Now, that experiment was done by Fernando Morris. The neodymium cores, you can put a voltage indicator up to it and it gets a reading. However, having battery-like qualities to me doesn't just prove the claim it's a free energy device, or approximately called a COP1, because as mentioned, there are several variables Searle went through to manufacture the SEG, including the law of squares and unique AC wave magnetization. Having the local air ionized heavy enough to due to a magnetic vortex would indeed put the device into an overcharged state, producing max voltage and effect, which, tuned just right, I believe includes maybe flight. Searle claims into building around the law of squares has merit. Having never delved into such study, finally seeing the shared diagonals that exist numerically in each magical square grid does suggest a deeper meaning to life and how the transfer of information exists. The moment of inertia is the measure of an object's resistance to changes in rotational motion around its axis. It's dependent on the mass of an object and how much of that mass is distributed relative to the axis of rotation. Is it possible that Searle cracked the code to achieve the lowest amount of inertia possible, combined with a repeating AC waveform that could be spoken into, I think that's the wrong word, that could be made into resonance? In this case, the threshold would be a magnetic vortex formation. Then you'd have yourself a supercharged solid-state ambient harnessing generator capable of tremendous voltage potentials that could possibly fly away on you. That's from Josh. So moving on. Let's see. This is an artist's impression of the Searle generator's magnetic angling design. Helical in shape, the stator is slanted one direction while the roller's magnetic field is slanted in the opposite direction. Now, the upper color image the illustrator got it wrong, and the roller should be slanted the opposite direction. The lower image you see, the roller is slanted in the opposite direction, while the stator is going towards the left, the roller is going towards the right. So the magnetic fields are in this opposite of each other. Not opposite polarity, but opposite direction. Let's see. So the next slide. I believe this is the one. Oh, yeah. So January 29th of this year, January 29th, 2025. And as you see here, it's a ring magnet with a 14 gauge magnet wire just laid over it. I had a hunch to just try this, not expecting anything to happen. So I clamped that wire to a magnet in an experiment and hit it with, I think, around 4,000 volts. And it blew my mind with what I got. Interesting enough, I know the date when I started this was January 8th, 2008. And I found, going back January 29th, so how many years and days from when the day I started this SEG project, January 8th, 2008, until January 29th, was 17 years and 21 days. Now, 17 and 21 are incredibly important numbers for me in doing this project. I get off on numbers. I love them. So it was like, it was an important milestone, to say the least. So going forward here, this is the day that everything changed in this project. No more groove lines, no more cutting with bits, and no more water cooling. Everything could be done electrically. The roller magnet field lines are printed onto the magnets, or printed, quote unquote, onto the magnets. They're more like impressions. I found with ceramic magnets, I could do the exact same thing. Their density is 4.5 GCM3, lower density, and I could do several lines at a time with only 250 to 350 volts. The neodymium magnets took a lot more power through a shorter piece of wire. I had to use between 4,500 to 5,000 volts to get a very nice impression. Their density is 7.45 GCM3. On the left-hand image is a magnetic viewing film placed on top of the center image, and you get this nice line. It's a little loosely defined. It's not what I'm going for, but this right-hand image you see, those are the kind of soft tooth marks I'm really, really going for on the ring magnets. So with this discovery, just went from one thing to another, to another, to another. And still making more discoveries. Even today, I was working on the models, the magnetizing jigs, and working out the kinks. Because I mean, this is a brand new thing to me. As far as I know, I don't know of anyone else who's ever discovered this before. I know of John Searl, who used gigantic coils with megawatts of power in AC and DC fields combined to get similar effects in his magnets. I talked with a gentleman a couple months ago. Actually, it was last year in November. And he worked directly with Searl for about a year. And what he told me is, yes, Searl got these magnetic lines like what I'm getting, but they went completely through the magnet. It wasn't just a skim effect or the surface of the magnet. Mine, I'm seeing it goes in about 1/4 of the surface area, penetrates about 1/4 or 25% of the distance into the magnet, but not all the way through. Now, this was just a hunch I had. Let's just try it on one of the stator magnets. This image on the right is a stator magnet. Now, these colors are just lines I drew with a permanent pen. You see the black lines, you see the blue and the red. And I just laid 14 gauge copper wire. You can also use 15 gauge or 12 gauge, but you have to keep the leads very short. I just laid it on top, clamped it down, hit it with 5,000 volts, and it left impressions into the stator. Now here's from the Sandberg report. Here is using the oscilloscope. This is an old document. I have the whole document. This is just one of the pages. He talks about the orientation of the magnetic field, which is one of the things I'm engineering now too. So you have the magnetic field going vertically, but also horizontally, like sprocket magnets. Here is one of my some of the first prototype magnetizing jigs I made, and they work fairly good. I use kind of, it's more of a toroid shape, you could say. But what I found with this system is it needs to be basically in direct, it has to be magnet wire, not just uncoated copper wire, but magnet wire that is relatively in direct contact with the magnet. The magnetic field in these wires has a very close proximity range, so that the magnet literally needs to be right up to it, not just a distance away. So what I found is if the wire was any maybe in a quarter of a millimeter away, it wouldn't work, or the field would be dissipated. You have this fading effect. But as long as the wires were right in direct contact with the magnet, you'd have these nice, crisp, sawtooth lines. So this is some of the prototypes I did. I also did prototypes with this ceramic magnets, which they were ridiculously easy to put patterns into, like too easy sometimes. If you went too high in the voltage, it would wipe the pattern out. This image on the right was, I was thinking I could magnetize while also put a pattern into a neodymium magnet, and what I found is it actually wiped the magnet clean. It brought it down to almost completely unmagnetized. Oh, it was strange. This image on the right was a jig that I designed, and Josh Varner created the whole entire 3D print. And the hope was to be able to put this special pattern onto an entire segment of rollers, like 8 segments at a time. And they eventually set up 12 of these all together, hit a button, and all of it magnetized with these special patterns. That did not work out either. Let's see. So this is the next set of systems we're working on. And you see on the left side is you could do I think it's a Rodin coil kind of design. That's similar to the process we're doing, except we're not using super thin lines. I'm using either 14 gauge, 15 on up to 16 gauge wire. Too much power goes through it and it blows the wire up. So I'm pretty selected in the ranges I have to use, but the right-hand model you see is one of the CAD files that Josh developed after some of the basic designs I came up with. And this can be sized down or sized up for different size roller magnet segments, which we've done a few different sizes already for either the ceramic or the neodymiums. Now you notice here you have on the lower right-hand corner, you have the helical design. It's slanted at 21 degrees. And then you have 34 points and leave one of them empty for the spring effect. Now here is one of the patterns I produced lately on the neodymium. Here I am measuring with the oscilloscope and the FW Bell Gauss meter. They pair together so I can actually visually see the magnetic field. The bottom section you see the Milwaukee battery, and in the far lower right corner you see the Gauss meter probe, and then there's a ring magnet in there. And with this plexiglass or the polycarbonate device here, I can rotate those magnet sections to be very, very slow or ultra fast. And then I can visually see on the oscilloscope the magnetic pattern. Now here's more of a close-up. This translates the Gauss meter's readings into a visual readout on the oscilloscope. On the left side, you have the probe laying on top of the roller segment. So I can put different segments in there, different sizes. To me, I model this this design after one of Fernando Morris's designs, but I have a different one that I'm working on building that I believe will be more precise, and it can handle any kind of rings, because eventually I wanted to do those half scale, which is they're about 1/2 of an inch in diameter. They're very tiny. So I'm going to be changing that pretty soon and doing a fully enclosed case so no wind can go in there, no dust. It'll keep it just real clean. Very high precision work. Okay, so this is essentially the pattern that I've developed. The roller segment magnetization pattern, experimenting with alternating directions of current directions and also AC signal patterns impressed into these segments. The top image, you have the 34 lines, and then you have the center, which is left empty. Below that was you have the main big image with the green points. Those represent the magnetic field. What I found is when you slant these at 21 degrees and have the ring size correctly made to the law of the squares, and you put 34 points of magnetism with one empty, and you slant these things at 21 degrees, what I found is the points, the top of the top peak lines up directly in proportion to the bottom peak. So it's not misaligned like this or whatever, but you use those correct slants and the top will match with the bottom. Pretty amazing stuff, but it has to be 21 degrees, 34 points, and the size has to be exactly what law of squares dictates. So the geometry is very precision, but when you do it right, you line up with these patterns all being correct. Now the lower images is images I got from the web of John Searle's purporting of that's what the field should look like on a roller. The next image below it is one of my roller segments. I believe actually that his image up there is slightly need to be adjusted. Let's just put it that way. And that those lines are all on the segments themselves, and is indicated by one conversation with Fernando, that each roller segment has independent fields to itself, not just one roller has a pattern going up and down. So that is what I am currently doing. The hope and dream is to be able to put spotted hazy patterns along with a direct pattern. Thereby you have one, like on the lower, on these images, you see one is, they're kind of spotted, and then one is solid. So that the solid one represents the DC, the spotted one is more of an AC, like a pulsed, both going different directions. So that is what I'm gearing up for with this magnetizing, is that one wire goes one direction with current and the other goes the other direction. Alternate forms would be one wire goes to the system that is at the same time all DC, and the other going the opposite direction is an AC signal. Trying to create a frizzy pattern on the field lines. Now here is a CG image of the roller segment with one sprocket, with one is null. That's what I call it. On the right-hand corner is an image I took today of the magnet ring that it has the physical cut lines. Now this, let's see, I guess I didn't take a picture, but I have a ceramic magnet that shows this picture on the right side nearly perfectly identical, and it's all done electrically. I should have included it here. Sorry about that, guys. But it's all done electrically. No more grinding into the magnets. Here is what I believe is probably going to be the final, one of the final forms I'm going to build and complete. This will be the magnetic pattern of one roller. The top and bottom have sprocket magnets, all facing perpendicular to the main field. So the main field goes vertical, and the sprocket pattern goes out horizontal. The stator itself will have a matching magnetic pattern, and what that helps do is when the roller is rotating around the stator, instead of basically dragging it around the stator, it's actually the sprocket pattern acts more like gearing, and so it tends to roll instead of being just dragged. I learned that through the Roshan and Godin experiment. So the intended roller magnetization pattern with sprocket magnets and 34-point magnetic compressions. The magnetic direction is always vertical. North is up, south is down, but the sprockets go out horizontal. That is what I'm gearing up for. All 12 rollers will have this pattern on them. Let's see. So next. What's next for the SCG project? So this is what, not just this year, but probably next couple of years. Finalize the ceramic roller SCG and stator featuring custom magnetic wave fields. Complete the magnetizing jigs for both individual segments and full rollers. Because the stator unit is so big, I don't have the power levels with my simple capacitor bank to be able to magnetize the entire stator altogether. I'll have to do probably just one segment at a time. But that's what I'm gearing up for, is magnetizing all 8 segments of a roller at once. Build and test the magnetizing jig for a single stator magnet with precise field alignment. Identify and evaluate a suitable replacement for the neodymium element used in the rollers and in the stator. Design, construct, and demonstrate a half-scale model featuring the world's first full 3-ring SEG with the inductors around it to harvest electricity. Begin and complete the version 7, or I like to call it Gold Edition, 1-ring SEG with 12 precisely matched rollers. Matched is in that the size in relation to the stator is matched so that their orbits don't overlap magnetically or electrically. And I have all that. I showed it prior a few slides back with the size and specs, but all has to do with using pi as the divider, so that that the rotation doesn't overlap. I think it's called a cycloid geometry. Okay. Integrate real-time performance monitoring. Develop onboard sensors and data acquisition systems to track rotational speed, the field strength, and energy output in real time for each ring and roller. Also, I have a thermal scope now tracking if it starts to get cold. I've seen that happen with Mr. Delphin, who was in Russia. His system went below freezing, went to negative 17.5 C in 2 minutes. And he didn't have all the crazy fields I have. Nor was he adhering to the laws as listed in law squares. And he was able to do this, making the system go cold, like ice cold. Optimize self-sustaining operation, achieve a fully self-feeding SEG system capable of powering its own control and magnetizing circuits without external input. It's basically just energy harvesting, ambient energy, converting it into usable power. That's basically it without anything complicated. Field containment and shielding tests. Design and test magnetic containment strategies to minimize external field leakage and enhance safety for public demonstrations. The only safety consideration I have for public demonstrations is that it goes too fast, and after 395 RPM, the roller flies off. They weigh 3/4 of a pound, and if you got hit by one, yeah, it would hurt. So safety for the system and safety for anybody standing around it. Thermal behavior and vacuum environment test trials. That's what I would love to see. Study how the SEG components perform in vacuum or low pressure environments, simulating conditions for aerospace or satellite applications, possibly. Doing the half-scale model will be a big help because I can work out a lot of the bugs in the system I'm just not aware of when I do a full-scale 3-ring system. What I didn't write down here was the next model, which is basically version 8, is something I've had in my mind, something Jared Yates proposed I ought to do, and so I figured out how to do it, is doing a homogeneous version of an SEG. It is the very first version Searl ever made, and that's the one that purportedly worked. That system was a blend. It was not a layered system. It was a blend of magnetic materials, and he put waveforms onto it, and apparently it not only worked, it flew away. Maybe not. But that is a system that he first built. So version 8 for me is going to be a system just like that, homogeneous, ceramic magnets with no layering. It'll be ceramic magnets to ceramic magnets. It'll be scaled right, but it'll have the patterns directly in contact with each other. So you're not going to have spacing like the copper sleeves creates the spacing. So that'll be version 8 that I'm going to be engineering soon. So I'm kind of wrapping up here. I have a closing statement I want to make here. As I close up today's update, I want to thank everyone here and everybody viewing on YouTube for following along in this presentation. The Searl Effect Generator is slowly transforming from an idea into a possible reality, with each new iteration revealing new layers of potential and possibility. What was once just a vision or dream of mine is now a machine taking shape, made of ceramic, copper, and magnetic precision. The road ahead is still full of many challenges, but with each prototype, me and my team, we are working with each test and each spark of a discovery. We're getting closer to a breakthrough of a working model that could redefine how to harness energy. I'm looking forward to what the next year will bring, and I'm grateful to be walking down that path with such a supportive and curious community, such as yourselves. Big thanks. I'd also like to give a very special thanks and congratulations to the people who have made this journey of mine possible. To my wife, Marigold, your love, encouragement, and belief in this mission keep me grounded and focused. To Josh Varner and Jared Yates, my teammates, innovators, and friends, thank you for the countless hours, the ideas, and the determination you bring to this project every single day. This progress belongs to all of us. And thank you, Tim Ventura, for having me here to be today with you all.
Wow. Well, thank you, Isaiah. Thank you, man. I mean, and I'm not, it sounds like pandering, but I'm absolutely on. You are the best SEG builder out there. The quality, I mean, when I came down, the quality of work, the diligence, like the love and attention that you put into that is like light years beyond anything I've seen. Right. I was just absolutely blown away, you know, and I know Jared will back me up. In fact, I'm going to bring him in and let's do this. Let me see. I'll bring everybody who's kind of open there. Let's put our hands together and give an enormous applause to Isaiah Ritchey. And, you know, Isaiah, another thing, like just to add, you are a builder. And I know this is something that's close to Mark's heart as well, right? Like there are lots of folks doing theory work, but like Drew is building, Jared is building, you were building, right? It's like being able to build stuff, you know, even David is building some stuff. He's got some, as a theoretical physicist, he is building some projects too. So, you know, it's like where the rubber meets the road, and it's so important.
Absolutely. Absolutely is. Again, thank you for having me.
Oh yeah, absolutely. Yeah, we got a couple minutes left. Do you guys want to go into lab updates now, or do you have questions for Isaiah?
I got a question. In as few words as possible, can you explain the theory behind the Searl Effect Generator and how it's supposed to do what it does?
From what I've understood, it basically just converts heat energy into electricity. Nothing more. That's from everything I've understood researching this, especially the Russians' SEG attempt. It really, that's its energy source, is heat.
A thermal electric converter. So there's no anti-gravity. There's no flying through the roof like some others.
Mark, I could speak to that a little bit. I've studied it. In terms of formal theory, right? Searl was always really weak. He has the law of the squares. And, you know, the initial idea, Searl said, came to him. He fell off the back of a cart, I believe, and hit his head when he was a child. And he had this vision for it. He did claim there was anti-gravity. He claimed that, now the anti-gravity, though, came from multi-ring rollers. But
Correct.
like, if you're like, I know you're working on DNP, right? And so you've got kind of a theory in place. With Searl, it was much more kind of mechanically based, geometry based. You build it like this and it will start to self spin and it will take off. But like, there's Jared, go for it, man.
Yeah, I just wanted to also comment as far as evidence for this thing actually working, in addition to the Mr. Delphin video that I put in the YouTube chat there, in search of the effect of John Searl part 25. In addition to that one, some other evidence for this thing having actually worked outside of John Searl is that Russian group that Isaiah was talking about, Roshan and Godin. They spent like $1 or $2 million to build this gigantic machine. And they claimed they were getting like 27 or 30% weight loss around there. Well, I got to go see that machine in person. And when I saw that machine in person, yeah, and you saw it too. And the people who worked on that thing, who were not Roshan and Godin, they had gotten it from those guys. They said that they were able to repeatedly get 7% weight loss and get the whole giant room that it's in like cooled down super quick from just having it turned on. So it looks like there may have been more than one successful replication of this.
Yeah. I mean, for me, this is a cop out, right? I know I'm copping out here, but like, I think the historical value is the big part. You know, I mean, what Isaiah is building is like a dream. There have been thousands of people over the last 50 or 60 years who have been like, I want to build an SEG, and he's doing it, right? And so, like, for me, it's like making that dream real, you know. And who, maybe it doesn't lift off, I don't know, but the fact that he's doing it, that's the.
If I lose the model because it flies away, that'd be the best day of my life. One of the few best days of my life. I'm assuming my phone probably won't work, or the camera won't focus, or something stupid will happen. It'll just be gone.
Well, when the rollers came off, I didn't lose the model. I just about lost it in my pants, though. I'll tell you. When you were he was spinning it up, he had a guard, thank God, because probably it's happened before. But
oh yeah,
spinning it up faster and faster, and then it's like pop, bang, and I'm like, what the?
Yeah. So I've learned the kinks of that. It depends on the roller mainly, and the best speed I can get is about 395 RPM. About 275, they start to slow. You can hear the sound drop down, and they start to float across the surface. 395 is the most RPM I can get with my models. But I know as if I were to reduce the copper thickness of the copper layer, you could increase the RPM. But then I have to change the rules and the laws, and that's a whole lot of extra work. So I'm just sticking to the rules right now. My main thing and what I'm working towards is getting the neodymium to cool down. And if I can repeat Delphin's experiment, that's a massive game changer right there.
Yeah,
and that would break the law of thermodynamics, because like everything's supposed to get hotter and hotter. You know, the more variables you add into it, things get hotter.
Yeah.
So if stuff's getting colder, that already shows you something cool is happening. Did you get in touch with the people in Texas that have that really big Searl Effect generator?
I was able to talk with him about a year and a half ago. It was soon after Jared did. But Jared, you can kind of pick it up from there. What happened with their company?
They went out. It was too bad. And there's even a fellow APEC member. I'm not going to name him out, but there was a fellow APEC member who worked on that.
Actually, there were two. Yeah. There were two. So
two APEC members. One of them more recent than the other.
Yeah. Well, again, thank you, Isaiah. So why don't we do this? We're pretty close to the top of the hour. Why don't we do this? Why don't we give you one more applause for an amazing presentation? And this would be an applause for all of our presenters today. Also, you guys have kicked butt. Why don't we go into lab updates? So I've got just about 1 hour left. I have to bail early tonight because I have a child thing that I have to get to. So
maybe if I can just slide in one more sentence. So in the material I provided, there is a paper called Heim Theory Reconstructed, the current date, and then toward experimental validation, right? So everyone working in a lab, please have a look at this. This is just a first draft on ideas how to validate and what to look for when we want to try to validate Heim theory, right? And I think some of the stuff that we are already seeing might be a way to validate Heim theory if we do this right. So just have a look on this paper, reflect on it, and give me some feedback, and I will iterate over time on this idea, right? To really have experimental validation of some novel effects.
And Joel, I dropped the Google Drive link, the read-only link, into chat for your papers. I also, again, these are linked from the APEC website. And let me see if it's working. Yeah. In fact, let me put it up really quick just so you guys can see. I will do a super quick screen share. So on every event page, and I try to be pretty good about updating these, if we have a presentation and I think I need to bug Isaiah for his again, I uploaded all of those papers. And if you have more, I can drop them in there as well. And it's a read-only link, right? So people can go in there and download. Should be safe, virus scanned by Google and all that stuff. So
awesome, thank you.
Yeah, well, let's do lab updates, guys. Who wants to go first? We'll play Wheel of Lab Updates. Spin the wheel, around it goes. Where it stops, no one knows.
I want to hear from Jared about the Graviflyer.
I got one for you.
Wait, you had 2 extra fingers there.
Yeah. The Graviflyer,
Mark,
the
take
Graviflyer
us into
for
the,
me
take us
is
into the
done.
future, Mark.
Mark has been kicking, but I see updates from Mark throughout the week. For anybody who's interested in Mark's DNP stuff.
Drew's been updating nonstop. Like I wake up at 2 a.m., like go to the bathroom, like Drew's doing shit. He's like, "Yeah, we're fine." Like, okay, great. Where's your sourdough?
I got one.
You
I got
guys are
one, but I
kicking
want to
butt.
go last. You want me to go first?
Sure.
Yeah, go for it, Drew.
All right. What am I gonna do here? I'm gonna grab a hold of the share screen.
Yeah, and I know that you have some good stuff. I'm just trying to be sensitive because I know that you have proprietary stuff too. So I don't want to.
Yeah. Yeah.
I think Drew
this is all for public. This is all for public share. Okay. Are you seeing a graph?
Yeah. There we go.
Yes. Okay. Good. All right. Well, this was I don't know, about a month ago, April, May. Yeah, right about a month ago, and this was with a previous thruster plate design. This one was optimized for when you turn it off. The okay. Let me just go real quick. There's 2 kinds of thrust being shown on this graph. You know, first of all, we start up here at 0, and this is 1 plate. This right here, this area, that's like 1 plate. And this is 2 plates, and this is 3 plates, and this is 4 plates. So now we got 4 plates active. What that means is the voltage is turned on, and the field, the electrostatic field, is being created by free electron field. So it's the electrons can run around through the metal and do whatever electrons do if they even exist, and that forms the field. There's no bound charge at the beginning of this test. So this is all 4 plates are on. They switch down, so they immediately come down to around, I don't know, 0.7 millinewtons or 700 micronewtons. And then from here to as long as I want to leave this stupid thing on, which is usually dependent on how hungry I get, it's slowly building up bound charge, which is electrons are leaving the metal structure and actually being forced into the dielectric. And as they're forced into the dielectric, they become bound charge. And bound charge is a much more magical thing because it's not restricted by the penalty of relativity. There's a relativistic penalty for free charge thrust. And it's roughly 1,000x what bound charge thrust is. So bound charge makes 1,000 times more thrust. Unfortunately, it's very difficult to get bound charge into dielectrics. It's kind of like trying to drive water into glass. It just goes real slow. So this is where I was about a month ago, and you see it's around 1.55 micronewton or 1.55 millinewtons, and then you turn off the voltage, which is this red line right here, and you basically have zero voltage. So the only thing left is going to be whatever bound charge there was in the system. And here it is. It's whatever that is, 200 something. Oh, I'm sorry, a little over. Yeah. So it's actually charging. So it's actually charging the system the other direction. So it's making positive thrust. Or it's in the noise really. So this is the design from a couple of months ago, and the only thing I wanted to show this for is that when you turn off the voltage, this design was designed to go back to basically 0. So this is like an on-off demonstration. This would be a thruster that you would want to use for something like navigation and guidance. Okay? We go from this to last night. Ran this one for about whatever 18,750 seconds is until I went to bed. So basically started off at, now this was the 3rd or 4th time I had run this test. So I was starting off with a baseline of 2.4 millinewtons already in the plates from the previous couple of tests, which they're not shown here. So that's where this thing started, this previous baseline. Switch it on, jump down to, I don't know, about 500 or 600 micronewtons. This was a 3-plate assembly. I don't know if I mentioned that anywhere. Then I ran this thing continuously, that's the black line, and it's constantly adding bound charge to the system because the off switch, when you throw the off switch, it jumps back up here 1,000 micronewtons or 1,100 micronewtons. So I'm just going to go through the what this all means because there's not a whole lot of information for a bunch of squiggles on a graph. The max thrust was 5.75 millinewtons, ran at around 9,500 volts, 0.4 microamps. That's 3.8 milliwatts continuous power consumption. Less than 1% of that total power consumption had anything to do with propulsion. The bulk of it was just the electronics consuming power to generate the 9,500. And realize that when the 9,500 was switched off, the power consumption went to 0. And this thing will continue to make whatever that is, 4.5 millinewtons of thrust forever, as long as the vacuum is maintained and the charge is bound into that dielectric, which is a pretty long time. I've run this a week at a time. This thing will continue to make free thrust, if you want to call it free, as long as the system parameters are maintained. So that's just an interesting part of this test. The thrust breaks down to something like 1.1 millinewtons are related to free charge physics. The relativity penalty is enacted, and it's dependent on voltage. Voltage goes away, this 1.1 millinewtons goes away. 2.2 millinewtons, I guess I got this all backwards. Total impulse. I don't even know what I was doing. Oh, yeah, I forgot. This was based on the baseline stuff over here. It didn't have the previous 2.4 in there. But anyhow, 2.2 millinewtons is related to bound charge. So there's no relativity penalty, and it's not dependent on voltage. So this will stay on forever until the charge bleeds off. And if you disconnect all the systems, the charge ain't got nowhere to go. So it stays in there for weeks at a time. Total impulse is 4.53 millinewtons average force times the time it was running is 84.9 Newton seconds. If I'm selling propulsion, that's what you sell. You sell Newton seconds. When you buy a rocket propulsion system and you want your little satellite to stay in the sky or go to Mars or whatever you want your satellite to do, you buy Newton seconds of impulse. And this thing will make Newton seconds of impulse for free forever. That'll make that much. So from here to however long you want to measure, this thing will be making free thrust. We're making free impulse. And the last note is this thing is operating at around 2% Earth unity thrust to weight ratio. That's based on three 10-gram thrusters. Right now, my thrusters weigh about 10 grams-ish. That is going to change rapidly. So this number is going down to 3 grams because they're going to be about a gram of weight each by about this time next week. So cool things are happening here in sunny Florida.
Yeah, Drew, that is awesome.
Question?
That is awesome. If you're driving it that deep into the dielectric, you're driving these bound charges over time, it almost reminds me more of like a battery than a capacitor.
It's like a thrust battery. If you charge the battery, quote battery, with all of the whatever it wants to produce thrust, it will continue to make thrust forever. It's more like a supercapacitor. It's like you charge up a supercapacitor. And as you can see, you just can't hit it with force and expect it to charge instantaneously to 500 millinewtons. It just won't do it. You just cannot drive the charge in fast enough. But thanks to Jared and his insane ideas, this thing now charges faster than any thruster I've ever had.
those came from UFO reverse engineering too. Maybe I shouldn't
It's
admit that. Should
possible.
I
I don't want to mention it. I don't want to steal the man's thunder.
It totally did.
It's remotely
Somebody
possible
told me
it
about a
did.
flying triangle they saw, and they told me about what was on the bottom of it. And then Drew tells me what problem he's trying to solve. I'm like, wait a minute, I already totally know this one. Somebody already told me.
We went out on the internet and found a pattern that looked good enough, and I did some tweaks to it. And this is the third iteration of it, Jared. This result right here is from the third iteration of it.
Yeah, that's
the fourth
it, Drew.
iteration
This is
in
amazing,
the chamber
man.
right now.
It's absolutely amazing.
That's where it is.
How much faster does this charge up?
This is probably charging 5 times faster than it should be. At least 5 times, maybe 10 times.
Yeah, buddy.
Yeah, and I figured out that if I switch to single color on the printer, I don't get any overlap, so I don't get any fuzz, so I get much sharper lines, so I can actually make the lines smaller and pack more lines in there. So it's going to charge up even faster.
And I think one of the important things to point out, right, is that you have dropped your voltage down and you're using thin films. And so for folks who complain about ion wind, you're not doing ion wind because you've dropped that voltage way down.
No, look at this pressure. I mean, I'm down 4 times 10 to the minus 6.
Yeah.
Okay. If you can generate ion wind at 4 times 10 to the minus 6, please let me know how to do it. Because, I'd like to get a Nobel Prize too. So no, we're very careful to make sure that we're not generating any false information. And I could give an hour-long dissertation on all the ways that tests can lie to you, and you think they're real, and there's 100. There must be 100 ways I could falsify this data, and you'd never know it. Literally, you'd never know it. But the final result is we're going to take this into space sooner rather than later, and then proof's in the pudding.
Yeah, it's absolutely amazing. Well, thank you, man. Thank you so much. So maybe I should pick on Mark next. Mark?
Yep. You could just pin my screen, and then I'm going to walk around with the laptop and show everyone what's up.
Yeah.
So, yep, Mark Sokol here in Hawthorne, New Jersey. I'm trying to take Drew's little tiny bit of thrust and actually lower the mass of the craft so we can actually get somewhere. So we're working on our subatomic spin orientation machine. And right now you can see it's actually taken apart because we removed the chamber, the RF cavity, and we were doing some maintenance on it and some, fine tweaking. So the chamber is right over here. It's a TM110 mode. And thanks to Kurt Zeller, he actually did a lot of work on this. There was a lot of very exciting discussions going on about which modes to use. And one thing we learned from these discussions is don't trust AI because it hallucinates and comes up with really bad solutions. So thankfully, Kurt set us on the right path. A couple things that we modified about the chamber. So this chamber was made by George Hathaway, who worked with Daniel Alzafon on this. Daniel's father, Frederick, is the one who came up with the theory. The one thing I did is we added some Teflon over here. So the chamber is electrically floating. It's not connected to ground. So we're going to be able to apply potential, like electrical potential, to the chamber and have the entire sample run at different potentials to ground. And we found some papers that actually indicate that would be helpful for the effects we're looking for. On top of that, I've been reading this book that came out a month ago, Triplet State Dynamic Nuclear Polarization. It's a method to increase the levels of nuclear polarization dramatically at room temperature and low field. And that uses light to excite pentacene, which creates triplet state electrons, which increases your coupling, your microwave coupling to the material. So it actually lays out how exactly it needs to happen. The light needs to pulse first, and the microwaves turn on, and that happens simultaneously with a a small sweep of the magnetic field. So the magnetic field is like constant at around 1100 Gauss, and you're sweeping only like 5 or 10 Gauss. So it's a small amount of magnetic field that's actually changing. The reason for this is to allow you to excite all of the modes of the sample, because there's several different spots where it would like to get excited. They're all very close to each other. So you just do a small sweep and then you have everything shut off. And that's when the DMP actually builds up. So this chamber had coils on it. I didn't even realize that at first. I thought they were temperature sensors. So we hooked them up. I wired them up. One of the leads were broken, so we had to fix that. And we were looking for ways to power it. Tried using the bipolar power supply / amplifier, and we couldn't get that to work. But what I did get to work is a simple audio amplifier out of a car. Like people have these in their as their audio amplifiers for their cars. You know, this is like a I think it's a single channel and 3000 watts. It works pretty well. I was able to get up to 75 Gauss actually in fluctuation, which is a lot more than I need. But the coil started getting very hot to a point where we started to smell, you know, the magic smoke was getting released. So the next thing we did is we added these copper cooling tubes, which are now part of the system. And this is going to be hooked up to our water chiller in order to keep it cool. Another problem, if we're hooking it up to our water chiller, then the chamber is no longer be grounded. So we're taking all of the water out of the water chiller and we're replacing it with transformer oil. So that's another project we have going on over there. There's a bucket. We're trying to empty it all out. I don't know if we'll get everything, but it's going to be a process to get all the water out of the system and replace it with transformer oil. Another project I am working on with Mr. Patrick. He's our laser guy, and we're trying to get the right frequency necessary to excite it. So we need to be in the orange yellow range, which is like 590 to 620 nanometers. And we also need short pulses. So we need a laser that can pulse on demand for a very short amount of time with high intensity and be at that frequency. So what we recommended to try is using the nitrogen laser, which gives us the pulses, but it's in the ultraviolet. And then we have, this is a dye laser conversion. So there's a little dye in there and it's mixed with vodka, actually, very high concentration, 200 proof vodka. And that converts the UV light, which you could barely see on my hand. It's like fluorescing a little bit, and it shoots it down to the correct frequency. The reason why it's not coming out as a actual laser beam right now is because you need more optics for that. So we have those optics coming in the mail. I have a whole kit that's coming in, and then we need to learn about that as well, how to do that. But that's the next project we have going on with the laser lights. We've also been doing some work on some signal generators we have, trying to get this 20 gigahertz signal generator up and running, and that would allow us to run some DNP at even higher frequencies. We're looking at a different wave mode potentially, try for much further down, but for now we're going to stick with this same wave mode. It's probably one of the best ways we can go about it. I also got a English wheel over here for this is a nice little nifty tool for straightening out waveguide materials and making things really flat or rounded, however you want to do it. Actually, one of these the inner plates in here are made out of silver. When I pulled it out, it had a whole bunch of little creases and bends in it, so I was able to use that to straighten it out and make it nice and smooth. One final thing in this book, this guy basically explains. It's basically his PhD dissertation turned into a book with very accurate descriptions of how exactly they achieved 250,000 times increase in signal to noise ratio for NMR using this method. And he calculates, this was for hydrogen atoms, he calculates that it was around 70% is the theoretical limit of the level of dynamic nuclear polarization that's achievable using pentasene. But in the final page of his conclusions over here, at page 142, he says with zinc porphins, it's possible to achieve a level of orientation that would be 1 or 100%. So for the next version, I got some of that stuff. Got it from Sigma Aldridge. It's zinc. Zinc is actually used in a lot of materials that phosphoresce and fluoresce. So triplet states are related to phosphorescence and fluorescence. They're one of the in-between modes where two electrons are kind of pointing in the same direction. They match up, and they're able to influence things a lot stronger than if it was just one electron alone. Like two electrons go farther than one. That's sort of the idea. And finally, we have our rotating electrostatic field generator machine. Still working on that. We're increasing the size of the rollers. It's probably a project for next week. We need to build a couple more of these, but that would allow us to go from 4 inches we have up to 21 inches, and we should see a stronger effect with that. On the inertial propulsion front, Nino Mercantilio, one of the engineers who comes by here in the morning, he helped complete this project. It is now up and running. It's remote control. So it's basically propellantless propulsion that's remote control. So you have to like move it with your finger. So it's probably a cute little demonstration. It produces a small amount of thrust. It'll scurry across the table. Probably going to stick wheels on it and use it for demos for, a conference or something. It would be a great thing to show off at a conference. Just a proof of concept, which is about as good as it's going to get for those kind of propulsion systems. And yeah, that's pretty much it for me. Tim, are you there? Get everyone back in.
Yes, I am here. Sorry. Okay, well, so I think Curtis, is Curtis still here? Does Curtis have an update for us?
What about Jared? Jared's going to show off his Gravifly, right?
I got Art's parts updates.
Yes. Okay, you want to do Art's parts updates? Okay, I'll take Curtis out for a bit. Okay, go for it, Jared. Do you want me to spotlight you?
Sure. I got to present some stuff here.
Oh, okay. Yeah, put it up for us.
Just Tim, before I forget, there is a Joe Rogan interview, 3.5 hours with Hal Puthoff.
Yeah.
Whatever his name is.
And Hal said
it
in
is
that interview,
worth listening to it.
He says that we have 10 recovered UFOs. I don't know. That's all he does.
Is that, you think the guy is lying, or is he on drugs, or do you think he's real?
Somebody else came out before him after the Grush stuff that said it was closer to 120. They said it was like one or two a year, and they've been getting them mostly from the ocean.
I mean, I don't know. I'll tell you that the thing that I was thinking about this last night, this is just kind of an aside, but the problem is there are so many people out there telling so many different stories that like, I don't know what to believe. And again, this goes to the whole, I mean, if you believe in conspiracies and disinformation, that's the best way to do it, right? It's hard to stop information from getting out. It's a lot easier to just dump tons and tons and tons of fake information and then just let people just give up on it. So, maybe I'm a case in point. I'm the official normie in the room for this community, but yeah, I was like, I'm in a perpetual state of ontological shock. And I'm like, why is that? It's because I hear so many different people with so many different stories that I have no clue what to ultimately believe. So,
Speaking of not knowing what to believe, Tim, if you want to...
Okay, take it away, Jared.
All right, so I have been going through every one of the letters given to Art Bell and Linda Howe, and like line by line, word by word. And you can see my comments on the side here. This is just really a doc for me. I might share it at some point, but I've been going through this thing trying to profile the crap out of the guy who wrote these letters and possibly his grandfather that he claims originally got the samples. And from all of these, I ended up finding some good stuff about specific spelling errors they made. I was able to make a profile of the grandfather and the grandson. there's a lot more going on in that document, but the gist is that there's two ways to take the letters. One way is to take it at face value. The other way is to take it at partial face value. Obviously, you could take it at none, but then it's completely useless and why even read it at all, right? So if you take it at face value, you come up with those profiles of these people that I came up with. And I went through like every single public and semi-non-public name associated to not just the Roswell crash, but all of the publicly known crashes from 1947 to 1952. And I've cross-referenced all of these people. And like, it ain't any of them. And I've narrowed down this window of who that grandfather could have been. I've narrowed it down so far to a team of like a couple of people. And it ain't them. There's like one or two people in there that I can't get their names, so it might be those guys. But so I also kept going down the other way on the grandson, the person who wrote the letters, on his profile, trying to figure out who could this be, because he gives a lot of personal identifiable information in there as well. And I went through all the possibilities there. One weird thing I found, if anybody looks at these letters, he uses English UK spelling enough times that it's a little weird. So some of the personal identifiable info in there suggests maybe he was coming from, RAF and was like doing some military exercises here in the US. But all that said, finally, the most recent update is he signs every single letter A friend, and the letter A is capitalized and the letter F in friend is capitalized. And wouldn't you know it, the guy who was in charge of Project Blue Book for all the decades, his dude was Lieutenant Colonel Friend. The guy who may have had access to some UFO pieces and materials, but definitely needed to like keep a low profile. Lieutenant Colonel Friend. So you want to talk about being cheeky? That's about the cheekiest.
What was his first name? Was his first name like Al?
I don't know.
Because you said it was from
it doesn't
capital
really matter.
Friend.
The dude was the first Tuskegee Airman, or one of the first Tuskegee Airmen, and he lived all the way up until like 2019. So like tons of red herrings throughout there. Other things in there suggest that whoever wrote these had a strong background in sci-fi, as well as a very deep understanding of ufology, and maybe even a few less than public things in ufology. So all of that said, like, this Blue Book guy actually, in some ways, if you go for partial acceptance of the letters, he fits the bill better than anybody. And he even signed it with his name, Friend. Okay, I don't know. So there's that side. I have one other thing that I've been doing here that's kind of interesting. Let me share this screen. Okay, so there is, this is from the National Archives. And it was a picture that I just randomly came across. But the interesting thing about this picture that you can't really see here too well is right above this craft, there's a couple like weird looking rings that almost look like a dipole. And then if you follow a straight line from that, there's like a third one. And I've actually found a fourth and a fifth one in this image. According to Project Blue Book, this was originally taken in 1964 by a guy. According to Project Blue Book, this picture is a hoax. It might be a hoax. Some parts about this don't fit the description by the guy who took the picture. The guy who took the picture said the size of this craft was like 70 to 150 feet and, whatnot. Well, if you do some analysis on this image, it looks like this thing is closer to the camera than these trees, which, like Blue Book said, yeah, it's just a hubcap. Well, let me share one other picture with y'all here. This will take me just a second to open up.
You realize we're going to have to do an intervention for this boy if he keeps this up.
Most certainly. All right, here we go. So I did some image enhancement here. Now, granted, this is not all 5 of those ringed things that I was talking about, but I think this makes it a little easier to see. This looks like a dang dipole, dudes. Also, the fact that you get this kind of egg shape on this one is interesting. That follows with Ed Teller's 1992 paper about gravitational waves from a dipole. Anyways, so I've been trying to do some analysis on this image to see if there's any way to estimate field strengths, field orientations, all sorts of different usable, engineerable information that may come out of this. Yeah, it's a weird one. It's a weird one. If if true, so far the only instance of Faraday rings that we get from a UFO comes from Ray Stanford from the 1970s. For reference, Faraday rings, as I understand them, light coming from the sun has like every possible polarization, right? Well, if you have a really strong magnetic field, then that means that one direction of circular polarization is going to have a different speed of propagation through it than the other. And so you have this splitting of those two circular polarizations that gives you these rings. The stronger the magnetic field, the more rings you get. So if you do some calculations and estimates on Ray Stanford's pick, it's like 10 to the 3, 10 to the 4 Tesla, 1,000 to 10,000 Tesla, which is crazy, insane, right? We make like 20 to 50 Tesla for like fusion reactors. Like we don't deal with stuff that high. But this one, I'm still doing calculations on it. It could be wrong, but it looks like it's much, much lower strength, which is interesting, which is unique, if indeed the case that this is what I think it is. Now, people try to say that the Faraday rings for Ray Stanford are actually something called Newton rings, which are an optical artifact that you get. One kind of caveat to that is that Newton rings are usually pretty round, and it takes a little fudging to get them to kind of like stretch in a certain way. Well, what we're seeing in this image on Ray Stanford's, you just see like off the tip of one corner of the craft, you see the rings there. On this one, we got 5 spots on here, 3 of them in a straight line, but it actually starts having this curvature that occurs, which could be a thing, could be a nothing. I don't know what to make of this picture yet, other than I'm going to keep going with it as if it has engineerable information in it and see if the numbers match up to what you would expect for a 30-foot diameter, 8 to 10 ton craft that, you know, going off of all the other sources of information that we have about some of these UFOs. Anyways, so it's been a deep dive, lots of Roswell learning, lots of early crashes learning, and a lot of genealogical records searching of hundreds of different individuals to see if they were the arts parts guy.
Awesome. Jared, thank you, man. Thank you.
I'm not building anything, but I got one thing to build in the works that I'm not ready to talk about yet, but it's pretty cool, and we'll see if something can come from that. Oh, and I'm trying to get some ComSol started on some of the nanotech that's present in arts parts. Okay, that's all.
And we'll give Curtis a couple minutes here. He may have an update for us. I'm not sure if he does. Well, I see an update file here. Curtis, are you there? Okay, I just texted him, so it might take a sec. Yeah, I actually have, Jared, I have your Faraday rings thing. I don't even know. I don't know if I should show this or not. It might be too super secret to do. You know what? I can run through it real quick. I'll run through.
Do it.
Are you guys?
Show it off, Tim.
Yeah. Okay, I will. Okay, hold on. This is partial. It's not done yet. Give me just a sec. PDF. Okay. Present, share screen. Oops.
Hey, Jared, what kind of, was that a picture taken off of a screen or just a digitized black picture? What was that again?
You can download that picture from the National Archives. It is ID number 303938034.
Yeah, anyways. let me run through what I have real quick for you guys. And this comes out of so this is UAP detection and analysis. I wanted to focus on multimodal detection. I'll go through real quick while we're waiting for Curtis here. So I have, let me see, 14 different kinds listed: active radar, which is traditional radar; passive radar; microwave band detection, which is similar to what the RB47 incident showed, right? Which is what led to the Alzifon model. X-ray, gamma ray spectroscopy; proton magnometer, which is one that I've been excited about for a long time. Then you've got traditional optical, right? That's photos and video. Forward-looking infrared or FLIR. You have ultraviolet optical photography. Then you've got the Faraday rings that Jared was just talking about. He sent me a couple photos for that. I'll show those. Gravitational lensing, that's Chad Wanless stuff. Then you've got Geiger counter and or scintillator or cosmic watch. portable neutrino detector. That is something that is really new and very kind of speculative. Then you have audio detection and sonar, right? And the sonar is obviously underwater. So the idea behind this was, why do we want to use multimodal detection? And by multimodal, I mean, you're going to have a camera, but you're also going to try and pick up other stuff, right? We saw that in the Nimitz sightings, where they were able to get radar data and overlap that with infrared, the FLIR, and then they were able to overlap that with optical visible video, right? And so when you combine all of those, you get a data set that is more reliable than any single one alone. They kind of multiply each other. And there are several different reasons for that. But I made, again, kind of a list here. So this multimodal data detection is going to hopefully let you determine the size, speed, and flight direction of your UAP, right? It'll also help you determine whether that UAP is a solid physical object. And I think that's really important, because people have taken photos in the past of lenticular clouds. Okay, well, it looks like a solid physical object, but it's just a cloud, right? So another thing, if you're analyzing, especially stuff like microwave frequencies and things like that, this may let you identify NHI technosignatures. And this could be a number of different things. Maybe you're picking up like nuclear signatures of some kind. Maybe you're picking up strange EM signatures that you know don't come from an aircraft. There are a bunch of different things that we could basically add into our data set to say, hey, look, here's some video of this object, and I picked up this other stuff, and there's no way that comes from an aircraft, you know? So we've got that. Another thing is detecting and analyzing electromagnetic signatures for communications or propulsion. Again, the Alzafon model came out of what is believed to be propulsion electromagnetic signatures. So if we're able to capture as much data as possible, maybe we'll get a better idea how these things fly, and maybe we'll pick up some communications between them as well. Another thing, especially stuff like infrared, may let us detect the temperature of the craft as well as temperature changes from things like air resistance. Now, one of the 5 observables, I believe, is that these things fly without air resistance, and the same would apply to USOs. They pass through water, apparently without water resistance. But the idea is, if we can map temperature to different parts of the UAP hull, then maybe we'll see more about what's going on there. Another thing with multimodal detection is red and blue shifting, or gravitational lensing. This comes out of Chad Wanless photos, and I have those later in this presentation. The idea being, if you're taking photos and video, you may see distortion. That distortion could be an artifact of the camera you're using. That does happen frequently. It may also be something that is related to gravitational lensing. And if we can map that down and calculate it, then maybe we could tell more about the drive systems these things are using. I mean, again, Jack Sarfati has talked about the lower power warp drive. Things along those lines may lead a signature, right? They may have a signature that we can use to understand exactly how it's working. Another thing we can use multimodal detection for is detecting stealthy objects that are masked in one spectrum. There is this idea out there that UAP may or may not be able to become invisible. Okay, maybe they're not invisible in all of the spectrum. And so if we can't see it in optical, maybe we can see it in IR, maybe we can see it in UV, maybe we see it on radar, right? Again, having more of those modes available to us reinforces what we're seeing. And it may also tell us other things. For instance, if you see something wink out and it disappears, but it's still on radar, then you may have an idea that they're using some kind of stealth. So again, these signatures reinforce the credibility of anyone, especially in this day and age, right? Because AI makes it really easy to fake photos and video. And it also lets us rule out stuff like aircraft, clouds, mirages, all sorts of things like that. So I'm going to skip through here. So why use multimodal? Photos have always been able to be faked. Jared mentioned like potential hubcap a few moments ago. Okay, people have been throwing hubcaps and taking photos of those for decades, right? AI software makes hoaxes even easier, you know? Even if we're not sure if it's a hoax or not, photos and video only capture a small amount of data. And that's one of the problems with UFO photos is we're going through these digital photos pixel by pixel saying, is this JPEG distortion, right? Or is this something else? We only have a little bit to work with. So the more data across more spectrum we're able to capture, the more depth of analysis we're able to do. Traditional photos don't provide detailed insights to understand what kind of propulsion mechanisms might be going on. They also provide easy fodder to skeptics. I mean, for as many people are uploading UFO photos out there, we also have just as many skeptics out there picking them apart, right? And unfortunately, like when you upload a photo, it's going to pick up stuff like JPEG compression artifacts, even if it didn't have a lot to begin with, because every time you upload those, they get squished a little bit more. So instead of giving the skeptics more fodder and getting into this he said, she said cycle, right, where someone says, oh, it's real, and then the skeptics say no, and here's 20 different reasons why it's not. We want to try and capture more data to be able to say, here's what we got, So again, a single data source increases the potential for error, and photos and video are susceptible to zoom and blur issues. So I just ran through some of these. I don't even know if I should go through them, but active radar is the gold standard for airborne object detection and tracking. That is what the military and airports use, right? Doppler radar is more accurate than ever. So radar is getting better. It's being used for weather patterns and things like that now. One of the things that I wanted to highlight, and Doug Butner pointed this out in the UAP Fight Club chat the other day, was most military and airport radar systems use filters to eliminate noise. So that could be small objects and ground clutter, right? This is something that kind of came to light during that Balloon Gate scandal where we had these Chinese weather balloons. Well, how come these things weren't showing up? How come it was a giant national security issue? It was because apparently at least some of them had been filtered out on the radar. The radar is looking for aircraft. It's worried about aircraft penetrating our defenses. It's not looking for a balloon. Okay, well, if that's the case, maybe it's also not looking for UAP. So I have a couple of photos. This goes with the radar part. 1952 Washington, D.C. UFO sightings. Saucers over D.C. This was tracked on radar, and at the time, they blamed this on temperature inversions. They said that basically those were causing the bounce back on the waves that was causing false signatures. So again, any one source of these data points can be in error. So that was saucers over DC. More recently, we've got the 2019 UAP swarm encounter. So Jeremy Corbell actually leaked some video of this, and it is radar. It's UAP showing up on radar. So as you can see, we've got like 75 something years of this, So radar is there. Passive radar, I do not have any photos for this. I will try and find some. This is what Mitch Randall has been working on. There's a fellow named David Hooper, I believe, also. And the idea is with a regular radar system, it sends out a beam and measures the response time, right? So I hit something with a beam, and then I'm going to measure the bounce back time for it. With passive radar, you're using a separate beam, and there are some big advantages to that. So you can do with FM or radio transmissions, right? But Starlink and DirecTV have made this more reliable. And basically what you do is instead of having to go through all the regulatory hurdles and, everything, right? Because you can't just blast radar beams out there. You can use beams that are already in place. You measure the beam, you measure the signal response time. It is not quite as good as active radar, but again, Starlink, DirecTV make it better than it was in the past. microwave band signal detection. This is kind of broad spectrum. I was thinking of the RB-47 incident. That was an Eland aircraft that recorded what are believed to be frequency emissions from a UFO. This is what led to Alzafon getting into dynamic nuclear polarization. So if we can pick up any kind of electromagnetic package from these craft, it could tell us more about what's going on. Another one, X-ray and gamma ray spectroscopy. This was used by UAPX, sort of, kind of, during a field investigation of UAP at Catalina Island. It's also used in astronomy. So, we're looking for very high energy X-rays or gamma rays. And that could tell us a lot about what's going on with these craft. The other one, proton magnometer. Again, I don't have a photo. I haven't completely finished this thing yet. It's a proton precession magnetometer, uses the principle of the Earth's field nuclear magnetic resonance to measure small variations in the field. And so it allows you to detect ferrous objects on land and at sea. And so in many ways, from what I've read, because I'm not an expert in this, they are very, very, very sensitive. I've heard that you could see someone flipping a coin a mile away with one of these things. The downside is this is not a detailed imaging device, right? And I believe it is focused on ferrous objects, so it may miss other types of materials. So this is just something to add to our toolkit, So I wanted to go through optical visible spectrum. This part isn't really done, but what I wanted to try and do was showcase we know how this works. Someone sees a UFO with their eyes, right? And then they reach for a camera or a smartphone. So I think one of the important things to point out here is that the quality of this video is improving dramatically over time. Smartphones are transitioning right now from 12 megapixels, which is what your selfie cam does, to 48 megapixels, which is what the raw version of the new iPhone camera does. And I believe Samsung has one too. So our image quality is about to get 4 times sharper for all of these. Another thing that we're seeing is an improvement in file types. It's going from JPEG, which has inherent compression, to file types like HEIF. And so you get a higher, basically a much larger color palette. So you get more detail for stuff like red shifting, blue shifting, and you get less file compression. So you're going to have cleaner images. So we want to try and use as good as we can in terms of photos and video, and that's getting better, every year. The other one is FLIR, forward-looking infrared. There are a number of different tools and technologies out there. IR imaging is used for all sorts of stuff. They use it to look for, like in factories, they'll use it to look for heat sources, right? The military obviously used FLIR for some of the Tic Tac videos. And I think I have a couple of images of those. You're going to get heat signatures there, absorption or emission of heat, right? So earlier we were talking about the Searl Effect Generator. Supposedly that device runs cold. If that's the case, it's going to show up in a different color with your infrared imaging than it does with standard imaging. That can help tell us what's going on. Is this thing emitting energy or absorbing it from the surrounding environment? That would be very interesting. It could tell us more about what's going on there, as well as if we use calibrated equipment. Again, this exists for infrared. It could tell us what the temperature is, and it could help detect stuff like air friction. So these are existing photos. The 2 on the left are from the Nimitz incident. The 2 on the right are more recent. So these are existing examples of infrared photography of UAP. Okay, so then ultraviolet, I have been searching. I was not able to find any UV images for UAP. There are lots of them out there. They use this for a number of different things. Again, it's a different spectrum. Instead of being lower than visible light in terms of energy, it's higher than visible light in terms of energy. A lot of insects use some UV imaging. Another interesting thing is most camera equipment, including your smartphone camera, can see a little bit into the UV spectrum. They actually use filters on those to prevent that from happening. And there are companies out there that produce basically filter removed cameras. They'll take them off the lens. They'll take them off the sensor. I believe you have to use somewhat different lenses. If I remember right, you have to use quartz instead of glass. That works better. And you can see near field UV with just regular cameras, right? And so then your megapixels are going to continue improving. The cameras that I've seen out there are more of the 12 megapixel size. They're trailing the commercial market, but hey, it's getting better. They are used already for a number of different things. One of the big ones is sunscreens, believe it or not. They'll do photos to see how well sunscreens work, because the sunscreen will be absolutely clear in the optical spectrum. You put it on and it will be completely white, right, as it reflects the UV in that spectrum. There are also specialized cameras that can see a lot deeper into the UV spectrum. Faraday rings. So this is their very high intensity magnetic fields. Jared was talking about this a moment ago. Ray Stanford took photos he believed show Faraday rings. Jared Yates and Charles Crawford dug in there. These are concentric circles of distortion in optical images. So these are the images that Jared showed me. He sent these over. These are somewhat enhanced to show the Faraday rings, but the general idea is you're going to see these ripples because it delays. Basically, you get an effect where it delays part of the light traveling. So I'm not going to get too deep into that, but this is something where very, very high intensity magnetic fields may create these. Gravitational lensing. This one is really exciting for me because the Aguadilla UAP appeared to split in two and come back together, and there appeared to be what's called shape-shifting. Shape-shifting is something that is very common in UAP reports, and no one has a good explanation for it. Well, Chad Wanless believes that optical distortions in UFO photos and video could indicate gravitational lensing, which is just light being bent in a strong gravitational field. And so this could be used and measured to understand or map drive systems. It may include red or blue shifting, mirage effects, objects simply disappearing, reappearing later, potentially splitting in two, as well as just all sorts of different shape-shifting behavior. The craft itself may not change at all in shape, but the light that is coming out of it, the light that's bouncing off it that reaches your eye, is being bent by this field. And if the craft is using some kind of a warp field, as it travels, especially when it turns, that field is going to be changing. It may change the way the light reflects. So the downside to trying to map these is we may mistakenly identify them based on JPEG compression, right? Because you get those little pixels around the image, MP4 compression, which is the same thing in video, as well as normal photographic distortions, especially in your older photos. Those cameras weren't that sensitive, so they had to keep the lens, they had to keep the iris open longer, right? So you hit the shutter, it opens up, light comes in. If something is moving, you could get some blur. That's not from gravitational lensing. That's just normal blur. So these are a few of the images that Chad Wanless has shared, and he actually just published a book about this. I would suggest if anybody is interested, look up his name, Chad Wanless. He is with MUFON, and he just finished working with a PhD electrical engineer to try and map these out. These are just a few of the images that he had. And again, you could see these series of white dots are what he believes to be distortions from gravitational lensing. Okay, so another one, this is going back to UAPX, and I need to make this slide a little more clear, is Geiger counter, cosmic watch. I believe scintillator is another thing. There are several different tools that are used to measure radiation, right? They use them in nuclear plants, all sorts of stuff. It would be interesting to be able to pick up readings from those. My thought is for something like that, it's probably going to be super short range, but UFOs have been associated with residual radioactivity at purported landing sites. There have been reports of personnel in the vicinity of UFOs, people who stand too close or it flies over their head, getting symptoms that look a lot like radiation exposure. And then there's also a tremendous history of correlation between UFOs and nuclear materials, storage, processing, vehicles, weapons, you name it. So it would be interesting to see if we can pick up data on that. Maybe nothing comes out, but maybe something does. Portable neutrino detector. This is very, very new, very hypothetical. I actually have a story on this. A university just developed this a couple of years ago. They are doing things a little bit differently. As you may know, traditional neutrino detectors, you have like this massive cavern full of light detectors, and you fill the thing with water, right? Like in Antarctica, and you just wait, and maybe like a year or two goes by and you see a flash of light, and that's your neutrino. This thing apparently it's tabletop, right? So you could it's portable, and it is a little bit more sensitive in a different way. So maybe that's something. The reason I wanted to mention this was this UAP nuclear correlation. I've wondered if it could be related to the fact that neutrinos really aren't shielded by traditional nuclear shielding. So in other words, your aircraft carrier has a nuclear power plant. Okay, so maybe the radiation is very, very well shielded by the craft, by the way that they built it, by the tons and tons of metal that surround it. Those neutrinos are going to go right through it. So if UAP are seeing neutrinos, it's going to look like a light bulb, which could be why they are attracted to those. So if that's the case, maybe we should be checking them for neutrinos as well. Then the last couple here, because I think I've only got a couple slides left. Oops. Audio detection. This is kind of a no-brainer, right? Some UFOs have been reported with a humming sound. Some people have reported other sounds. So the question becomes, okay, can we do audio detection? Maybe we can record a sound. Again, by itself, not very useful. But if you're able to get video and you get audio with it, who knows? Another thing that we might be able to detect there is smaller sounds, right? Lesser sounds from things like air friction, air pressure. If you hear a whooshing noise, that may show some interaction with the environment. We could use that to help provide more data. And then another aspect to this is an atmospheric sonar system like Tesla's used to use for imaging, right? Most cars still have backup alarms that are similar to this, where basically it just sends out a sonar ping like a bat, just like radar, except that it's sound and it listens for the response and it can tell you how close things are and provide some imaging. The upside to something like this is it gives you another mode for imaging that's completely unrelated to others. So maybe you've got interference with optical, you could pick it up with audio. The downside is obviously these are going to be very, very short range. So there's audio and then there's sonar, and I didn't want to leave this out. Basically, this is just audio imaging in the water, right? And the reason I wanted to put this in was it has reportedly detected several UAP, USO in historical naval encounters, right? And the details for this have not been as forthcoming as I think we've all hoped. But there have been several rumors of very big encounters where you get sonar detection of, I believe, what they call fast movers underwater, right? And so that is all basically underwater audio. It can help identify distance, speed, and size for submerged UAP. And depending on, and again, I'm not a sonar expert, maybe you could listen for sub sounds also to tell, maybe it's giving off, I don't know, some other noise. I did have a couple of general considerations. Optical imaging is getting better and better and better. As it gets better, we're going to see higher quality UAP video emerge. I think that's something that is easy to forget, right? But you look back to the beginning of UFOs and you get this grainy, blurry image, and somebody says, "Oh, look, it's an alien spacecraft." Okay, well, who can tell, right? It's a bright, overexposed light on a dark background. Okay, then you fast forward to stuff like the 2004 Nimitz, where it's still difficult to tell, but you can kind of see an outline. You can see the outline of it traveling. You can say, okay, there's more detail here. Well, by today's standards, those are incredibly outdated images. So as these things improve, the imaging that we have is going to get better and better and better. I think one thing that probably won't get better as well is the fact that these are at a distance. And if you're taking smartphone images with them, you're always going to have problems with zoom, right? And so that is something where like people take their smartphone out and they try and get an image of the moon. And it's the same thing. It looks big to you, you get it on camera and it's tiny. So there are some physics limitations there, other limitations with sensor quality because they're small sensors in these phones. But the fact that everyone has a recording device in their pocket and the fact that the megapixels and the color palettes are getting so much bigger so fast, that is a giant boon. Again, newer file systems provide more colors, fewer artifacts from image compression, and radar and other technologies, infrared, for instance, those are also moving forward at a rapid pace. So that is my walkthrough on multimodal imaging. Okay.
Very nice, Tim.
Thank you. That, believe it or not, that slide deck was only half done.
Oh, I believe it.
Yeah, but
Outstanding work, Tim. Do you think we could give Curtis a couple of minutes for his update?
yes, Curtis, go for it. That was
Okay,
just
let
a
me-
time
let
filler
me-
anyways. I was stalling.
I think it's better if I could share my screen. If that's all right.
Yeah.
See here.
Do you want me to take down your slide deck?
Yeah.
Okay.
But let's do it this way because I have some videos. So let me know if that's working.
Rock and roll,
Looks like
brother.
It's working. All right. Thank you very much. Let's
Make it full screen if you.
Slideshow mode.
Yeah, there we go. I think it's being a little slow, but it looks like it's getting there.
And
maybe.
Okay. Is the is it you guys see a window within a window?
Yeah.
Yeah, we did.
That's a little weird.
Okay, hold on. Yeah, let's see. Let's see if yellow doesn't work. Let's see if I do that. I'll just do it this way. There we go.
Oh, now it's good.
Okay.
Okay. Awesome.
So, yeah, and I have some things to say about all the physics stuff. Really interesting things, I hope. Anyway, so I updated the presentation a little bit. I gave a presentation in upstate New York this week. Had a flight up there. It's kind of eventful for me. It was a little tough trip, but I survived and got back. So I want to kind of skip ahead and get to the video, but what I'll do first is just give another description of the Mega Drive. This is a picture down at the bottom showing the brass reaction mass support structure, which is a aluminum frame. And what you have here is you have some rods, some bearings or linear bearings, some springs that allow it to like return to center. And these are composite bearings in here, these steel rods. And inside, this one happens to be a 16 disc stack. So it's double the what we have been using up until now. And then on the right, there's an aluminum cap. And that's the way this thing is built. And the operating principle is using the Mach effect, which is something that, in theory, can take it into can utilize transient masses. So what that means is, as you're pumping in energy and taking out energy, electrical energy in this case, and as that's happening, you have a piezoelectric stack where you have expansion and contraction happening at the same time. That change in momentum happening in coincidence with the change in energy gives you a transient fluctuation in the pushback from the rest of the universe, the inertia that the body is experiencing. And so if you time it right, what can happen is that as you're pushing on the brass reaction mass and it's pushing back, if you time it right, you're going to get a push in one direction or the other, depending on the phasing of that timing. So that's kind of just a description of the theory and what we're testing right now. So as you all well may know, that we've been testing this in a vacuum chamber. We've been using a torsion balance that basically has a sort of a non-stable equilibrium. The center, it kind of if you go off center, it kind of pushes back a little bit. We have a magnetic damper. And you can see this entire torsion arm weighs about, the weight is not on here, but it's about 830 or so grams. So that with our device, total amount of mass being moved is about 1 kilogram. And you guys have seen videos of it. It actually moves quite a bit. Let me go to the next slide. Here we go. So basically what we have seen over the last year or so is that we're getting about an average thrust, about 200 millinewtons is what we're seeing when we average things out. And we're not using that much power. So we're based on the piezo driver. When we use that, it's about 20 to 30 watts we input, and about 2 to 5 watts it's dissipated. And again, the device mass itself, just the drive itself inside, is about 170 grams. And in the lab, we can run this as we sweep through. We have a lab, I call it a lab duty cycle. It's not a real duty cycle. The lab duty cycle of 10 to 25%. So this seems like really good results, but I want to put this in context, is that it seems like a pretty high force. Also, the duty cycle is lab, like I said, it's in the lab, so we're not like constantly running this. So I don't really know engineering wise where it's going to go. But we can if we start taking out the heat and doing things like that, we might be able to do better. Of course, it's hard to compare with other drivers because we don't, we're not using propellant, so it's just the energy. So you can't use ISP. You have to use other things like maybe thrust per unit power or something. And we have more lab work to do. So I made this chart basically comparing ion drives, Hall effect drives, and the mega drive using the numbers I just said, which is 250 millinewtons for about 2 to 5 watt range, or 20 to 30 watts input. So that it's off the chart, right? So if you're getting propellant propulsion, it's like efficient. You don't compare with other conventional technologies. Now, one of the things I want to emphasize here is that as we drive this, our drivers, what we're doing is we're sweeping through the resonance. You guys have probably seen that in the old updates in the videos. So one of the things about that is that as we sweep through resonance, the theory predicts that the direction of the force will change. Okay, so how that manifests exactly, that's going to vary depending on the the materials and how they're reacting, but that's essential here, because what we're now doing is we're now going to linear experiments. So this is Michelle Broyles. She's one of our lab partners. This is her air bearing experiment, and we're also going to set up a similar air bearing experiment. And we have some preliminary videos here, and I'm going to play this one first. This is a video. You can see that right here on the left, there's a polyester line. So this is allowing the system itself, it's encased. This is not in vacuum, it's in air, right? We've talked about air and the air effects, but you can see here that there are two foam plates on either side to block any air effects from pushing this entire frame, right? So this whole thing, I believe, weighs about 300, less than 400 grams, including the device. So let me play this video and you guys will see. Now what's on the right, the blue trace is the center of mass, the green trace is the device itself, the red trace is the frame, support structure. And you'll see when the power kicks in, you'll see some stick-slip motion, but you'll see that the center of mass is now kind of going into the left here. So on the graph on the right, down is to the left and up is to the right. Then you can see it kind of pushes to the right and then pushes to the left. And so what she's doing here is going through a constant sweep. In this case, it was 42 to 37 kilohertz over 5 seconds. And you can see that the amplitude of the center of mass, it going back and forth, being pushed in one way or in the other way, continues to increase. And then right here, the power is turned off, and you can see that the polyester centering line starts dampening the motion. Okay, so that's the first video I want to share. And let's go. I'll skip this. This is the raw data with the same video, but with just the Filtech sensor. This thing on the right here, this metal tube-looking thing, that's a Filtech sensor that gives that red trace, that gives us a distance. On the bottom, the middle, that red sawtooth-looking thing, that's the voltage signal, and the green is the current. And then the bottom left, that's the fast Fourier transform of the current signal. So it gives us the phase idea what the phasing is happening there. So now this run is a little bit different. In this run, there were 10-second sweeps, but what happened is after 10 seconds, what Michelle did then is have a constant frequency for 10 seconds. And what you'll notice here is as she goes through resonance, it seems to push in one direction and then another, and then settle down as the frequency is constant, and then it does it again. And it does this several times. You'll be able to see the green. You see how the green like kind of leads and like drags the rest of that along. The green again is the device itself. So one thing I want to say is that as the millinewtons that we are reporting are the average of these things. So we are inputting power, and we're not trying to stay on one side of the resonance yet. We're just going through resonance. So in theory, if we can just stay on one side of the resonance and find a way to keep that side of the resonance, we should be able to extract or see these high impulses preferentially, consistently, instead of going back, pushing one way or another. Now, as we know, with inertial forces, you push, it pushes back, right? That's kind of what we're dealing with here. But we're like pushing, and it's pushing back, and you're doing it one way, and then the resonance changes. So it's turning out that's the trick. And the reason we're able to see this now and see this experimentally is because now we're in this linear experiment. We no longer have as much of this back and forth. Now you'll notice here there is a back and forth. There's no polyester thread, but there is that power cable that comes in. It's a stress relief little cable. So it does have some centering aspects to it. So let me play this video for you guys. And you'll see there's a little dot there kind of traveling through the graph. And that's telling you where it is in the video. And right here is where it takes off to the right, the green. And then you get some crashing around. And then it takes off to the left. And then right there, you have a constant frequency. So it's kind of like just doing its sinusoidal motion, kind of centering. And then again, right about here, the power kicks on. You get a little bit of stick slip, and then the green pushes to the right. Then you get some little stick slip motion, and then you get another push to the left. And then the power is off again for a little while. And then the power gets back on somewhere around here. I'm not sure exactly where. I think right around here is where the power is turned back on. And you see a big push to the right. It's getting close to that Filtech. And then the power is off again. And so a little bit after 70 seconds, the power is turned on again. And you can see the green trace. The device pushes to the left and then flips over, starts pushing to the right really fast. Kind of scratches around a little bit, pushes to the left, and then the power is off. So you can see there's multiple, it looks like maybe multiple even resonance nodes that we're hitting here. So I want to stop and see if, how do I press that? And let's get back to, are there any questions before I proceed?
I had a question about the plot you showed before, because you said it was like 250 millinewtons, but then in the plot you showed it was like 1,000 millinewtons. So I was just curious how you got to that 1,000. It was a few slides back. When you were comparing it to other technologies like the ion thrusters. Okay, so there's the 16x is if you were to do 16, and you've currently tested the 4x.
Yeah, so right now a single mega drive. See, this is taking into account the duty cycle, right? So if you're going to get consistent trust of 250 millinewtons, if you're 25% duty cycle, you need 4 mega drives. So we're taking into account that here. And so you would need 16 to get a Newton, right? So basically I'm taking into account here the duty cycle and the number of drives you would need. That's what this graph is. Did that answer your question?
Yeah, thanks.
Okay. Okay. Any other questions on this? And again, this is preliminary. These are the early results. Michelle's ahead of the game with us. She's the one doing this linear experiment. And is that her doorbell? And one second, guys. I need a minute. Okay, I'm good. Let's see here. So we are, of course, we're working towards testing this with the driver and everything else included, the power source. You know, that's down the road. But initially, what we want to do is do the linear experiment with an air bearing. But instead of a capsule, we're trying to get to a thing where it's a capsulized vacuum, right? And the device is in vacuum in a capsule, or completely in the vacuum. And so to do the vacuum test, we're going to be using these magnetic rails. They came in last week, actually. They do have some roller bearings because of Earnshaw's theorem. You can't get a stable magnetic capture, right, without some feedback. So that's what those are for. So they do have some clearance and allows it, you know, pretty free. It's a pretty low friction type device. The only thing about it is that these things are heavy. This thing is about 1 kilogram. This is the smallest one they make of this type. They have smaller devices, but that are maybe 400 and some, maybe 500 grams. But we're going to try these first to see if they do what we need. The good thing about these is that they can hold a lot of weight. So later on, when we are trying to do experiments with like the rest of the power source and the driver electronics, we can put them all on these rails and see if it actually pushes. Because right now, you know, there could be some electromagnetic vector potential magic happening. I don't know. So we got to do that test. We're still working, of course, on the supports. You guys have probably seen these. These we call them big ears, but I'm still looking at like doing an even bigger one that with a bigger rod. These are 2 millimeter rods. The smallest of the type I want to use, which would like completely eliminate the stick slip issue, would be 8 millimeter. So that's down the road as well. So I just threw in this slide just to talk about the different type of missions you could do with this. And I gave some examples. Of course, I got Andrew's thing down here, right? And as other propellantless type technology. Of course, the Xeno is a super torquer. It uses superconducting magnets to allow satellites to have attitude control, which is a really cool thing. This is a graph that Paul March made about the Mach Lorentz thruster. So in theory, we can get really high thrust with that. So that's something that we're looking to do in the future. Now, what I want to do is I want to talk a little bit about the physics, because, I just, I know that there was a lot of discussion today, and I enjoyed the talks, but I just want to, did I not? Okay, the slide didn't. I just want to point something out, right? So we're talking about, there's discussion about UAPs, like what are they? And if you guys can, hopefully you guys can still see my screen. So I just want to point something out, right? So, I don't know if UAPs are real. Oh, thank you, sweetie. My daughter is offering me an ice cream. So I don't know if they're real or not. I haven't experienced them, and I don't have a comment about all that stuff. But let's say there was something like that happening, right? I want to point out, like, just think about before we knew, like 100 years ago, before we had a theory on nuclear power, right? Think about back then, like what they thought the sun was, right? So there's the sun. You see it every day, and none of physics could describe it, right? People thought it was coal. It was like gravity and some kind of thing, like some supernatural force, right? All these different theories. And it wasn't until we like made advances in physics that we actually had something where we could say, oh, this is a reasonable thing that could be happening in the sun, right? The gravitational forces and the nuclear forces are interacting. And yeah, you could have, it all checks out, right? So I guess my point is this whole thing about, you could throw everything about what we know now at this, let's say we observe UAPs, or we find out, okay, yeah, there's other life and they have these craft, they do stuff. Obviously they're probably not going to tell us. We probably have to figure it out for ourselves. I don't know, maybe not. But the reality is, for us to get it, we probably need to advance physics. And the way to advance physics is not to have a more exact theory of coal, or just like, okay, how can I, compress coal down and its coal is burning, right? It's combustion. It's not combustion, right? It turns out. So if there's something that we observe that's an unknown, it's presumptuous for us to think that the theories that we have now can explain it. And that's my main point that I wanted to make. Anyway, I'll get off my soapbox.
Well, Curtis, thank you, man. Thank you. Yeah, I think, I mean, if we're talking about the UAP phenomenon, I think it is incredibly multifaceted, more than any of us realize on a day-to-day basis, right? Like, okay, if I mention to you like the movie Independence Day, right? Automatically that brings this whole narrative and set of beliefs and set of stories with it. And we all know those, and we all grew up with them, right? And so you see that clip, right, where Will Smith is punching out an alien going, "Welcome to Earth," Okay, well, that's a whole collection of like preconceptions and beliefs and information and all of it. And culturally, we're all indoctrinated in that. And maybe none of it, maybe only a small part of it, has any basis in reality. So then when you talk about UAP, I mean, the thing that makes it tough is that it's so, it's so incredibly tied to, everything else, I guess.
Yeah.
Sorry, I had a call.
And here's the thing. So let's say, and this is one of the reasons I kind of stay away from that topic, is I think that it's a really easy tool for discrediting people. And especially if you're doing something legitimate and you start looking at that and like bringing that in, I mean, things come and go, right? With a political whatever. And so it could be that they're just it's a way to like discredit and slow down people from actually making advances, because I find it ironic that like a lot of the things that are talked about, it looks like it's the right path, but it's like twisted in a strange way, where people aren't like using the thinking like I just described, where, hey, our theories, how do we know our theories are good enough for this? Like we already know that our theories are incomplete, right? That we have like different sectors described in okay ways, but they're not compatible, and we know we have more work to do. And
I think it's people like us that have to change that. And what I mean is, again, you're starting out with observations and mythology, and it's people like us that have to bring science in and take that forward. And the reason I mentioned that was, like they're having congressional hearings about UFOs, right? They just said the UAP fund just had one with Hal Puthoff the other day, or with Eric Davis the other day. Hal Puthoff just did an hour on Joe Rogan, and millions of people watched it. Nobody's doing that for not just alt propulsion. Nobody's doing that for classic science fiction. And with my podcast, I've interviewed a fair number of classic sci-fi authors, and that period of time, unfortunately, is kind of quieting down. It's going away. And so I think part of it, I've been having some deep thoughts on this, is like, how do we stay contemporary, and how do we, this goes to the intersectionality thing, right? How do we, it's like you bring the mountain to Muhammad, so to speak.
Tim,
I
have
think
a thought on this.
Jim's answer is to get something working, and then people will start paying attention.
Yeah.
I also think a lot of this, like, AI is out there now, and we're living in the future kind of, and a lot of this tech just seems like banal and commonplace to people at this point. And like, people are already figuring out trying to figure out how to live with AI and all these other things. And so like they see all these books about it, like, and it's no longer fanciful, it's real. And like, I think that's why like a lot of the stuff that's done well recently, like The Martian or like The Expanse, that has like sci-fi realism for a good part of the storyline, really draws people in now, because they're really grappling with, like, that's maybe why Black Mirror was so popular too, is like people are really grappling now with, like, it's not something that's coming, it's like here, and what do we do now? Like, so we need new simulations.
Michael, I'm right there with you. Yeah. Well, and people are talking about,
like, actually there's going to be probably even a new wave of, like, once people have adapted to this technology and they can start to imagine what the next step is, we're going to probably see even a new wave of sci-fi in like a decade or two that has a new set of concepts to imagine and consider, maybe.
That's where I disagree. In 10 years, it will be remakes and reboots of the Terminator. And
well, that's just the state of Hollywood. That's a separate problem. I'm sure there will be good authors slaving away in their hut in the middle of nowhere, making good books like they used to. But
they'll have Arnold in a wheelchair. They'll he's like,
you know what I want to see? I want to see like a Fast and Furious remake where they're like super old, and it's like the title's like Slow and Steady, and like he just has this like magical power. He just drives normal, and like everything happens around him, and he never gets hit. Like, just Fast and Furious, like that'd be hilarious. But anyway, back to the physics stuff. So Curtis, have you ever thought of like what happens when you get like, instead of just accelerating this object back and forth, what if you like change the magnetization along with, or the electric field or voltage or something along with the acceleration?
That's exactly the dPdt factor of it. So we're putting in voltage, taking out voltage at the same time. That's why it's a piezoelectric stack, at the same time that the material is expanding and contracting. So those have to see. The thing is it can't just be electromagnetic. It has to be inductive, meaning inertially inductive. So the inertia of what the material has to be changing. So you have to have acceleration, you have to have jerks, snap, crackle, pop, all that stuff higher orders of motion happening for the effect to take place, because this effect basically takes advantage of the transient reactions from the rest of the universe. Now, it doesn't detail the mechanism of that, right? There's a paper that Hal Fern wrote, the Hoyle-Knoller theory, and like solve the problem with the infinities that Hawking had brought up, because the universe, you have a horizon, right, even in the future. So there are theories, and then the unified theory I'm working on, of course, that's all built in, because the Mach principle is built into that. So there's definitely mechanisms in there for this effect. So yeah, that is part of it, and that's why, like, when I see a lot of these talks, I see, like, people are focusing on one sector or another, but the transient, like the inertia, is kind of like set aside. It's like a dark mystery that no one talks about.
Yeah, I think in a lot of fields right now, the higher order terms are neglected for simplicity in the mathematics. And then when you add them back in, you get a lot of weird effects like this, potentially.
Yeah.
Yeah, well, the other thing to think about too is when you're getting this info out there, I've noticed a real lag, right? Like even with social media stuff, like especially LinkedIn. God, I have things I posted like 2 months ago that are just starting to get views on LinkedIn, and I'm like, why is that? And it's just people are busy, right? Especially with like the new presidential administration and all the chaos that's going on in DC, and and so it's not that they're not there. It's not that they won't use it, but it's just getting it out there for people. And that's a reason that I'm so appreciative you guys come on and share your updates. And I'm going to put these in my video editor. I will do some cutting up, and I will do some video shorts. So
Curtis, I think it's really interesting what you're saying regarding the UAP topic. And I think, of course, you have a point there, right? But the question is, how complete do you want your description of reality to be, right? If you want a complete description of reality, you cannot let social filters define what you're looking at and what not. Heim said, if anything has an existence time different from zero, then it is part of reality, and it needs to be part of a full description of reality, right? So while I agree that you can be attacked for looking at something which is perceived by a lot of people as a part of reality, also throughout the history of humanity, right? So I might pose this question because I think it's very interesting. If we're able to build a warp drive, how will the UAP phenomena show itself then? Because if we take it serious that through history the phenomena has appeared in different forms, kind of like in relation to the worldview perception of humanity's state at this time, right? So what will it be when we finish a warp drive? This is, I think, the interesting question behind here.
Yeah, the thing is, so my analogy of the sun, right? The sun was something that we can observe. There's nobody questioning, are there suns? It's like it's right there, right? Every day. So it's maybe not a good analogy in terms of like the observability and the repeatability of the observation, right? That it's something that we know is real, whereas this other stuff is like there's still a question. But that's all kind of like a political side of it, right? Where when I say political, I mean like it could be misinformation. It could be the information itself is misinformation to like draw out people that have like good ideas and do something about it, right? We don't know the motives, right?
It could be, right?
Yeah,
but
it could be anything.
It could also be that it's
But let's say it was. What I'm saying is like, let's say it was confirmed that okay, we've let's say it's 100% confirmed, it's repeatable. Like people can go visit a place and it happens, and you can measure it with all those the ways Tim brought up. And okay, we confirmed that these kind of motions can happen. At that point, we're looking at our physics, and it's like, well, nothing here really tells us what. It's like, oh yeah, we can use GR, but then we have to use imaginary numbers and energies that are like non-physical. It's like, no, our theories are not good enough, right? And we know there's problems with it. So what I'm saying is, I'm just simply saying it's likely that our understanding, let's say it is a real phenomena, our understanding of it will likely only come about when we advance physics. That's really my point that I was making.
I totally agree, right? And my push for Heim theory is exactly trying to do this. And I think you're trying to do this, and I hope we are on a conjecture, and I hope someone of us will figure this out, because I actually agree. We need not just to unify quantum mechanics with general relativity. We need the next level, right?
Yeah.
Of
and
understanding.
by the way, I find it ironic that these things I'm looking at in just physics is giving me, and the things Jim's doing, of course, it's giving mechanisms for these type of things to be possible.
You see, the question
it's without assuming that that's possible, right? It's kind of like figuring out nuclear power without knowing the sun is there, right? Let's say the sun was behind some kind of cloud, and we got heat, but we didn't know the sun was there. We could postulate a sun, right? If we knew the physics. So that's kind of like, I think the thing that's sort of happening with my line of research is that, it's definitely possible that there's other things that we can do that are more exotic, that the physics allows for, that don't require these non-physical energies, and but you have to advance the theory in a reasonable way, right? So you have to have a theory that gives you GR, gives you the quantum mechanics in its domain where it does work, and gives you all of particle physics, right, that you see, and has mechanisms for consciousness, has, right, the things we observe, like you're saying, that all has to be possible in the theory.
Yes. And so what I'm posing is kind of what this book, Unidentified Flying Hyperobjects, is posing, right? That UAP phenomena might be showing the next step for some kind of theoretical understanding. I'm not saying it is that way, but I think this is a very interesting idea. And if we are able to build a warp drive in the next decades and in our lifetime, we will be able to test this, because we're going to see how the UAP phenomena is going to show and represent itself then.
Yeah.
And also, we should post this and test this long time, so not just within our lifetime, because
this is why
might really expose this.
This is why I'm so big on detection, right? Because it gives you more to work with. I mean, and that goes for everybody. I mean, everybody here who's building stuff, right? Like the more data we're able to collect, the more you're able to take that back into your lab and fine tune what you're building, So
when I was in college, I had a good friend of mine, a roommate, who we talked about all sorts of sci-fi stuff throughout the years, and one of the things that we thought was like, well, what if the constraints of our universe are more broad than the constraints that we think the universe has, and what if we assume too soon that there's some constraints in the universe that can't be broken, like increasing entropy, time, direction of time, all these things, and then those constraints end up leading to our eventual extinction, like when there would have been no reason to. Then that would be the greatest possible tragedy. Is like there's to have a universe where there was a way out, but we just stopped looking for it too soon. So, or a way to get beyond the limitations that would eventually end the species or something like. So, I mean, I think that we have a responsibility to leave no stone unturned, basically, and hopefully UAP detections and things that are verifiable, solid data can help inspire us to imagine what constraints are not as solid as we would otherwise believe. But we still have to do that hard work of imagining that, you know.
So I would, how would I put this? So earlier, I don't know who it was, one of the speakers brought up, other speakers brought up that, hey, you know, there's so much experimentally that we know now that the guys 120 years ago that figured out QM and GR didn't, right? What that whole body of work, I mean, it's like impossible to even go through, but there's stuff there that if you're doing things now and using even just the same methodology that they used to figure things out, the theory would be different. And just doing that by itself is probably going to advance us. That's my guess. And that's the method I'm taking. And that doesn't even bring UAPs. And like I'm saying, it's looking like UAPs pop out as something that's possible. But the question is, what experiments, what observations are important, right? That's the hard part of this. And this is something, you know, Einstein, he's wrote about, is like, you know, good luck doing unified field theory, right? Picking stuff that you find like, okay, I'm going to take this as fundamental versus that, right? What principle do you base your theory on? It's very tricky, right? You can be led astray very easily, and you know, have blinders on. So even though we have all this extra information, it's tricky. So I'll just say this. So the reason I got back interested, for those that don't know, in the physics theory part of it, is that about, I think it's 3 or 4 years ago now, there was a cosmological paper where they were observing the large-scale structure of the universe. And what they found is that parity symmetry is violated. That means the way galaxies are arranged seem to have a preferred direction. And that's not something that was predicted. And it was a 7 sigma, the paper reported a 7 sigma confirmation of this, is what they reported. I don't know if subsequent papers may have different, I don't know if they were 3 or 4 sigma or whatever, but that's where I got interested again. I said, wait a minute, you know, that's like, that shows us that we really don't, our fundamental theories are, while they do describe a lot of things, they're really not giving us the observations that we have, right? I mean, they're not explaining things. The whole thing about what the redshift is, right? This assumption that it has to be a velocity. You know, that's an assumption. We can't make those assumptions.
Yes.
About the universe.
Yes, I think this is complete. Yes.
It could be some velocity, but it could be more than that, right? So it's really, I think there's like a thing where, like, at this time, you got to step back, look at everything, stop assuming about what we know is fundamental, and like really, like, you know, do some. And anyway, that's where I've been the last couple of years. So
oh, by the way, Curtis,
Yeah.
I finally
Well, guys, I just want to let you know. So I'm going to close things down at 7 tonight. So that gives us about 15 minutes or so.
Oh, thanks, Tim. So I did finally read the interior Schwarzschild stuff. That's a brilliant idea, I think, towards what you were saying. Like, roughly speaking, let's see if I've got it right. It looks so if we're inside a black hole, if the universe is inside a black hole in some sense, then you might expect to see a blue shift because stuff's falling in after you and it's accelerating. But if you're past the event horizon, actually, and the black hole is big enough, then you're actually going to see a redshift because you've been falling into the black hole longer than the other stuff has. So you've been accelerating longer than the other stuff has at a distance because you're looking at it at some point in the past in general. And so because it hasn't had enough time to fall towards you, it actually looks like a redshift, not like a blue shift like you would otherwise expect. So for the interior Schwarzschild solution, you should expect a cosmological redshift. So it's a brilliant idea if I've got it right.
Yeah, and here's the thing. So that's just like, okay, so first order type thing, right? So we're saying for that, for those of you guys that didn't have that discussion with me, what I brought up to Michael was that whole thing about redshift. One thing that I always used to ask other physicists is like this thought experiment about, okay, let's say you were in a massive body and you dug a tunnel to the center, and from the tunnel you shone a flashlight to the surface. Would that light redshift, right? And so I get different answers depending on what people think about gravitational potential and stuff like that, right? So constant mass on a neutron star or whatever. Set aside the engineering, right? Dig a tunnel in a neutron star. But anyway, so if you look at the interior Schwarzschild solution, and we're not even doing the Kerr metric, right? It's the stationary. If you look at the interior Schwarzschild solution, you actually see that as the light leaves the center, there is a redshift. Okay, now that is not a black hole, right? The whole thing about the universe is a black hole, that's just these science communicators really they drive me crazy sometimes. So really it's like, okay, it's not dense anymore, right? You're distant, far away, and it's a very sparse universe.
Okay.
Right?
So,
but there
so
is
if I'm
a
understanding,
density.
you're talking about a general boundary condition. It doesn't have to be inside of a black hole or something.
Right.
Interesting.
So the light is traveling to you, and there could be multiple effects. There could be still some expansion and contraction over time that we don't know that velocity. That could be, right? Because the equations of general relativity allow for that. That's a degree of freedom they have for the field that we associate with space-time to be expanding, contracting over time. But at the same time, with that expansion and contraction, you could have a difference in overall density, where it seems like you have something denser, and out here it's less dense. And so you could have a gravitational redshift effect over long distances. And so that's what I'm saying is basically my point is that just assuming that it has to be all from motion is probably going too far. And what's interesting about that is that the type of curve that you get when you look at the interior Schwarzschild solution is that type of curve that we're seeing, where you get a kind of a R squared type thing, where further away you get an acceleration. And that's what we're seeing at the far end of the universe. It's looking like, what we call the far end of the universe, visible universe. We're seeing that instead of linear, we're seeing a redshift that looks like it goes up with distance. So that curve, matches this kind of explanation of the universe. Now, how much of the density, how much of if it's gravitational, and I haven't fitted all those numbers. I'm interested in cosmology, but not so much that like that's drawing me. I'm like trying to do the unified field theory. Then later we can deal with the cosmology stuff. But yeah, that's what Michael was referring to.
Gotcha. Thanks for that clarification, Curtis.
Sure.
Looks like I have a little more to research there. All right. Is there anything else we wanted to chat about? I think we could probably.
Yeah, why don't we wrap things up? Okay, well, I will do that, guys. Thank you all. This has been one heck of an event. Yeah, give yourselves an enormous hand. Amazing work. We burned through a lot today. Okay, well, let me close things out then. Let me see. I'll do solo layout. This is Tim Ventura. This has been APEC for May 10th, 2025. I want to thank you to everyone who presented. We're doing one in June. We're going to push that. Usually we do once every month. I try and keep that fairly consistent. I'm going to be at the SCU conference again, explorescu.org. If you want to attend that, that is coming up, explorescu.org in early June. So we're going to move our next APEC probably about a week out. So thank you again, everybody.